sign in the morning session and before leaving in the evening. The attendance sheet will be circulated to you in this hall. So we are not quite happy for the attendance. So now we will be beginning the session A4 and A5. I request the session chair is Dr. Mandira Sreshtha, and the rapporteurs for this session are Nishchal Sharma from IISER Mohali and Athira Jose from IITM Pune. So I request Dr. Mandira Sreshtha to please preside over.
Well, thank you very much, and very good morning. Good morning. Okay, great. So I hope you all had a very nice evening last night. I think it was quite interesting with a lot of rain, but also very nice music and people around. So thank you very much, Dr. Sanjay and the organizers, for such a good evening. Today, I think we continue with the presentations that we had yesterday. We had quite interesting presentations on the modeling aspects, if you all recall the last few sessions that we stayed on. And today we have the session, as was just mentioned, A4 and A5. So this particular session is very much going to be dealing with regional climate modeling. And I think this is one of the important sessions for us, particularly in the context of the various models as well as the data that is coming out, particularly for my context. I mean, I've been always, contacted in terms of getting data, the CORDEX data with the region, the CMEP6 data sets, the downscaled. So I hope that is also going to be covered, I hear, in this particular session. So we have 4 presenters in this session. The first presenter that we have is Dr. Swapna Panikal, and she's going to talk to us about Earth system modeling in the regional context. And I think you will hear an update on what I just mentioned in terms of the downscaling for CORDEX. Let me just give a short introduction of Dr. Swapna Panikal. She is a senior scientist at the Center for Climate Change Research here at IITM. And she's leading the work on IITM Earth Systems Model Development and Research. And also, I'm very pleased, and also you'd be delighted to know that she is a lead author of IPCC Working Group 1. Some of us might not know that. So of the 6th assessment report. And she's also the member of the Working Group on Coupled Modeling of WCRP and the member of the Safe Landing Climate Lighthouse activity. Well, I'm glad you're also involved in the Lighthouse activity. So let us welcome Dr. Swapna, and you have 10 minutes for your presentation.
Thank you, Chair, for the nice introduction, and good morning, everybody. Myself, Swapna Panikal. I am from the Center for Climate Change Research at IITM. So in this talk, I will briefly discuss about the Earth system modeling activities that is being carried out at our center, CCCR. We will be focusing more on the regional aspects. That means that I'll be focusing more on the Earth system modeling activities and the focus on the South Asian monsoon region. So just a brief introduction about the IITM Earth System Model. This is a global coupled model, and it is having an atmosphere global forecast system, GFS, and the land model is NOAA LSM, and ocean is the modular ocean model, version P1, and it is having an interactive ocean biogeochemistry as well as interactive CIs. So a brief history about the IITM Earth System Modeling, like we have with under the protocol, or we were using the climate forecast system CFS V2 for the seasonal prediction at IITM. So with the idea, like we will be using the same framework across the modeling scales, like starting from the short range to extended to seasonal, and for the climate change, we'll be using the same framework for the climate change assessment, climate modeling. So we adapted this model as the basic structure for developing our IITM ESM. However, this model is a seasonal prediction model. So we for a climate change simulations, we need to ensure that we are able to have a radiatively balanced framework, so that we can have the long climate simulations and we can assess like how with the increase in the radiative forcing, what are the changes that is going to happen in the climate system. So with this view, because it was a seasonal prediction model, it is not having a radiatively balanced framework. So in-house development have been carried out at CCCR. Like first we have changed the ocean model to MOMFO P1. That is like, it is having an interactive biogeochemistry. In addition to that, it is having a better ocean mean state compared to the previous version. And also developments has been carried out so that we are getting a radiatively balanced framework. So once we assure that the model is ready for the climate change simulations, then we evaluated the model for the mean state and the variability, and to also address like how the drivers to the monsoon are produced in the model. Then we have participated in the CMIP 6, and it has also contributed for the recent IPCC AR6 report. So this was, I was talking about like when we developed the model, first we looked at the mean state and we see like how is the radiative balance at the top of the atmosphere. So present day we have an about 0.5 watts per meter square imbalance, and the left panel shows the TOA balance from the present day control runs, and we are about a 0.8 watts per meter square at the top of the atmosphere. Then once we have a radiatively balanced framework, we also see like what are the drivers to the monsoon, whether how are they captured in the model. So we know like ENSO is the major component that is producing interannual variations in the monsoon. So first we looked at the mean state and how the ENSOs is captured and how the ENSO monsoon association is captured. And the panel, the curve, like the black and blue curve, black is from the observations and blue is the from the model. It is the lead lag correlation between the NINO 3.4 and the ISMR. Again, we can see like during the ENSO years, generally the Indian summer monsoon is below normal, but that negative correlation is well represented in the model. And another, we also looked at the different other modes like AMO, PDO, and NTA. This also has very important links to the monsoon variability. So our students have different publications that have come out recently, like how these modes are affecting the monsoon over the region in the global couple framework. And another point I would like to highlight is that IOD, the Indian Ocean Dipole, you must all be aware. So it is like a pattern of sea surface temperature in the Indian Ocean. That is again a mode, like it has a dominant impact on the Indian monsoon. If you see for the 2023, the present year, we know like the El Nino is developing and it is maturing. And what we expect is that the monsoon rainfall will be deficit. But we see that this year, yesterday, and this 20 September, we got a good rainfall. It is an impact of the ongoing IOD. So that representation, like how the, if once the El Nino is there, if IOD also happens, how the monsoon will be getting affected. That is an important point we need to address even for the climate change projections also in the future, how it is going to change. So that is also being represented. So when the monsoon is there, generally all the CMIP 6 models shows that because of the strong influence of ENSO, all the models shows a deficit rainfall over the Indian region. But this is the Taylor diagram, which shows like IITM ESM that is marked in red and the NESM 3. These are the two models which shows like all the models produces their dipole pattern in the SST, but when you look at the association to the monsoon, they are not able to capture those associations. So these two models from the historical simulations, they are showing like there is a good association to the monsoon. So being assessed like all the modes of variability that is related to the monsoon are well captured in the model. We have performed the CMIP 6 simulations. So this is the CMIP 6, what we have contributed. The central part, this is the DEC simulation. That is the mandatory set of experiments every modeling group has to contribute for participating in the CMIP 6. So we have carried out the DEC simulations and also different MIPs. MIPs are the model intercomparison project. These are being done to address any specific scientific questions, whichever we are interested. So we have also carried out various MIPs. Again, the focus is on how the monsoon, what are the contributions of the climate change to the monsoon. So we also perform various MIP simulations. And all these data sets we are already published through the Earth System Grid Federation node that is sent at CCCR. And also the CORDEX data set, which is downscale products from the CMIP 5, is also being published through the ESGF server situated at CCCR. The students are welcome to use the data, which is publicly available. And we have also looked like what are the changes, that projected changes over the Indian monsoon region. This is again based on the IITM ESM CMIP 6, CMIP 5, and also the CMIP 5 models. And what we can see, like recent IPCC report clearly mentioned that we will be globally, we'll be crossing 1.5 degree temperatures in the coming decades. And what we see for the Indian region, like if we go with the median emission scenario, like we will be having a temperatures between 2 to 2.8 degrees over the Indian land region by the end of the century. And if you go with the high emission scenarios, it can cross even 4.5 degrees centigrade. So these assessments, this model, because we are having a model and we did the projections, we have contributed to CMIP 6 IPCC, and the model is also used for assessing the climate change over the Indian region. So question comes, like, if you see the CMIP 6, there are more than 100 models they have registered for CMIP 6. And if you see like more than 50 models data is available through the Earth System Grid Federation nodes situated across the world. So what is the need for the regional modeling? So we know like GCMs give a valuable information, but we see like if we have to have a very regional specific information that is very much needed for the decision making and policy making at the regional levels, we have to have a regional climate models. Why? Because it is very computationally expensive to run the high resolution models globally, especially the climate change simulations. If you need to carry out for long up the 21st century and by the end of the 22nd century, it is computationally very expensive. And this is just an example I have given from the added value what we get of CORDEX. Left panel is from the CMIP 6 and the right panel from the CORDEX. This is from the IPCC technical summary. And this is the Tmax, maximum temperature, projected changes in the maximum temperature exceeding 35 degrees. And we see that there are certain regions and all the colored shows that models are having a good agreement, and the hatches represents models does not agree in the pattern of change. And we can see like the CMIP 6 models, there are certain regions like North America and all, we can see like the CMIP models, global models are not agreeing in the sign, but we get some added value from the CORDEX simulations. And also there are studies, they are telling like these GCMs are used to drive the regional downscale the climate models. So when we select the models accordingly, when they are able to capture the better features, mean bias, then bias, if you use the RCM to downscale, the bias can be reduced. And also like there are high-res CMIP simulations available again from CMIP 6. They are spanning up to 25 kilometers. And if you see the revolution from CMIP 5 to CMIP 6, both in the atmosphere and ocean model, there is a larger increase in the resolution we can see. So models are going with the higher resolutions, but again, it is computationally expensive. If you see the high-res simulations, the tier 1 simulations has the historical up to 2014 and the tier 2 will have up to 2050. But we don't have any data till now available by the end of the century. So if we have to have a long climate projections, we need to have some RCMs. And the activity that is being carried out at CCCR. So as I told, we have used a coarser resolution model about a 2-degree atmosphere for the CMIP 6. We are also moving towards a high resolution modeling. So previous version is a 200 kilometers. Now we have implemented a TCO grid, that is a triangular cubic octahedral grid. Why we have implemented? Because we need to have a compromise between the computational resources, data storage. Also, we need to have a high-res simulations. So using this grid, one important point that it will reduce the number of points near the polar regions, but we'll have a more high resolution near the tropical regions. So we will, our region, we will get a better resolution. So that is the one advantage with it. We go with the TCO. And again, we are refining the ocean component so that we will have a nearly 1/4 degree ocean, which will be coupled with around 67 kilometer atmosphere. So this will be our model, which will be participating for the upcoming CMIP 7. And also in addition, because we are prescribing the vegetations, but previously we have used a Hurt et al. Data with the 13 vegetation types. It was very much coarser over the Indian region. Now we are implementing the NRC LULC data set with the 24 vegetation types. So upper panel on the right side is the previous vegetation type that was used in the CMIP 6. And the down panel shows the 24 vegetation types with a 67 kilometer. So we see like the vegetation types also, there are a lot of changes over the Indian region. And this is the precipitation change. We know like all the CMIP 6 models produces a dry bias over Indian region. So what we see is that when we increase the resolution and when we change the proper LULC over the Indian region, the precipitation biases are getting reduced in the new version. And also, like, we also should have, like, we are focusing, it's a global coupled model. All the teleconnections are very important. So as an addition, we are trying, like, there have been melting over the Arctic regions, Greenland, Antarctica, all the ice has been melting, how they are impacting our region. That also we are addressing. So presently we have included the Greenland ice melt into the region, and we will be slowly implementing, like, what are the Himalayan cryosphere, the changes of the Himalayas, how can we be coupled to our region. So the lessons learned and way forward, we need to have high resolution models for the regional decision making. And at our center, we will have a high resolution 27 kilometer AGCM version of IITM ESM, which Dr. Sabin will be presenting in the coming session. And we will have a couple model with 67 kilometer over the region, so that we will have a more regional focus over the regions. This will be our upcoming to the CMIP 6 and IPCC. Thank you.
Thank you. Thank you very much. So we'll take 2 questions. If you have any questions for Dr. Swapna, please. Yes. Wait.
I think obviously very nice work, so no need to say. Only my concern was that you have done a lot of tailoring of the radiation over the oceans and all. And did you take care anything about the atmosphere and do the budgeting separately about atmosphere and ocean?
Yeah, generally we did that because it is a coupled version. We cannot only do the atmosphere and ocean.
Correct.
So that is how we used whole coupled framework. And what we look at is that what is the radiation that is reaching at the top of the atmosphere, and what is the radiation that is reaching at the ocean surface. How they are, we should ideally, when we have make a difference, it should be 0. So that will not go into the accumulate in the atmosphere and it will not work. So that is the point we made sure, like, there is no imbalance between the top and the surface of the ocean. So what is going into the ocean is also important.
This is around 0.8 or something.
No. Up and down is ideally 0.1 for us. Top of the atmosphere is 0.8. Some part is taken by the ocean. So difference is ideally should be 0.
Yes.
It's a very nice presentation. You are doing a lot of things. Yeah, you mentioned that if you provide your own land use land cover data, it improves the precipitation.
Yeah.
So I'm wondering that the land use land cover, the data I prepare, what the resolution? Is it 67 or different?
No, this is from the NRSC. They are giving a very high resolution data, but for our grid, we have to again, we have to come down to our grid. So we have remapped it for a 67 kilometer for our region, but still with 24, and all the vegetation types are getting changed because we were using an IGPP classification. Now we are moving on to USGS, and it is having a 24 types. So different crops, because if we move from the pre-industrial to the present India, crops are getting increased, and different types of crops are there in our region. So that type of different types of crops also are better represented. So
means the feedback.
Land atmospheric coupling is getting improved. Yes.
Thank you.
It is a prescribed, but when we prescribe the vegetation, we change everything. The albedo will get changed. So the land atmospheric coupling gets affected.
I'll take just one more question and then we go to the next presentation. Yes.
Yeah, thank you very much for your excellent presentation.
Thank you.
Can I have your thoughts about the future perspective to implementing the biogeochemical cycle and the dynamic vegetation scheme and ecological schemes in ocean and so forth?
We already have a biogeochemical chemistry active in the ocean, but our plan is that we need to have a full carbon cycle. So we will be slowly moving towards a carbon cycle implementation in the model. So that is the next step of development, what we are planning. Thank you.
So thank you very much. I actually had a question, but I'll take it later regarding the cryosphere, including the cryosphere too. That is interesting for us. So thank you very much. A round of applause for Dr. Swapna, please. Okay, so we'll go for the second presentation. And our second presentation is on regional climate modeling in the framework of CORDEX South Asia. And we have Dr. Sanjay already. He's, of course, all of you know Dr. Sanjay. So I think I do not need to give you a very detailed introduction to him. But I think it's very important also that he's the program director of the Center for Climate Change Research Institute here at IITM. And then his specialization is on regional climate modeling. And he's also the point of contact, as you're aware, of CORDEX South Asia and a number of other, I think, with the team, with also the CORDEX Science Advisory Team. Yeah, he's also a member of that and a contributing author, CA, of IPCC Working Group 1 of the 6th Assessment Report. So are we ready with your presentation?
Yeah.
Okay, good.
Thank
So
you
all
very
yours.
much for
You
that
have-
introduction. And I'll be much shorter than what Dr. Swapna was presenting, because most of this thing, our activities have been the overview you got from Professor Federlin in the keynote talk. So I'll just add some more details to that. So what was our contribution to this regional climate modeling in the framework of CORDEX South Asia? So this this slide also you have seen yesterday. So here actually we started this CORDEX activity in 2012 when the WCRP started this activity. The activity was not in the Asian region. So we were the first to commit to this CORDEX activity. And that time it was mainly looking at the coordination of this, so that it is not only about dynamical downscaling using regional climate model. It can be any method of downscaling. CORDEX is open to any method of downscaling to get a local scale climate information. How to improve the local scale climate information. So that's why what two methods we now know is, one is dynamical downscaling of the global models with the regional climate model, and the other one is the statistical downscaling. Yesterday we saw some talks coming of new methods for dynamic. So that's what the students have to look for. What our requirement is to have a local scale climate information, which can be reliable to give for decision making. So in this activity so far, what our contribution had been to downscale the CMIP5, the coupled model intercomparison, the phase 5, which was used in the earlier IPCC report, to downscale it to a 50 kilometer using a regional climate model, the same ICTP REDCM4, which is the most popular model. And then we did some 6 downscaling. That's what I was from IITM. So this slide also was shown yesterday. So I'll just little more detail. So what it gave the opportunity by doing this is, a lot of publications have come out on evaluating these results, and everything is not very positive. There are issues. So we learned that other than using some other models and learning about the uncertainties in our monsoon region, we could see that actually this is not what the user is looking for. There is much more need to be done. So this is not a developmental activity. This is a more application type of thing. So we try to tune the model before going into the projections, but we don't do a further development of the model. So what it gives is, we can quantify the uncertainty. What is the uncertainty in due to different sources, like different model formulations, different scenarios, and here we are focused on the South Asian monsoon region. So we are trying to see which model is going to give the relatively better picture of our monsoon. So that's why these papers, so whoever is interested, on our website, all the publications are from all our partners are there. And this slide also now Dr. Swapna showed. So this was one where we could apply the CORDEX also, other than the CMIP and data. So here again, we could see that tell that the warming over Indian region for the high emission scenario will be around 4.4 with a range 4 to 4.9. That's where the ensemble comes into picture. that actually we can see with a regional model at a higher resolution, relatively higher resolution than the global model, that the range which is expected range for a high emission scenario, which we know that it's not going to happen with all the governments taking the good policy decisions. This may not happen, but at the higher side, it will be around 4 to 4.9 degree warming. And also you can see for the sea surface temperature things also is shown. This is coming from the CMIP, like what Dr. Swapna told. This is not a CORDEX. The land temperatures and the ensemble, we could do the spread, we could show. So these are the advantages of having a ensemble of regional simulations. So all this data has gone into, as Dr. Swapna told, and this was also shown yesterday, 22 simulations. Totally, there were 26 simulations have gone into the Earth System Grid Federation, a data server which we have installed here from. First, we installed it for the CORDEX activity, and because of this, our involvement in the CORDEX activity, we could take up this, and this is maintained by none other than Sandeep Ingle, who is looking after this entire the IT thing here and managing all our IT things are there, and so he is the backbone to doing this system grid federation. And now we have published our out of this there are 6. So there are six simulations from here. All these things you can later see it on the CORDEX website. All these are published there. All the links are given there. And later, this data for use in IPCC, it has gone into the Copernicus climate data store, where a subset of the CORDEX data has been published. And that is what has gone into the IPCC one interactive atlas. That is that is where actually you can also, you have open access to these data sets. So they have visualization. You can see the below. I have given the link. So that is the IPCC chapters had a chapter on Atlas chapter, the last chapter, where they're talking of each regions, and any region you can see from basically from the CMIP 5 and CMIP 6 and also the CORDEX data set. So this all our contributions has gone to IPCC through this. And here, as an example, Dr. Swapna showed you one extreme index, the warm days index. Here I'm showing the extreme precipitation index. That's one common index, RX 1 day. It is called 1 day. 1 day precipitation, annual maximum 1 day precipitation. So how you can just visualize in the top panel it is coming from CMIP 6 ensemble, in the middle panel from CMIP 5, and in the bottom panel is from the CORDEX South Asia. So this is where the CORDEX is giving a much larger extremes. Whether it needs an evaluation, whether it is properly giving or not. So that is one more feature of this atlas. But here only thing is we are not talking about the individual models, it's the entire ensemble. But we can see that actually you can pull that data out, this NetCDF data, and you can do your own analysis. So here what I have done is what we have done is over our Indian region, we have we have clipped it over the Indian region and seeing and trying to compare it with the the left panel is from the India Meteorological Department. The middle panel is from the Aphrodite data, that is the regional data available over the Asian region, and the right panel is from the HADEX, that is the common data coming from the UK Met Office. So I'm not getting into the detail. The thing is, when you see the bias with respect to the Aphrodite in the bottom panel, you will see the brown colors, seeing that there's a dry bias in the CMIP 5 and CMIP 6 ensemble. While in the CORDEX ensemble, you don't see much, although in the west, closer to the west coast, you see a dry bias, you don't see much. So the bias has reduced. So this kind of assessment can be done before you use the projections. And now to get it into a finer scale, the right-hand side, I've shown the same pictures for the southwest coast, the Kerala coast region, how it is represented in the CMIP 6 and CMIP 5, the middle and left panel, and the right panel shows what is coming out from the CORDEX. So you don't see the bias is in the other side. It's like slightly wet bias is there. So the same thing you can see, say when you look at that finer scale for CMIP 6, CMIP 5 and CORDEX, we have seen it in terms of the near-term future, the changes for the low, medium and high scenarios. All these things are not that actually, these are all the data you can pull out from the IPCC Atlas, and you can do your own analysis. So you can do your own. So here I have used the GRAD software, and then we have done it. So the main point I want to tell is what it shows is that analysis of the multi-model ensemble mean global and downscale region projections implies that the scenarios with low GHG emissions, that is RCP 2.6 for CMIP 5 and SSP 2.6 for the CMIP 6 would lead to substantially smaller changes in this precipitation extreme index beyond 2040 than under very high GHG emission scenarios. So especially for this Kerala state, that is the southwest part of the India. This kind of assessments you yourself can make. That's the point I wanted to. I don't want to take much more time. Yeah, one more thing is that is, see, although this is coming from the ensemble, that doesn't mean that there is no uncertainty. Now, if you see, what we saw is the mean, the arithmetic mean. Now, when you see the median, you get almost the same picture in the middle panel. But if you take the 5th percentile of this ensemble of CORDEX simulations, you get that there is a degrees, the future changes a degrees in this extremes, while in the 95th percentile you get a large increase. So this kind of uncertainty has to be communicated when we are providing this data set to the decision maker. So the challenge what has come now, as IPCC also has pointed out, there is a high confidence that climate services has set a new scientific set of scientific challenges to the physical climate research. That's what we have to understand. These data sets, CMIP or CORDEX, is basically for climate research, but now we are using it for climate service applications directly. So this is what this conference also needs, actually, how to do it, how to communicate, because this uncertainty is there. We are trying to reduce the uncertainty through our model development, like what Dr. Swapna mentioned, because this CORDEX depends on the global projection. The better the global model, yesterday also we heard many of the talks telling about the large scale conditions, the better you get the regional scale information. So that's the point. Yeah, the more detail are there. That's the point I wanted to mention. And this again was told, this is another activity we are involved in the convective permitting over the Tibetan Plateau region, the third pole region. So the first paper was discussed by Professor Fedlin, as well as in one Giulio Curo from this flagship study had presented the paper. So we were part of the initial case studies, and the first results from the multi-model multi-physics ensemble simulations of 3 case studies show high performance across a range of meteorological situations and are close to available observational estimates in simulating precipitation. And so this is also just overview. Yeah, I'm over. So this was just a overview paper, because the main constraint there is observations. So what they showed is that there is a large observational uncertainty also over that region. So when you go to convecting, permitting, modeling and all that, that is also going, how do we evaluate these things is going to be an issue. That's my final slide. So these are just the links to show that where our data set, the ESGF data set for the global CMIP 6 contribution, which Dr. Swapna mentioned. And also we had made a data extraction tool, which had been used by many people who don't need the entire South Asia region data. They can do it. Thank you very much. Thank you.
Yeah. So thank you very much, Dr. Sanjay. Just one, yeah, you have just one question. So you get this one.
Thank you for your very informative and very important presentations. I think policymakers will get more information from this presentation. Just a small question. You have shown dry bias slide in the CMIP 5, CMIP 6, and CORDEX. So are those considered with the IMD or all others, Aphrodite and others? Information.
Here, that's what I showed. I showed from the India Meteorology Department, Aphrodite also, but here the bias is with respect to Aphrodite.
Aphrodite. Yeah. So Aphrodite means up to 2015.
Period, I don't know, but yeah, but that 1986 to 2005, that was the evaluation period in the earlier, because these are all little previous results.
Sure.
And just I wanted to, this point was to demonstrate the feature of this interactive atlas, because where we all have contributed. So these are open, any student can go and then have a look at it. And then,
thank you very much.
Yeah, so thank you very much. A round of applause for Dr. Sanjay, please. So we go to the third presentation of this morning session, and the presentation is by Professor Pankaj Kumar. His presentation is on a regional Earth systems modeling framework over the CORDEX South Asia domain. And Dr. Pankaj, he's with, let me just look at his bio real quick here. Yeah, so Dr. Pankaj, he's an associate professor at the Indian Institute of Science and Education and Research at Bhopal, India. And then, yeah, so I think you please go ahead with your presentation, because that's more important. Yes, over to you.
Thank you very much. So what I'm going to talk about the regional Earth system modeling framework over CORDEX South Asia region. That's what we are trying to aim for. And largely what we are working, I'm working on this topic last 4 or 5 years since this Lund conference of CORDEX happened in 14 or 15. That time, initially, first time I presented the results. So obviously the context, to set the context of this talk, we are warming like anything, and obviously this 1.5 degree, which we say we are going to cross very soon. Even the land temperatures were above 1.5 degrees over the last decades. Also very well known that the cold nights or the cold days are warming much faster than the other parameters of the temperatures. Excuse me. And then obviously the greenhouse gases are the main driver, and obviously in our language we call it as virtually certain, almost 100% sure that they are the main contributors. And the important point which we should be clear, that the South Asian countries are projected to be vulnerable to the most extremes, and that's what we are witnessing nowadays. And if we talk about how we are dealing this, so we are dealing this currently with the Earth system models under the IPCC umbrella. And obviously these slides are from AR6. Obviously in the warmer temperature, we are more vulnerable to the extremes. The extremes, either the hot extreme temperature extremes are on very high, sitting at very high end. So this all what models are predicting or projecting, what we are witnessing as well. One of the important thing from our perspective is that at least 12 coastal cities in India is projected to be having flooded by a meter or two, a couple of feet, and our larger economic interest lies on our coastal areas. So that's also is very important that we know the information at very high resolution. If you remember Dr. Sanjay's talk, these regions, global models have limitations. And who are the people who are global? If we look into the vulnerability kind of assessment, so who are the kind of emitters? No? So you see that the high emissions are coming from the West, and they're doing this since the industrial era, last 150 years or so. And who are the sufferers? So you really see that the most vulnerables are the African, Asian countries and all those people. So all are going in the very well in the projected or stated statements that the South Asian regions in particular are very vulnerable to the extremes. And now coming to the Earth system modeling, obviously it's a very challenging task. Dr. Sapna has already briefed you about those things. We have atmosphere, geosphere, hydrosphere, biosphere, They all are interacting in real time with endless array. And we have to understand the physics and dynamics and then thermodynamics and then parameterize and then made them to talk to each other. All these processes, very few processes are listed here. That's what has to be taken into account when you are doing all those exercise. And also the whole ocean and the whole atmosphere should be taken into account when you talk about the Earth system modeling and all those things. So what, coming to the topic, so what Earth system model which we are using right now. So we are running a atmospheric model, regional model REMO, which we are running at as I said, I'm running since last 5-6 years, with REMO last 20 years. But we are running at different resolution, 0.44, 0.22, and 0.11, very high resolution. And we are running over over the CORDEX South Asia region. This is the CORDEX South Asia region, and it is also coupled to a global hydrological discharge model, which is a resolution of 0.5 degree. Then we have a full global ocean model of MaxLink MPIOM, which we are running at a variable grid. It has also a stretch grid option so that we can play around with the grids and zoom in and over the region of the interest. Region of the interest. So over Indian Ocean, we are running over Indian Ocean. We are running at the coastal areas. These are around 5 kilometers, and over here around 20 to 25 kilometers, and the rest of the places where it is not coupled up to 1 to 1.25 degrees. So also we have a direct two-way nesting. So feedbacks can go from one domain to another. Then we have full marine biogeochemistry again from the MaxLink, and the coupling frequency for regional model to the ocean model is 3 hours, and regional model to hydrological model is per day. Simulation we did for reanalysis and historical simulations for this period, and 60 to 2000, several RCP simulations for this area. For 0.11, we only have done so far the reanalysis simulation for last 30-40 years, but rest 0.22 and 0.44, we have several RCP simulations for South Asia, coupled simulations. So now, just to give you an overview, Dr. Sanjay also tried to give you this point, so I will give you from a different perspective. So what is shown here is the ensemble of CMF5 simulations, which is roughly around 150 kilometers, and then CMF6 simulations, which is roughly around 100 kilometers or so. Then all the CORDEX simulations, which is roughly around 50 kilometers. Then the regional model, which I'm using, is roughly 25 kilometer uncoupled version. And then regional Earth system model, 25 kilometer, a regional Earth system model at 12 kilometer. Without saying much, you can clearly see the improvement in the settings. The 2-3 points which were also highlighted. One is that the dry bias, which you see over the Indian region, is persisting even in the CORDEX simulations as well. Obviously, the intensity is less. That's what is shown. Also, if you do the difference, you will see some improvement here, even regional model. And another interesting point is that all the models tends to overestimate precipitation over the ocean, especially the regional models. And when you come into the Earth system modeling, regional system modeling, the precipitation bias significantly reduces of the order of 20 to 25%, which is a very interesting result. And the same thing, I just zoomed in for India, and we clearly see that the improvement on all the regions, which we see that the dry bias is there, but it has significantly reduced in these areas. So we look into the interannual scale, now intra-seasonal scale also we wanted to look at. Then we looked into the ITCZ, which is the main feature for them during this season over South Asia, because we are only 3 months we get water, and 9 months we are dry, and main water resources is monsoon. So when we look into the ERA 5, that is our benchmark with respect to 0.11, 0.22, standalone RCM and CORDEX and CMF6. So what we are looking at the migration of ITCZ in different in all these models, and what we see that the 0.11 degree was able to capture those precipitation extremes in the north compared to the standalone RCM, which is precipitating too much, or CORDEX, which even we don't really get the precipitation maxima in north and all those things too much over the ocean. And obviously CMAP6, difficult to get those things. Again, to highlight the point, one interesting point is that the ERA interim, that is our forcing model, is sitting here. And when we talk about the 0.25 and 0.11, the model is showing even better simulation than the ERA interim simulations when we are looking for the precipitation signal. So the simulations are even improving with respect to the forcing model. So to conclude to this slide, regional Earth system modeling framework showed very high skill for the climate studies over South Asia region. Then I have 1 or 2 slides to quickly tell from where these improvements are coming. So not all, but at least 1 or 2. So one is that obviously ocean has a very strong role to play in our region because we are surrounded by the ocean, and air's interaction plays a very important role. And LPS, which are the main contributor, especially to the north, where we see the dry bias and all those things, they are not very well simulated in either settings. So when you have the good ocean response feedback, the LPS, the low pressure systems, are well represented, and their response is less over ocean and more over the land. And then obviously the atmospheric heat budget also is improving. Black is observation. This is regional system model, and this is only regional model. And everybody wants to know what is happening to SST. So SST, if we look into the forcing SST, is the global model with respect to the observations. The MPI, the root mean square error, the biases are large in the global model. With respect to the regional model, is less. And when we look into the differences, the improvement is of the order of 20 to 40, even 60 degree to the forcing SST. The regional model improved those things. So this is the last slide which I have, just to see that the improvement with respect to 0.11 and 0.22. So what we are looking into the observations, TRMM, the migration, this northward propagation bands. So we would expect these kind of structure, not going into deep. So the 0.11 degree was able to capture this propagation bands very accurately or much precisely, even better than the 0.22. But when we look into the other model like RECCM or CCM or RCA, they really show limitations in capturing those things. So the interesting point to highlight is that the regional Earth system model at very high resolution at 0.11 degree will be a very good choice, at least to address our regional climate information and all. And then further, if you really want to go to another scale, then you can use other methods like AIML and all those things to go to a scale of a kilometer or so. Thank you very much.
Thank you very much, Dr. Pangu. So if you have any questions, yes, we have one question here. There's the mic there, please.
Thank you for showing very promising results from regional Earth system models. Yeah, so definitely there are improvements in regional Earth system models. Is that just because of downscaling to higher resolutions, or implementing some other techniques like spectral nudging to stabilize the model solutions?
There are two things actually. One is that obviously downscaling does not improve much because we have seen. Another interesting point is that we are coupling it. So coupling improves the things on adding to the better regional physiography. So both are playing role here.
So coupling here means atmosphere, ocean. I see. If I recall your slides zoomed at Indian scale, I see a lot of improvements everywhere else except the Northwest Himalayas, especially Jammu, Kashmir and Ladakh. From 100 kilometers to 11 kilometers, I think the bias is safe, still wet bias.
I think that's a very good point to highlight. There are two things actually. The regions, especially where you have very low amount of rainfall. So when you do this kind of percentage bias, the shooting will be very high. So if you look into the magnitude difference, then the differences will be very less. So I only showed the percentage bias here. So if there is a 0.5 to 0.7, then you have a 50% increase, or 0.5 to 1. So then if the bias is, if your Rajasthan is receiving 0.5 millimeter per annually, and your model is showing 1 millimeter, then you have 100% bias. But in terms of rainfall, it is very less. Apart from that, that's one excuse as a modeler I make. And the second is that the observation is literally nothing there. So
yeah, this is where I'm coming from.
So it's when I give the glaciology talk, I first show the observational network, then I show my result.
Yeah.
Thank you.
Yeah.
Just one point, real quick though, because we don't have time.
Actually, I missed Dr. Pankaj Kumar also is a contributor to our CORDEX data set. So I request him to also with this regional system model also consider for CMIP6 downscaling also.
Sure, I will.
That is one thing. And the other point I missed is actually our CMIP6 downscaling activity, other than Dr. Sabin will be presenting a high resolution, and Dr. Suraj will be talking on our efforts to do with the RedCM5. So he will be also talking. Thank you.
But I was wondering why that didn't come earlier. So thank you. Thank you very much. A round of applause for Dr. Pankaj, please. Okay, so we have the last presentation for this particular session. And let me invite Professor Lalu Das, and he's going to talk about the traditional MLR and advances in machine learning-based statistical downscaling and reliable tools for providing accurate inputs to the crop simulation models. So this is also for application purposes. And so Professor Lalu Das, he is a professor at the Agriculture, Meteorology and Physics Bidhan Chandra Krishi Vishwavidyalaya, India, of course. And he's been working also earlier with the Japan Agency for Marine Earth Science and Technology, JAMSTEC at Yokohama. And he's also the point of contact for WCRP South Asia. So over to you, please.
Thank you very much for this nice introduction. So very good morning to all of you. I am going to talk traditional multi-linear regression based on advanced machine learning based statistical downscaling. This is basically a tool for regional impact assessment. So from yesterday onwards and still just previous lecture, we have learned a lot of things regarding the downscaling. All are based on dynamical downscaling. So I am the only man who is basically going to speak on statistical downscaling. So we all know that global ocean atmosphere coupled models are the primary tools normally provides long-term or short-term climatic information. In addition to provide some of the models we have seen in the morning, the weather information of medium range, which is valid for 4 to 10 days, extended range 10 to 30 days, and seasonal scale valid for 1 to 3 months. So all informations are with us. However, this model suffers from substantial biases when we compare with these surface observations, are unable to provide useful information at the regional or local scale, which is basically required for study for impact analysis for different economic sectors like agriculture, hydrology, health, insurance, and tourism. So therefore, there is a huge demand by the multi-level stakeholder to have reliable forecast product at regional and local scale for accurately assessing the impact of climate change on different economic sectors. So what is actually, we say that the downscaling, the numerical output has been emerged as an alternative to provide an actionable product representing the local features for multi-level stakeholder, whatever I have mentioned. So through this talk, basically I am focusing for my students. So can we evaluate the different statistical model and choose a suitable model which will actually apply for the South Asian domain? And whether there is a lot of question is whether the statistical downscaling provide some added value compared to non-downscaling results. And second question is, how do we solve distillation issues from empirical statistical downscaling RCM, GCM ensemble? And third question is very, very important. Which downscaling method, whether the statistical or dynamical, will be provide reliable information for impact assessment study. This is a very, very debatable issue. Sometimes some people says, when you do some downscale product from the dynamical model, it further needs to do some statistical downscaling for the location. So this is a very, very debatable issue. When I was in some meeting, and there are many people have many arguments, so I am not going to do that. So why do we need downscaling? There are different types of downscaling. This is the model output statistics you people all knows, and perfect prognosis PP model downscaling, and also machine learning based downscaling I will talk today. So what is actually downscaling? It is basically the relationship between the large scale to local scale phenomena. So these are the local scale phenomena. Basically, we wanted to have what is the temperature for a particular location, what is the precipitation, and this is the local scale information we really want. And there are large number of large scale features from the upper atmosphere that is actually available from the reanalysis data. So we have to make some relationship between the local scale and large scale. So large scale variables are more reliably simulated, and relationships remain valid in the future climate change condition. So if you look this result, so you can see this is a long back we have carried out. That is the Himalayan regions, Western Himalayan region. You just see this is the observed, and this is the different CIMIC 3 model output. You just see that in the monsoon period, so no models are able to capture the observed features over the Himalayan region, and it is the this is the you can say that the CIMIC 5 model. We have also produced the CIMIC 6 model. So you just see no models is able to capture the monsoon rainfall over the Himalayan region adequately. So if you go for the temporal scale, this is the observation, and this is the model simulation. This is the CIMIC 5. So everywhere there is an improvement, but we really don't have the actual features. So this slide is very, very clear. So why do we need downscaling? So if you have 20 a number of multimodal ensemble of 20 models, so you can see this is the time series, the blue line, and this is the observation. And we choose the best performing 3 models, and we make the multi-model from using the 3 model. You can see a little bit improvement. But if we do downscaling using the scaling method, you can just see how this bias has improved and come to the observational features with a little bit similar to internal variability. So if you go for spatial scale, you can see this is the observation for some homogeneous zones of India, and this is the multimodal ensemble. So you can see there is a lot of difference. So it's indicate we need to have some downscaling. So there are different ways we can do downscaling scaling method. This is basically some tuning of the model output with observation, and this is a standardized reconstruction. Yeah, this is again another way of making bias correction and something like that. So, and this one is very, very important, that that is the probability approach. So this is the observation, this is the model output, and this is the future model output. So you can see the future is far away from the observation. So if you tune this, so you just make this difference between the observation in the historical period and tune the future with this difference. So your future will be a little bit closer to the observation. So this is the way we are just going to see that downscaling is very, very important. So this is the observation, this is the multimodal ensemble. And if you do the downscaling, so you can just see how improvement we are getting, which is very closer to the observation. So this is the one way we are just going to take. So now people are talking about, so in the climate system, it is very, very, people are always talking about downscaling, but now we are just going to say something about that medium range weather forecast, extended weather forecast, and seasonal scale weather forecast also need some downscaling. So if you see the skill of UK Met Office medium range weather forecasting, you just see this is the 1 day advanced forecast, 2 day, 4 day advanced forecast, 7 day advanced forecast, 4 day. So if you see the RMEC is actually high over the eastern part of India, particularly Gangetic West Bengal region, and it is increasing if the length of the forecast is increasing from 1 day to 10 days. So which if the skill is very not so good. So if you go for the extended range forecast from the IMD model, you just see the relatively lower skill have been found over the Gangetic West Bengal or eastern part of India. And if you go for the seasonal forecast, you can again see the correlation is high and correlation is low and RMS is high over the eastern part of India. So I am not going to go in details. So the downscaling is essential, and we can do downscaling for different approaches. So reanalysis based PP model downscaling, and during this downscaling, one point is very, very important. Everybody has to be very much careful that when you are doing PP based downscaling, you have to select the suitable predictor. Another point, you have to select the suitable downscaling domain. So one of our work which was published earlier, and we have seen that we have chosen for doing the downscaling over eastern over the Himalaya region, considering the whole South Asia domain as a domain. Then we just taking the India land area is the domain, and last one is only the Western Himalaya region. When we consider the domain for Western Himalaya region for predicting rainfall over Western Himalaya region, we get very good results. So that is the way. So when we are going to do downscaling, so we have to be very much careful. So now some advanced machine learning techniques is also available for transfer function. So when we'll use that machine learning techniques, so we are expecting to have very good results. So these are some results we have obtained from the Himalaya region. You just see future temperature over the Dehradun and the Manali and Gulmarg is going to be increased from 1.5 to 6 degrees Celsius at the end of 21st century. And what about the precipitation? Precipitation is also going to be decreased drastically. We have analyzed 23 numbers of observational station over the Himalaya region from IMD, and we have seen last century where Himalaya rainfall has drastically reduced, almost 280 millimeter rainfall decrease. So these are the things we are just going to highlight. So another is
the time is up.
I have to finish. Okay. So this is the important value added. So how we can do the value addition for our downscaling result? There are many ways. If you are interested, I can discuss all the way how to actually assess the value addition for the downscaling assessment. So this is the how the models produce the downscaling product that will be used as the crop simulation model or hydrological model to do assessment how climate is impacting on rice production or wheat production, anything else. So I am just going to quickly conclude because time is very less. So just this is some models we have just tried to see how the advanced level machine learning is improving. Actually, I should have skipped this one. So conclusion is downscaling is essential to reduce bias and uncertainty. And second is method of doing downscaling is very, very important. If you choose wrong method, your downscaling product will be wrong. And third one, each downscaling process, selection of predictor I have already mentioned is very, very important. And it is, if it is wrong, your product is going to be wrong. And potential for machine learning to get better results that we can say. So two possible recommendation I just wanted to say that multi-level stakeholder who are really wanted to have the downscale product. So multi-level stakeholders should have high resolution downscale climate information beforehand to implement any adaptation and mitigation strategy towards combating climate change and local scale. To adequately assess the impact of climate change on agriculture sector through crop-specific crop simulation model. So everybody has to take the downscale information instead of raw GCM output to reliably produce how much productivity is going to be changed in their location. So
thank you very much, Dr. Lalu. You've taken 5 minutes from your session, by the way. So I'll allow one question just to be fair. To those that have not asked yet, if there's anyone from the back who wants to ask question, otherwise I'm taking from the front. No hands there? Okay.
Yeah.
Methods. Which machine learning methods you, suggest to use?
Actually, we are working and we have presented some of the figures you see. Some machine learning models actually random forest we provide for specific homogeneous zone it is better. Another specific homogeneous another model method is better. So it is a very sensitive on the method and zone where you are looking for.
Okay. So well, someone seems to be really wanting to ask a question. If it's really short only.
Yes.
Really short.
Yes.
Yeah, please.
So it is very clear that statistical downscaling is way better than the other maps, dynamical downscaling, at least here.
Showing anything about
Let him ask the question.
Okay.
Yeah. So then what do you recommend? Are we going to, is it good to go with the statistical downscaling further, or still we have to depend on dynamical downscaling from the CORDEX?
This is a very fundamental question. That is the debatable question. So I was in a forum. That time some dynamical downscaling people and statistical downscaling people was there. So somewhere the dynamical downscaling
You speak on the mic.
Okay, sorry. Dynamical downscaling product has some limitations to reproduce the local scale features, like say our eastern part of India in the pre-monsoon season, thunderstorm having some influence to get rain. But if you go for some RCM or GCM, that features cannot be captured, but it is influenced through the observational data. So basically statistical downscaling, what is happening, they are tuned with the observational data from the large scale information. So we are expecting better results if you do the statistical downscaling.
Okay.
But it is not true for everywhere.
Thank you, Dr. Lalu. Thank you. Thank you very much. A round of applause for Dr. Lalu. Thank you very much. I think a very rich presentations and discussions. And I would not attempt to really summarize all of them, but I think each one had its own merit in terms of course, the first three, looking at regional climate modeling and some of the successes as well as progress that is being made and the plans. And I think you very much heard Dr. Lalu very much talking about statistical downscaling and its merits. Of course, dynamical downscaling has its own merits too. So with that, I'll close the session and we'll request Dr. Sanjay for the next. And of course, before, I'd like to thank all the presenters and all of you here, listening to the presentations, for being here this morning. Thank you very much.
I request Bhupenji to felicitate this chair session. Please, Dr. Mandira Srestha. Thank you. There are some announcements, I understand.
Yeah, so with this, we will now break for tea and coffee. And then, so there is one more announcement. So in order to fulfill Mahatma Gandhi's vision of Clean India, the Swachh Bharat Abhiyan, a massive mass movement has been launched that seeks to create a cleaner nation. Today, employees of this institute will assemble for a Swachhta pledge at 10:50 Indian Standard Time in the reception area of this main building. Let us all be a part of this activity. I request all of you to join us for this pledge. We will resume for the next session after taking this health break. So at 10:50, we will go in the reception area and we will be quickly back. That is just for 2-3 minutes. Okay. Yeah. So, yeah. So it is 10:44 now. We'll now quickly break for tea and then we will go there directly. Welcome back. So we'll be resuming this session A4. So I request Dr. Sanjay to kindly chair this session, and the reporters for this session are Nishchal Sharma from ICER Mohali and Athira Maria Jose from IITM Pune. Yeah, so, yeah.
Yeah, thank you very much, Bhupendra. Thank you very much. Now, without any delay, I think we'll start the session because Dr. Sabin is from the Center for Climate Change Research. So I think he will introduce himself. So I don't want to get too much into that. He will know from his talk itself, he will come to know the kind of work he's doing. He's going to be our next contributor to the CORDEX activity. So Sabin, please go ahead.
Yeah, good morning, everyone. Thank you, Chair. So I am working as a scientist here in Center for Climate Change Research of Indian Institute of Tropical Meteorology. So this talk will briefly go through the high resolution climate modeling activity, which we are taking care in IITM. So basically from the last lecture by Dr. Swapna, you might have noted that the main activity of CCCR is based on our IITM Earth system model, its development and production simulations. So if you see this T62, this the version which we contributed towards the CMIP6. The resolution was something nearly 2 degrees, and the version which we are planning is also will be something around 1.5 degrees. So if we want to address some details in terms of its for regional assessment, the resolution is really a matter. So to tackle that issue, we used an alternate approach. So we just took, this is an Earth system model, which is having all the components, ocean, atmosphere, biogeochemistry, and so on. So we just took the atmospheric component of this version and configured it into a very high resolution, that is T574, which will be giving a uniform resolution of something around 27 kilometers throughout the globe. So we use this version for our high resolution simulation. So we have a global high resolution simulation, and we will use all the forcing from CMIP6 archive. So that means that is also to be followed for the CORDEX procedure also, just like CO2, aerosol, land use, land cover, everything will be prescribed. And so you get, while making the simulation, you will be getting a global information. So this is not a regional information, but it's a global simulation. So the entire globe will be dynamically resolving with a 27-kilometer horizontal resolution. So this data we will be reshaping for this CORDEX South Asia domain and will be contributing as well. So this is being a atmospheric only model, you have to be depend on SST boundary condition from a parent model. So here, this boundary condition will be coming from our own IITM Earth system model, and being a very high resolution global model, to make a long continuous integration also will be slightly bit expensive. So we planned something, a time slice experiment for present day from 1995 to 2014, and a near term or near future, we can say, and the end of 21st century simulation also will be there. And you can just see some of the simulated features from our model. This is the high resolution model, the shown at the bottom, and precipitation and the low level circulation is shown here. And this is our IITM Earth system model, which is at a coarser resolution. This is from the observation. And for this is obviously for the monsoon season, you can see the huge amount of precipitation over Indian region associated with strong low level circulation. You can see that this model, IITM Earth system model, is the one of the best model in the CMIP6 archive. And you can see that nice glimpse of precipitation and circulation is featured here. But you can see that since the resolution is better, orographic precipitation and precipitation over central Indian region is slightly better in this version, this high resolution, along with a strong, intense low level circulation. The upper level feature also, you can see this is the upper level circulation at 200 HPA. This is from our coarse resolution. This is from the high resolution. You can see here that the tropical easterly jet stream is relatively strong. So that means a clear baroclinic structure is visible over this Indian summer monsoon region. So to be precise, over the Indian region, you can see that the dry bias, which Dr. Swapna was mentioning, which is considerably reduced in this high resolution simulation, especially over the central Indian region and over the Western Ghat region, comparing to our own this Earth system model. So the model has a reasonably good annual cycle in precipitation. This is blue line is from IMD, India Meteorology Department observation. The red is from the high resolution model. You can clearly see, but there is some overestimation over this the month of June. That also you can see, but more or less the annual cycle is coming decent. And this is some interannual variability of Indian summer monsoon. That is the year-to-year variability, where you can see that the model is able to capture most of the annual variabilities. For example, this is was a deficit monsoon year. I think it is 2002, and this is 2004, 2009, and 2014. And mostly the model has a good agreement. In addition to the monsoon feature, you can see that the model is able to capture the North Indian Ocean cyclones also pretty well. So this is, we have two monsoons, the cyclone season, that is, one is post-monsoon and the other one is pre-monsoon season. You can see that the model is able to capture the tropical cyclones also relatively well. So using this version, we have planned a set of experiment. One is, the first one is evaluation experiment for this period. And the second one is the historical simulation following the CORDEX and CMIP procedures. And for the future, we will be using SSP, that is a moderate emission scenario, which is for the two time slice period, 2021 to 2040, and end of 21st century, we will be making 2 time slice simulation. And then addition to that, we have 2 more experiments that is for our own scientific understanding. So one is SSPRO and another is GAG. Yeah, I'm finishing. You can just, this is a quick comparison from the CORDEX simulation. You can see that this is the annual cycle from the, or the 11 CORDEX model, which was in the previous phase of CORDEX. The black line is from the observation, and all the models are showing a lot of difficulty in capturing even the mean annual cycle. The bottom one, you can see that this is from the comparison with the India Meteorological Department data and the T574, the high resolution simulation, which is having a reasonable good skill in reproducing the precipitation, especially during the monsoon season. Here you can see the Taylor statistics. Here, this is the blue dots are the 11 CORDEX models, and its ensemble mean is coming as the purple color here. And this is the red dot is our T574, which is having a good correlation. And the RMSE is also relatively less in this model. So there is certain value addition comparing to the other CORDEX member model. So the take-home summary is that, so we have the 27-kilometer model is showing certain value addition, especially over Indian region in terms of monsoon, as well as in simulating the tropical cyclone. So we will be contributing this 27-kilometer IITM high resolution model for the CORDEX South Asia domain. So you all will be welcome to use this data once it is available. Yeah, thank you. There I'm stopping.
So thank you, Dr. Sabin. Very nicely talking about our new contributions. So we can have one or two questions if you have any.
Yeah, thank you very much for your good presentation. I have a very quick questions. So could you explain about the skill differences of the coupled and uncoupled model?
The difference?
Yeah, I suppose you explain about the atmospheric only model.
Yes.
So could you explain about the difference of the uncoupled and coupled model?
Okay, so basically the IITM system model has a ocean version, that is MOM4 P1, and the atmospheric version is the GFS, NSUP GFS versions. Basically, and we made a lot of modification to that model. Actually, Dr. Swapna mentioned in her previous talk, a lot of bias was there, a lot of things were modified in the code itself. So that version we used for our high resolution initiation. So basically, you can call it as we removed all other ocean components, and we just took the IITM ESM models atmospheric version and reconfigured that into a very high resolution. So still, this is a spectral model with the T574 version, and that will be able to provide a 27-kilometer, nearly 27-kilometer global resolution. So that is our basic version.
Thank you. Any other questions or?
Thank you, Sabin, for the presentation. Now, I was just wondering the timeline. You said it's being done.
Yes.
When is it going to be made available?
Future runs are mostly finished, and the percentage is already available. So we will make it shortly. We will be releasing the data, and we have to make a few more ensembles. So, but initially we will one ensemble we will be releasing. Yeah, in a couple of months we will be releasing.
End of the year?
Yeah, only thing is that we may have to modify some of the fields, and then we will be uploading it.
IITM GFS is daily product. IITM GFS.
Yes, the output is daily. On a
Okay.
daily scale, we are storing. Yeah.
Okay, Sabin.
Yeah.
For
Okay,
want
thank you
of time, more discussions can be held during lunchtime and all that. So we go to the next speaker, exploring the precipitation extremes over Hindu Kush Himalayas in CORDEX simulations by Srihari K. So please keep for the time constraints, 5 minutes.
Good morning, everyone. My name is Srihari, and I'm from Weather and Climate Modeling Lab, ISA Mohali. So today, first of all, I would like to thank the organizers for giving me this opportunity. So today I will be presenting our work exploring the precipitation extremes over Hindu Kush Himalaya in CORDEX simulations. As we all know, the Hindu Kush Himalayan region is a very unique region due to several reasons. The sensitive ecosystem and the largest ice mass outside the polar region, and also availability of natural resources like fresh water. And also many people, over 1.9 billion people are living and getting the benefit of this particular natural resources. So all in all, this region is very unique, and also the complexity of this region, especially the topography, poses a great challenge for the climate modelers to get the modeling right for this region and to reproduce the observed variability. Coming to the data and methodology, we are trying to quantify the extreme precipitation characteristics. As we all know, like the mean precipitation is fairly has been discussed in many studies before. So we are trying to get the extreme precipitation characteristics in terms of extreme precipitation indices suggested by ETC-CDI. And also we have used 17 members of CORDEX simulation, and studies based on the model ranking are widely being conducted across the globe to analyze the performance of global and regional climate models. So here we have used 5 of the extreme precipitation indices and statistical parameters like Taylor skill score and index of agreement to quantify the performance of these models. So coming to the climatology and seasonality, we know that the annual climatology of HKH region is predominantly contributed by summer precipitation, and the summer precipitation is mainly contributed by the summer monsoon rainfall, Indian summer monsoon rainfall, and the winter precipitation is especially over the Western Himalayas is contributed by the Western disturbances. And coming to the seasonality, the sub-regions across the HKH domain, we can see that the CORDEX simulations, ensemble mean of the CORDEX simulations are reasonably capturing the annual cycle of the rainfall. However, there is some overestimations or discrepancies with respect to the observation data sets. So we have the extreme indices, skills and statistics. We have analyzed the extreme statistics. Here we have used the Taylor skill scores. And as you can see, the models are having different skills when it comes to the representing these extreme indices characteristics across the indices. Also across the season, we are seeing a lot of variations. So in order to, it is actually very crucial to get the best models or to know the skills of different models. So here we have highlighted best 5 models that is based on the TSS. And the immediate question arises will be how well these models are performing or comparing to the all model MME. So we have across the season statistical plot that actually showing the different statistical improvements. In a nutshell, what we can see is that there is a reduction of error up to 10% with respect to the MME of all models. And also it is in better agreement with the reference data set in terms of skills and agreement. So these are the results. So another immediate question that we are interested to answer is that how is the future projections are represented, or what these models which showing higher skill scores in historical period have to say about the future. So we can see in a nutshell, we have different trends for the different subregions, as the heterogeneity of this entire HKH domain is high. So we have to take the subregions and analyze the trends individually. So in a nutshell, again, we can see that the precipitation extremes portend an increasing tendency over the bulk of the region in both near and far future, and also for the scenarios, different scenarios. Here we have taken the RCP 45, which is a moderate emission scenario, and RCP 85, which is a high emission scenario. Also, there has been observed mixed trends across the region, but they are not very significant. So summing up the study, we have analyzed the CORDEX simulations for its extreme precipitation characteristics, and also analyzed the skills of different models. And we have found that this skill is actually varying with the models and seasons also. So in general, this model depicts extreme simulating precipitation characteristics for annual and JJS compared to the DJF. So there is definitely room for improvement. So yeah, so that is what we have to say. Thank you.
Thank you. Thank you, Srihari, for being on time, and very nice, interesting presentation on the Hindu Kush Himalaya extremes. Thank you. Thank you very much. Any questions? One or two.
You have shown the Taylor skill score. How you have calculated it? You consider the spatial points or the time series?
Yeah, so we have actually taken the climatology of all the indices only. So it is based on spatial only.
No. I mean, you have considered several beat points over Hindu Kush region, only one beat point, or area average one.
It's not an area average one. So all the analysis are done over the entire domain. So spatially only we have calculated everything.
How you have, for example, for monsoon, how you have calculated that correlation? I mean, all the years you have taken, like how many years you have taken?
This is
maybe what I suggest, no, we are short of time. This detailed discussion you can have during the lunch time and all that. If you have any specific questions, we can take
no,
it
actually, I have questioned how.
Yeah, that's it. That methodology, I understand the methodology you are asking. So you can have, no, we are all here. So any other on the topic, or shall we go to the next? Okay then. Thank you, Srihari. So the next speaker is Dr. Suraj from IITM. The analysis of the CORDEX evaluation experiment over South Asia using REDCM-based dynamical downscaling of ERA 5. So it's a joint work which I mentioned in the morning, which we are trying to do CMIP6, aiming at CMIP6 downscaling. Yeah, Dr. Suraj.
Thanks, the chair. Good morning to all. I'm just, as already told by Sanjay, Dr. Sanjay in the morning. Good morning all. Thanks to the chair. As already told by Dr. Sanjay in the morning, I wish to highlight our initial efforts in doing the CORDEX evaluation experiment over South Asia using the latest version of REGCM, okay, through the ERA 5 based. So as per the recent AR6 report, the studies of downscaling, the studies focusing on downscaling over the South Asian region is lacking. Basically, because of there are fewer number of RCM runs over this region compared to the other CORDEX domains. And then our IITM as well as ICTP have earlier contributed to the CORDEX South Asia runs by dynamically downscaling CMIP models simulations. And as per the CORDEX, they have recently published an experimental design for the which actually presents a simulation framework for the downscaling of the CMIP6 global projections. So the question is, so what we are doing is, so in the present study, what we have done is, so we have taken the latest version of ICTP regional ICTP REGCM5, the latest version of RCM from ICTP. And it is as configured over the, and we have configured that over the CORDEX South Asia domain and for the CIMIC6 experiment framework. And then we carried out the evaluation simulation driven by the ERA5 driven by the ERA5 reanalysis data, and it's around the resolution is about 25 kilometer, and the period is around from 1979 to 2020. So the thing is that, and we have used a tuned up version of the model, which actually based on the deep cumulus conversion process. Okay. So our effort is to evaluate the performance of REGCM5 in simulating the rainfall climatology and the near surface skin temperature. So this is the setup for the different options for the dynamic and physics options coming from the REGCM5. I'm not going to spend more time in that. I'm directly going to the whatever the initial results we have done. Okay. So this is the seasonal climatology of rainfall, okay, and also for the 100-meter wind. And the first one is GPCP. The first panel is GPCP. This one is GPCC, and this is ERA5, and this one is REGCM5, which is whatever we think it's a best tuned model. Okay, and then in general, the REGCM is going some fidelity to capture the seasonal transition in the wind as well as the rainfall over the Indian and surrounding regions. In particular, it is able to capture the rainfall maxima over the Western Ghats region, and also there is the next rainfall maxima over the northeast region, and also the model is able to the model is making an attempt to capture the moderate to high rainfall over the Indo-Gangetic plain, though it is slightly underestimating. And then we are also showing one more statistic, which is the second order moment. Okay, that is the variability statistics. So if you compare that one, this is the GPCP, GPCC, and ERA5, and this is the model, and this is the seasonal evolution of that one. So we can see that during the summer monsoon period, the model is having some difficulty. It's actually overestimating the variability which you are using. That means we have to do some more tuning to get a best version of the model. So this is our remarks, okay, at the end. So the thing is that the REGCM is making some attempt to produce a good representation of the Indian monsoon, Indian climate characteristics, and also the rainfall climatology. Or what we found is the rainfall climatology over the South Asian monsoon, over the Indian monsoon region, is very sensitive to the physical process in the model. And also currently we are carrying out some more physics model sensitivity test for further improving the spatial and temporal variability of the South Asian monsoon climate. So the ultimate idea is to go for get a suitable configuration of REGCM setup for doing the dynamical downscaling of over the CIMIC6 using CIMIC6 historical as well as the scenario MIP simulations. So that is our ultimate plan. Thank you.
Okay, thank you very much, Dr. Suraj, for introducing the IITM's plan to do the CIMIC6 downscaling with the regional model. But our commitment is with the high resolution model, global model, which Dr. Sabin presented. But when this is ready, we will be also doing it. That's we are not committed for that. So the next, sorry, if any questions are there on this, you can have.
Yeah. Thanks, Suraj, for the nice presentation, and we are looking forward receiving the data also. We start to analyze it. Still, REGCM5, even it is a best suit model with better configurations, still model produces a lot of rain, especially Western Ghats and other side in Bay of Bengal. Is there any sort of nudging applied on the large scale forcing so that some moist physics can be improved through the tropospheric feedbacks?
Okay.
Nudging, either spectral nudging or grid nudging on the large scale.
Currently, we have not done anything like that. So thanks for your input. We will look into that.
Right. Thanks.
Any other questions or otherwise? Okay, one more.
did you check the data, your downscaling results with Indian observations? Yeah. Well, I saw you just compare with GPCP and
we did some analysis. We also did some analysis. We didn't show here. So it is more or less similar to what we are already seeing in the GPCC, and there are some differences in that, but to some extent it is more or less similar.
Okay. Thank you.
This was basically a preliminary thing because we are trying to do some sensitivity thing, and the result what is shown is the best we got so far. But that's why we are still not getting into a commitment to, because before going into do the real CORDEX runs, we should first evaluate the model a little more. So that's what we are doing. And for some time we are got occupied in this conference. Now we'll be getting back to that.
And also, Jimmy, observation will not find over oceans, right? Yeah, that was
correct. Okay, then. Thank you, Dr.
Thank you.
Now we have an online presentation by Dr. Laura Burgin from the I think it's UCAM at office, or she will introduce herself. So the topic is on evaluating CMIP6 models for downscaling on Southeast Asia CORDEX domain. So we can hear something on our neighboring CORDEX domain, the activities. So please go ahead.
Good morning. Can you hear me okay?
Yes, we can hear you. Please go ahead.
Okay, I'll try to share my screen. This one. Is that okay? Can you see?
Yeah, yes.
Perfect. Okay. So
maybe you can make it full screen if possible.
Oh yes, sure.
Thank you.
Yeah. So good morning again. I am Laura Bergen. I'm presenting this work on behalf of my colleague Grace Redmond, who couldn't be here today. So apologies if I don't know all the details. It's not really my work. But I would be very happy to share with you what we've been doing in Southeast Asia. So just firstly, a quick word about how...
Laura, 1 minute. Can you please, in the bottom, there is this Zoom sharing that can you hide that?
Oh, so yes, sorry.
Some of the text. Yeah. Thank you.
Yes, so a quick word about how this work is being funded. Some of you may have heard of the Icrc program, which ran in South Asia until about a year or so ago. This is the follow-on project called WISER Asia Pacific. So it's also funded by the UK government, but we are now looking across the whole of Asia and into the Pacific. So we're currently in the planning phase, and we have some regional partners and some kind of overall themes that we're trying to achieve with this program. But in this planning phase, we have two kind of quick start or startup activities. And one of these is to look at some regional modeling to support the development of national scenarios. And initially, we're doing this with IMHEN in Vietnam. So the first step of our project is to obviously assess which models we want to downscale for Southeast Asia. So we're following the approach of Carol McSweeney and the EuroCordex paper by Sobolovsky. This method is basically to remove any implausible models and then try to capture the range of uncertainty as best as possible with the limited amount of resource that we'll have. So I think we have resource to downscale around 3 to 5 different models. So the processes that we focused on in this study were the summer and winter monsoons and the SSTs. So quickly showing the results for the summer monsoon. So these are plots of the 850 hectopascal wind for JJA. And generally we find that the CMIP models, CMIP6 models are showing improvements on CMIP5. And for the summer monsoon, we don't think there's any reason to rule any individual model out. So none of them are implausible. We do, however, find that there are significant biases in some of the models. So for example, the MIROC model here the circulation is too far north over Vietnam. For the winter monsoon, again, we don't find any of the models to be implausible, and we don't think any of them should be ruled out based on this process. We do find one of the IPSL models, it's a bit borderline. There's no kind of westward flow back over Indonesia. And in quite a few of the models, the easterly component is too strong. So compared to ERA 5, we find some of the models are showing too strong a easterly component in this wind. Moving on to sea surface temperatures in the summer. As we know, the RCMs take their sea surface temperatures directly from the GCM, so it's very important that they are not too biased in this metric. The ocean temperature is also very important for tropical cyclone formation. We think about half of the models are satisfactory. They don't show any particularly significant biases, but there are several that are biased and 4 are significantly biased. Some of them are showing too cold temperatures, particularly in the northern part of the domain. And there are some that are too warm over the maritime continent. If we look at the kind of region where the tropical cyclone formation is, generally most of the models are doing quite well. So again, we have not ruled any out as being implausible for summer SSTs. Then to try and look at the range of uncertainty, we plot the precipitation against the temperature. And for this particular evaluation, we're looking at SSP 370, as this is the most extreme scenario used by CORDEX. In this plot, the blue dots are where we have boundary data available, and orange is where there isn't any boundary data available, but we're including these for context. So overall, the red circles show the kind of 8 models that we think we would like to ideally downscale. However, we need to dig into a little bit more about the precipitation, because it's also important that we look at the spatial changes as well as the overall magnitude change. The orange ones are the ones that we rule out as being significantly biased. So in summary, from the present day, we don't think any of the models should be excluded. There are some that are significantly biased. We only have resource to downscale around 3 to 10 models. So we haven't quite decided which 3 we will focus on, but the 8 that we would like to, that we recommend, are on the screen just there. So I'll stop there and take any questions.
Thank you very much, Laura, for that nice evaluation of the CMIP6 models for the Southeast Asia domain. First of all, apologies for late. We had a late session going on. That's why you have to wait for some more time than the scheduled one. So I will take some 1 or 2 questions from the audience, if any questions are there, or anybody would like to ask about the evaluations which have been presented. Like to.
Well, this is Mandira. Thank you for your presentation, Laura. I'm familiar with the ARC program, as I'm from ECMOD and coordinated the program with your colleagues. Yeah. So I think with these evaluations that you showed, I think you took 23 simulations. What is the next step that you're going to do with this evaluation?
So we've started the baseline run. So Grace and some colleagues are now running the ERA 5 simulation, and we're in discussion with IMHEN, who will be our pilot study, on which models we only have resource for probably 3 models to do downscaling of the CORDEX regions. So we're discussing with them which 3 we should prioritize. Does that answer your question? I guess we'll also be looking to write up and share this work further.
Okay, Laura. Thanks. Any more questions? Or yeah, Professor Koji.
Hi, I'm Koji. I would like to have some very quick questions. So do you have a considering about the possibility to consider about compare with the hydrogen MIP and also CMIP6. I mean a coupled model and atmospheric ocean only model.
I'm really sorry. Could you repeat that again? I missed some of the.
Okay. So do you consider about the possibility compare with the atmospheric only hydrogen model, hydrogen MIP, and also CMIP6 in your evaluation? Can I have your comments on that?
So in our report, we have done some literature reviews, and there wasn't time to discuss the results in this 5-minute talk, but we have looked at other CMIP6 downscaling that's been done, or a CMIP6 evaluation that's been done for this region. I don't know the results off the top of my head, I'm sorry, but it's also a nice idea to look at comparing with atmosphere-only high-resolution modeling. Yeah, we haven't done that yet.
Okay then. Thank you, Laura. Thank you for your time. And maybe you can keep interacting through our online interactions can continue.
Yes.
Thank you very much.
Thank you for the opportunity.
Thank you. This finishes this session, and we continue with the next session, the session A5 on statistical methods and machine learning techniques for regional climate downscaling, which will be chaired by Professor Lalu Das. I invite Professor Lalu Das to come forward. We are running behind schedule, but we'll try to finish the session and go. We will have a slightly late lunch. Yeah, the reporters for this session are Bella Lodh from Icrc Bhopal and Priya Kumari from IITM Pune. So they are, I think they're sitting in the behind. So they will be taking down. So on to Professor Lalu. Thank you.
So thank you very much. As we are already behind time, we have to very much quick about the session. And without going to details introduction, I just wanted to say that this session is basically statistical method and ML techniques for regional downscaling. So basically, previous session was the dynamical downscaling. This is the statistical downscaling. And there are 5 presentations in this session. So, okay. So 3 presentation out of 5 presentation is online and 2 will be offline. So first presentation will be online mode, and it will be by Manmeet Singh. She is going to be talking. Manmeet Singh, bringing deep learning to the plate of climate scientists for downscaling. So she is there. Okay.
Hello. Yeah. Is my screen visible?
Yeah.
Okay. Thank you. My name is Manmeet Singh, and I am at the IITM Pune. So I will, since we're already running late, so I'll very quickly. I'm talking about bringing deep learning to the plate of climate scientists. And we'll be talking about some of the tools that are under preparation for downscaling and urban downscaling in particular. So this is a very famous plot where we have on the x-axis is the spatial resolution, and on the y-axis we have the time. So when we are talking about downscaling, we want to get the information at a granular level, at a very high resolution, particularly in space and also in time. Now machine learning has been it's become very popular in the last 10 years as a method for statistical downscaling. A lot of questions the physical scientists used to have, like why machine learning algorithms work. So I just wanted to highlight this paper from Zeiler and Fergus, where they plot the weights of the CNN, and they show that the initial layers, they try to identify the edges, then the curves, and more and more complex features. So it's like a high nonlinear higher order polynomial regression. So this is like one of the very recent success stories of machine learning for climate. So the model is Pangu weather, which is operationally used in ECMWF right now, and they have shown that the track of the typhoons, it's exactly matching. So Pangu weather is exactly matching what the observed track is. Now I'm coming to so what we are trying to do. So if you want to try something or do downscaling and go to the scales at which the virtual world and the real world observations, they exactly match. So then we are talking about something which is called as digital twin. And to do that, what do we need? We would need high resolution data sets, probably half a kilometer or less than that. And so this high state-of-the-art machine learning algorithms would be used for that. Now, the first thing that we would need in that is, so this is a tool I'm talking about, is a downscale bench, which was recently published in Computational Urban Science. So the first problem is development of supervised learning data sets, wherein we bring together what we have, what we need from satellites, from the reanalysis products, from stations, and how is the evaluation going to be done? So the evaluation of a high resolution product can, if it's a new product, can only be done if we have the station data, because that's the first time we are developing that gridded product. So in this, we have developed a method called iterative SRCNN. So SRCNN is a method from computer vision. It's for basically used for single image super resolution. And so methods like, for example, people have used bilinear interpolation, bicubic interpolation. These are general purpose operators. So machine learning based general purpose operator SRCNN was first prepared, and then it was used in an iterative mode to generate high resolution urban precipitation gridded product over a city in US. This can be replicated over any city across the globe. And we basically, then the next step is whether it's just SRCNN or there are so many different models, computer vision models, particularly after the advent of attention based operators and the transformer models. So this is another tool that that is actually now prepared. I have the collab notebook ready for this. I'm calling it Climate Downscale Suite. So in Climate Downscale Suite, there, so on x-axis, we can see the number of operations. On y-axis is the performance in peak signal to noise ratio. This is purely from computer vision. So there are initially people, so the SRCNN Dong et al. Paper came out in 2014. And then there was the fast SRCNN, and now people are using the attention-based model. So this is a 2018 or 2019 review paper. And so what we have done is just for demonstration purposes. So there is a DMSP nighttime lights data and VIRS nighttime lights data. So DMSP stopped in 2012. And VIRS is available from 2012 to present. So you can see that models like Swin Transformer, which the paper has come out in 2022 for Swin Transformer. That's the best ever computer vision model available for deep learning based downscaling. There is a model called SAN as well, which is giving us even better PSNR as compared to Swin Transformer. But these are a suite of models for people who would like to do downscaling depending upon the kind of resources they have, the needs and the end use applications. So these attention-based models require GPUs and some good computational resources. So then the next thing is how are we going to implement the station-based data set in the training? So that is actually the next step so we're basically training this model. And Meteogan is an architecture that Yeah, I'm just finishing now.
Yeah.
So which is prepared. So which is an answer to develop high resolution gridded products and to aim towards urban digital twins. Thank you so much.
So thank you very much, Manmeet, for your nice presentation. And it is a very informative presentation. And this presentation is very much suitable for today's actually main heading. So as time is very short, so quickly we have 1 or 2 questions from the audience. Yeah.
Okay, thank you very much for your interesting presentation. I have one quick question. If you consider in the model about the nighttime activity in the nighttime light, so how will you improve the precipitation in the urban areas? Can I have your comments on that?
So the nighttime lights example is not for precipitation. It's basically just a demonstration for showing the climate downscale suite to improve the precipitation. So as I showed it, we are basically using meteogan, and in which in the generator the model that will be used will be a single image super resolution based model from climate downscale suite. It can be anything from SRCNN, FSRCNN, SAN, Swin transformer, and the discriminator will be using the station based data as a target. So that is how the precipitation will improve. That nighttime lights example is just for a quick evaluation of the different models from climate downscale suite.
Okay, thank you very much.
Thank you very much. One more question. If there is no question, I have a very quick question. So in your method, you have said that you need observed data for less than 500 meters resolution. So if some places don't have any meteorological observation data, then how they will do the downscaling using your method?
Yeah, no, I said that actually we are preparing urban gridded data sets targeting less than 500 meter resolution. Now to do that, we would need station based information in that region to basically validate our 500 meter data set, because this is many places in the world will not have 500 meter gridded product available. So how will we validate that? Now to validate that, we would need to put stations. We cannot put station at every grid point in the 500 meter grid, but we need to have an algorithm which can basically develop such a high resolution product and also not require the need to put the stations at every grid point.
Okay, thank you very much for your nice reply. And we should go for the next presentation. So next presentation will be on investigating the impact of custom loss function to train a deep neural network for downscaling gridded precipitation data by Midhun Murugesh.
Good morning to all. Myself Midhun from Icrc Bhopal. Today I'll be presenting part of my work, which is to investigate the impact of loss functions to train deep neural network. So problem which I will be covering is precipitation downscaling. So I hope I don't need to introduce the requirement for regional downscaling. But in recent years, the AML based downscaling is in a fast-paced development. So basically, this AML offers an opportunity. If you have an input target pair, we can derive models out of it, data-driven models. So this flowchart basically show how it is done. This model represents any neural network architecture which contains an n number of learning parameters. So it will be initialized randomly and it will produce some y hat equal as a prediction.
Okay, please continue.
Okay, so
And very good morning.
Sorry. So please continue.
So the moment we have y hat and a y, we can produce a loss function out of it. And this model parameters will be updated iteration after iteration so that it will produce more realistic according to the target value. So that's why I'll be investigating the impact of loss function. So here I used a SRDRN architecture. It is called the super resolution residual neural network. It is already been imposed by Wang et al. Into their two of their subsequent papers. So it is a fully convolutional architecture. It has around 22 million parameters. So the problem, it is a synthetic experience-based study. So I targeted a 8-factor downscaling. So the 0.1 degree GPM IMERG data is utilized, and the coarse resolution data is also derived out of it by aerial averaging. And so the three loss function, which is MSE, mean absolute error, and the weighted mean absolute error, I'll be discussing. So to meet the data requirement, I splitted the entire Indian domain into 4 boxes. One is the Northwest box, Central India box, and Southern Peninsular box. So the data from 2000 to 2017 from these boxes are used to train. And for testing, which is the results I'll be showing, is for the entirely different box, where there is no sharing grid, and it is a highly precipitation area of Northeast. So now moving forward to the results, this QQ plot shows the field averaged precipitation values for the test period, which is 2018 to 2020 over Northeast. So here you can see this BCSD, which is bias correction and spatial disaggregation. It is a very well-established statistical downscaling method. So it has certain limitation of overestimating, and so similarly, QDM is another method for bias correction and downscaling. So where the spread is large, when it comes to the SRDRN, it is exactly reconstructing all the precipitation value even at higher percentage. So another important aspect which I want to explain is the how to reconstruct the extreme, because in a warming climate studies related to extreme will be important. So here this is the 99% bias plots from various models for the test period. So you can see in terms of the mean bias, like the BCSD is different, because BCSD, this method is trained over this region itself, and also it has a explicit quantile mapping based bias correction technique. So and this overall this MSE, MI, and WME seems to be underestimating. But when I look into the seasonal based 99 percentile, you can see this BCSD, which is better here, goes far below. And basically this SRDRN models are reconstructing the data much better over various seasons. So this KG score is calculated from the reconstructed 99% magnitude for each season, and it is calculated with respect to that from the IMERG observation. So, so to conclude with, deep learning based SRDRN is trained for greater precipitation downscaling with the 3 loss function, and is compared against a benchmark method, example BCSD. So the MA loss function has a better state. It is a L1 loss, so it has this feature of preserving extreme as well as mean. So also it's demonstrates the potential of AML for statistical downscaling of greater climate. So I'd like to thank my institute, Icrc Bhopal, and my funding agency, PMRF and Inspire. And also I'd like to acknowledge National Supercomputing Mission and CDAC for providing me the GPU computation access.
So thank you very much, Mithun, for completing your presentation on time. So we have a few times, so we have a couple of questions. So, okay.
Thank you for your nice presentation.
Thanks.
So when you select your study domain, so Northeast Indian, including Bangladesh,
Yes.
separated, but other study regions are overlapping.
Yes.
And you showed only the result of Northeast India.
Northeast India.
So what is the reason behind selecting other boxes?
So because I wanted to give this SRDRN a challenging problem, because I'll be training on some particular data, and I'm looking forward to reconstruct that data. So if it is on the same domain, it has some inherent features learned. So I just shifted it to some other box.
Okay, thank you.
Any more questions? So if there is no question, so can you tell me what is the demerit of your work?
So this is fully data driven, and these CNN models are basically called black box. Even though it's giving better results, we cannot explain it completely and understand it completely. But if in other domains and all, if it is giving good results, we can go for it. So that's one disadvantage. but it requires more and more data and more analysis to establish it to an operational way.
Okay, thank you very much for your nice reply.
Thank you.
So now we are going to shift for the next presentation. So next presentation will be future changes in the precipitation extremes over the base Himalayan Uttarakhand region during the southwest monsoon by Athira Maria Jose.
Good afternoon. I'm Athira Maria Jose, and I work as a senior scientific assistant at IITM Pune. My topic is on future changes in precipitation extremes over Uttarakhand region during southwest monsoon. These are my objectives. Evaluation of the 20 next GDP data models for southwest monsoon over Uttarakhand. These are statistically downscaled models from CIMI-5. Then the projection of changes in future changes in monsoon rainfall and rainfall extremes. This is my study area. It's the state of Uttarakhand in the northern part of India. Again, details of the data that I've used, next GDP models, Aphrodite's observation data, and then I've taken into account two emission scenarios, RCP 4.5 and RCP 8.5. These are the 20 next GDP models. Moving on to the result part, here we have the temporal variation of monthly rainfall over Uttarakhand. You can see that the models are able to capture the temporal variation somewhat over almost all parts of the year, except monsoon time. During that time, you can see that there is underestimation of values. And for up-to-date data, you can see that the peak months rainfall occurs in July. In the case of models, it has shifted to August. Here we have the spatial variation of again monsoon rainfall. These are the individual model plots, and here you have the multimodal mean, the observation, and the bias. For Uttarakhand, most of the rainfall occurs in the southern parts of the state, and the northern parts record lesser rainfall, and almost all the models are able to capture that. There is still some negative bias that is happening, especially towards the southern eastern end. This is a simulation of rainfall extremes over Uttarakhand. We have plotted for simple daily intensity, heavy precipitation days, highest one-day precipitation rainfall, highest 5-day consecutive rainfall, consecutive wet days, dry days. And you can see that the models are able to capture some decently, they're able to capture some features. There is inner spatial variation. They're able to capture spatial variation well. But there is still overestimation of values. The models are still overestimating the rainfall extreme values. Moving on to the projections for monsoon rainfall, we have considered RCP 4.5 and 8.5 scenarios for near and far future. In the case of 4.5, in the near and far future, the models project an increase in 10 to 28% of monsoon rainfall. In the case of RCP 8.5, in the near future, the models project an increase in 10 to 22% of monsoon rainfall. In the case of RCP 8.5, again, in the far future, they project an increase in 34 to 43% in the monsoon rainfall. And now we are looking at the variability of extreme rainfall indices. I'm presenting to you the highest one-day rainfall and highest consecutive 5-day rainfall. If you look at the historical period, you can see that the models are overestimating the value. This is the next GDP and this is observation, and the models are clearly overestimating the value. And if you look at the future scenario, all the models are projecting an increase. In the case of one-day highest rainfall, the rate is at 1.4 mm per decade for 4.5, and in 8.5, it is again increasing to 3.3 mm per decade. In the case of consecutive 5-day rainfall, 2.8 mm per decade in RCP 4.5, under RCP 8.5, 7 mm per decade. So yeah, they're projecting an increase in extreme rainfall as well as monsoon rainfall over Uttarakhand. Moving on to the conclusions, the models are able to capture the spatial variation of monsoon mean as well as the extremes somewhat decently, but they still underestimate the mean rainfall and overestimate rainfall extremes. the projections, future projections, they suggest an increase in the rainfall in the near and far future, especially extreme rainfall, 1 day and 5 day consecutive rainfall. This can lead to increased frequency of floods, especially flash floods over Uttarakhand. Uttarakhand, as we saw this year, already experiences a lot of flash floods and floods. So an increase in frequency is definitely cause for concern. That's it for my presentation.
So thank you very much, Athira, for your nice presentation within a very stipulated time. So we have some time to ask some questions to Athira. So do you have, okay.
Thank you for a nice presentation.
Thank you, sir.
Yeah, I saw you have taken the reference period is 1976 to 2005, I think.
Yes, sir.
I was wondering if you take the reference period so close, like recent decades or recent 2 decades, how will be the changes in the far future and near future?
So recent decades, as in?
Yeah, I mean the reference period, if you check with 2000 to 2020.
So the data is not, I think for historical period, I think for next GDP, the data is available only up to 2005. For next GDP, it was only available up to 2005. So we basically took like whatever was
I
the
understand. Okay.
best
Thank
option.
Thank you, Athira. You have actually chosen a complex region for this comparison. I have 2 questions actually. One is on, you are saying that there's an underestimation of the mean rainfall and overestimation of extremes. So does it also mean that you have more dry days in the simulations?
No,
and that's one aspect. The other is, we always consider the observational data as the ground truth.
Yes.
Gospel truth. But there are uncertainties associated with, for example, Aphrodite may have its own limitations.
Yes.
So sometimes we may be actually being unfair to the models by trying to compare them or evaluate them using data that are inherently uncertain. There is uncertainty.
Yeah.
So have you actually considered looking at different types of observational data sets and the kind of problems associated with Aphrodite itself to make sure that we are making the right comparison?
Yes, sir. To answer your first question, we have, I'm actually showing only a very small part of my research, and we have actually plotted for consecutive dry days, and consecutive dry days are actually decreasing. Consecutive wet days are increasing and consecutive dry days are decreasing. And to answer your second question, we have also considered IMD data, and IMD and Aphrodite in this case almost follows the same pattern. And we found Aphrodite the best app for this work, and which is why after comparing both the observation data, we chose Aphrodite data for this work. So yes, we did look into it.
Thank you.
So it's a kind of extension of this comment. So first thing is that whatever you are using is a GCM downscale product, and over Uttarakhand, where the grid box may be 1 or 2.
Yeah.
So it's very difficult when you do these things for a research purpose, it's okay, but when you publish it or for some decision making, this results is obviously have to be very careful when we talk outside. Another point is that when you look into the station network in that area, there will be hardly any stations there.
Yeah.
So everything you are taking from valley to there, and then your whole results will change.
Yes,
so that's one comment. Another, probably you can use other data because your everything is ready. You just have to change the data, and your results will be a little bit different, I'm sure.
Okay. Thank you, sir.
Thank you very much. Any more question? Okay, so just I have a quick question. Have you downscaled it?
No, sir. These are statistically downscale data already available. Next GDP, it's an NASA.
Actually, in my previous talk, I have shown that rainfall over Western Himalaya is going to be decreased.
Yes, I did
Even
notice.
is a decrease, but you have shown it is going to be increasing. But extreme is something else. It is very good. So if it is going to be increased, so how frequently it is going to be rain, or how frequently it is going to be dry? That is the main issues for our future research. Okay, next.
Thank you.
Yeah, okay. So he's saying that next speaker is in online mode. So identification of suitable predictors for statistical downscaling of rainfall over Indo-Gangetic plain by Ratul Rai Chaudhuri. So Ratul, please start.
Yes, sir.
You start?
Yes, sir.
Okay, you start. Quickly, you have 5 minutes.
Yes, sir. Good morning, everybody. My name is Atul Rai Chaudhary, and I am here to present my presentation.
So directly go to your talk. You don't have to give your introduction.
Yes, sir. I am Atul Rai Chaudhary. I am currently pursuing my PhD program in Atmospheric Science Department in University of Calcutta, and University of Calcutta under Professor Subrata Kumar Midda and Professor Lalu Das. And I'm here to present my presentation. I'm here to present my presentations titled as Identification of Suitable Predictors for Statistical Downscaling of Rainfall over Indo-Gangetic Plains. Introduction.
Can you stop your presentation for a minute?
Yes, sir.
Hello?
Yes, sir.
Ratul, please can you check your YouTube?
YouTube?
Huh? So you are not using the YouTube?
No, sir. I'm using Microsoft PowerPoint. May I carry on, sir?
Just please wait.
Oh, okay, sir.
Ratul, please continue.
Okay, sir.
Your PPT, please open.
Oh. Okay, sir.
Okay. So full screen, you can make it full screen, Ratul.
Oh, yes, sir. Okay, sir.
Yes, you continue.
I'm giving my presentation on the topic of identification of suitable predictors for statistical downscaling of rainfall over Indo-Gangetic Plains. Introductions. Rainfall is a major input for agriculture system and highly erratic in nature. And the unusual behavior of rainfall can have indirect or direct impact on the agricultural activities, and thus is very important that downscaling of climate models it's very important and it is very important that downscaling climate models that can provide the fine-grained information about future climatic condition in the Gangetic plain, as this plain is the most agriculturally productive, and thus it can help the farmers and policymakers for to make more informative decisions. And now statistical downscaling relies on heavily between the large-scale predictors and local-scale predictant, and this process is known as PP downscaling, that is perfect prognosis. And for PP downscaling, the finding of suitable predictors is extremely important. So this presentation will focus on this aspect. Now, the objective is currently the objective is to identify homogeneous rainfall zones of IGP through K-means clustering analysis and to find the best performing predictors in each rainfall zones for IGP in each season. Now, IGP covers 600,000 kilometers square between 22 to 32 north and 74 to 92 east longitude, and it is basically a flat terrain with rich fertile soil and with accessible groundwater. And as for observational data, we use the IMD grid data with high resolution, and as for predictors, we use the 21 NCEP and Caribbean data and 1 sea surface temperature data from NOAA. And these are the list of 22 predictors: geopotential height, U winds at different pressure levels, specific humidities and relative humidity in different pressure levels, and precipitable water content, mean sea level pressure, precipitation rate, and even mean sea surface temperature and mean of 3.4 zone. Now, the K-means clustering algorithm, which we'll be using to categorize, to find the several homogeneous rainfall zones. It is first proposed by McQueen, and it basically divides the data points into K distinct clusters. Now, for the features of the to find the rainfall zones, we will use each total rainfall experience in each season as the features during the time frame of 1961 to 2020. And as for the measuring the evaluating the optimum number of clusters, we use 3 scores. That is CZ. First is CZ score, Helsinki-Harbour score. This is the formula. Second is scale score.
Atul, please come to the result.
Okay, sir. Okay, sir. Result and discussions. Here you can see that these plots are CH score plot to find the optimum number of clusters. Here you can see the number 3 and number 3 for pre-monsoon season, number 3 for monsoon season, number 2 for number 2 for post-monsoon and winter season. So you can see that the cluster 3 is better here and cluster 2 for better here for post-monsoon winter. Similar case we will find in the KL score as well. And as for the DB score, we find all 3 seasons. In all 3 seasons, the optimum number of clusters is 2. So we will categorize the IGP in the pre-monsoon season as 3 clusters, and for the monsoon season we will also place 3 clusters, and for post-monsoon the winter season we will choose 2 clusters each. And these are the illustrations of the homogeneous region, and these are the box plots. Okay, sir.
So you conclude?
What, sir?
You conclude? You go to the last slide and conclude it.
Last slide. this is the best performing predictors for R square to find the how good our fit for multilinear regressions, and these are the values. These predictors perform well during the calibration period for monsoon season. These predictors.
Ratul, please go to the last slide. Your conclusions.
Okay, sir. Conclusions: the homogeneous pre-monsoon, monsoon, post-monsoon winter rainfall zones in the IGP region were obtained using the K-means clustering algorithms. Two out of 3 scores identified 3 homogeneous pre-monsoon and monsoon rainfall zones. 3 out of 3 indices identified 2 post-monsoon and 2 winter rainfall zones. The IGP region receives highest rainfall in pre-monsoon season, followed by highest rainfall in monsoon season, followed by pre-monsoon season. Majority of IGP experiences rainfall during the minimal rainfall during the winter seasons, and the performance of predictor is worse in sub-Himalayan part of the Bengal. In pre-monsoon zone 1, zone 2, and zone 3, IGP best performing predictors are precipitable water, U wind at 850, U wind at 1000 respectively. And for monsoon season, for monsoon zone 1, 2, 3, the best performing predictors are V wind at 850 MB, U wind at 500 MB, and precipitation rate respectively. And in both post-monsoon zone, post-monsoon rainfall zone 1 and zone 2, the best performing predictors are precipitation rate. And as for the winter rainfall zone 1 and zone 2, the best performing predictors are greater humidity at 500 and precipitation rate respectively.
Okay, thank you very much, Ratul, for your nice presentation. Although there was some systematic problems, but you have concluded. You have prepared a lot of slides and you have presented very nicely. So thank you very much, Ratul. So we have some times to interact with Ratul. Do you have any question? So do you have any question? If there is no question. Okay, so thank you very much. So this session is actually one more lecture, but she is not in the in that system. So he's actually off. So we are going to close this session. So there are 4 lectures. So 4 presentations. They are all are basically 3 are from advanced machine learning based presentation and in different location. So they showed that how the downscale using the machine learning algorithm is going to be improved a lot for different location. One is for city location. They are going to say that extreme warming or cooling or precipitation using the machine learning, deep machine learning algorithm. And another one is on the Indo-Gangetic plain, and another using the machine learning over the Western Himalayan region. So all these informations are actually providing useful for the CORDEX domain for South Asia region. So with these small comments, I just wanted to thanks once again to all the participants, the speaker and audience. And also I would like to thanks organizer for giving me this opportunity to act as a chair for this particular session. So thank you very much for your attention and opportunity. So I am just handing over the microphone to.
Yeah. Thank you, Professor Das. So I request Dr. Sanjay to kindly felicitate the session chair, Professor Lalu Das. Yeah. So now quick announcements. So first thing is TA claims can be submitted today at the Varahmir Hall reception area between 16 hours to 17 hours local time. Then participants are requested to be present. Again, I am repeating this. Participants are requested to be present during the sessions and mark your attendance in the morning session as well as during the afternoon. You may assume it as a necessary condition. Okay. So in order you to get the certificate. And the third is we will now break for lunch. And again, it is arranged at the Meghdoot basement. And we will reassemble here at 1 p.m. Yeah, posters are being displayed in this yeah. So yeah, let us quickly have our lunch. Yeah, thank you.
So good morning, everyone. Good morning. Great to see you all networking. Great to hear you all networking. Good morning, everyone. I'm glad you survived the heat yesterday in the afternoon and evening, and to make sure you drink enough. We should have more water today. At least we tried to organize a bit more water. It is for some of us, maybe not for all of us, but for some of us, an interesting future climate, which we experience already inside here, which we do not want to have everywhere around us. So I'd like to welcome you to the second day. I think we had a great day yesterday with lots of very good opening, interesting statements in the opening, I must admit. I also think we had 3 very interesting scientific sessions. It was a bit presentation heavy. So the next day, today and tomorrow, will be much more interactive, so that we have both in such an international conference. So let me guide you a little bit through the program so that you know what we are expecting from today. We do have a very interesting panel in a minute, and then after the health break, we have the insight session on what we learned yesterday in A1, 2, and 3. And then we have a discussion about future scientific developments in CORDEX. And I do think what we could see yesterday is that there's a bit of a strategy missing. So if you think about it and get engaged and be prepared, we would like to get you on board here and to ask you to give your information, your concerns, your views, your suggestions for the future. This will be organized with the SAT members and co-chairs and Silvina and myself and the session chairs and so on. And then I'd like to remind you that we do have a lunch break, and in the lunch break we have a meeting with the FPS PIs, the SAT and the POCs. You remember the email from last week, where we said we would like to meet you for a lunch to discuss a few structural things. And I would suggest that we meet here immediately right after the end of the morning session and not meet outside in the heat. So let's stay here for a moment and discuss a few things, and we organize somehow that you will not starve and die from not eating. So we will make sure that you also have time to eat. So that's in the lunch break, so don't run away after the insight session. Then in the afternoon, we do have this, we start our interaction with society. And this is not transfer to society, it's interacting with society. And there will be an interesting discussion too. Then again, your turn in the insight session from the pilot flagship studies, which is from 4 to 5. And it's important that you also make up your mind during the day what you think about the flagship pilot studies. Is this a good instrument? The FPS PIs should have gotten 2 questions or 3. If not, doesn't matter. I know you're all excellent scientists and you know everything at the spot. So if you see the question which you get on the panel, you will be able to answer. So we would like to have from each FPS 1 representative on the panel in the session from 4 to 5. Immediately after this session, we have a poster session. This means those of you who have still left the posters in the places, please take them down in the break. So in this morning break, so that others can put their posters instead, and the new poster session for the session B is prepared when we go there at 5. The SAT members meet immediately after the flagship pilot flagship studies session at 5 here for a 5-minute wrap-up for today and to prepare for tomorrow. Irene, did I forget something important on organizational issues? I don't think so. So have a nice day and please get engaged. And I pass the microphone to Irene, who is moderating the first session. Thanks.
Thank you, Daniela, and welcome all to the second day of the CORDEX conference. Nice to see you. The doors are open today, so we hope we will be a bit cooler than yesterday. Today's session is a panel discussion, and we have our distinguished panel here, Bill Gutowski, former co-chair of CORDEX. Then we have Linda Mearns, who's been in CORDEX for a long time and is a point of contact. And of course, Silvina Solman, who is one of the CORDEX co-chairs, as you know. Then we have Erika Coppola, who talked yesterday, twice maybe even, yeah. And then we have Ramon Fuentes Franco, who used to be an ICTP student. And then our second co-chair, of course, Daniela Jacob. So this is the panel. But as you see, there is also an empty chair at the end here. And this is where a specific special person should sit today for this discussion. This person was one of the founders of CORDEX. He's been doing this for a very long time. We owe him a lot. He's also soon retiring. And maybe you can guess who it is. Please welcome up Filippo Giorgi. Sorry, Filippo. We have tried to keep this a secret as much as we could. And all these people now, they will talk a little bit of what Filippo did or maybe didn't. So let's see. And Bill, he will start giving a bit of an overview. And before you start, Bill, just so you know, if you are getting too long, if you don't keep your time, I'll let you know.
I'm hard of hearing.
Oh, yes. Yes, please go ahead if you want to sit down there. And then I'll let you know when you should come up.
Okay.
You can stay there, Linda, if you prefer.
Okay. All right. Yeah, it's quite a pleasure for me to honor the legacy of Filippo. I want to give thanks to all the people that I have encountered and worked with over many years, because one way or another, they informed what I have to present today. So the beginnings for Filippo: grew up in a small town of Sulmona, Italy, central Italy. And from there, he started his university education about an hour's drive up the road at L'Aquila, I think you pronounce it. Sulmona is a relatively small town of 25,000, so you might say fairly modest beginnings. But from that start in that region in central Italy, Filippo extended his reach to cover regions around the entire planet. And I think it's especially appropriate that there is Africa showing up in this picture here, because Africa is one of the regions where he had a substantial amount of his influence over the years. Filippo was involved with the very start of regional climate modeling, as Irian mentioned. This was some work that initially he did with Robert Dickinson and some others at NCAR, and it was climate sort of by simulating 6 winter storms using storms that had been generated in the NCAR model of that time, CCM1, with this resolution of 4.5 by 7.5 degrees, and they put that through this forecast model MM4. They looked only at the western part of the United States, and what you see on this figure is the topography. You probably can't see all the details, but what I would point out is that, here we go, that in the more refined topography, you have the Sierra Nevada Mountains and the Rocky Mountains, and in the CCSM1, it was just a big hill. And they were wondering just what this might mean for the hydroclimate, in particular of this region that I've highlighted here, which is where the United States had planned to put a nuclear waste repository called Yucca Mountain, and wondering how that would change going into the future. That was a very simple beginning. But from that beginning, Filippo took that and started to run in all sorts of directions with regional climate modeling, doing what I would call the first real climate simulations of a month, very modest by contemporary standards, but beyond the forecast period. And he did this several papers here, but what was really astonishing to me was looking at all the other papers he did over this 4-year period. I was certainly aware of a lot of these papers way back then, most, if not all of them. But in going back and reviewing this, it just was astonishing to me that he did all this work in about a 3 to 4 year period. And as you can see by these various topics, GCM nesting, climate change, validation, lake feedbacks, lower boundary conditions, he was really laying out the whole framework for what regional climate modeling is all about, all the directions that need to be explored, and all in this very early period of his work. Very remarkable that he really set the stage in many ways. He didn't just start doing regional simulations. He was exploring the whole realm of what's possible with regional modeling and what needed to be explored more deeply. Because of that work, a community started to develop of regional modeling around the world. And Filippo was very, very central to this first project to intercompare regional climate simulations, one of the very first, well, the first intercomparison project involving regional models. Part of that was Filippo's, sorry, wrong way. Filippo's own model now, which was now RegCM2, it had advanced to its second phase, but there is a community developing around the world. The Darlam model was a model from Australia, a model from Denmark, Hirham, and then various models in the United States, the regional spectral model, the regional atmospheric modeling system. Filippo again played a very central role working with my colleagues, Jean Tockley, Ray Arrett, and myself in organizing and setting up all that needed to be done for this project. There were 8 models that were involved, and their grids, the outer part of their domains are identified here, covering this region of the central United States. Simulations that were maybe slightly longer now, 2 months instead of 1 month, still very modest by today's standards, and focused on 2 extreme periods, trying to understand how the models would behave differently between these 2 periods. The resolution was about the same as what Filippo had done in his early simulations. Filippo played another key role for us in that he had already started networking beyond our community with other folks. And because of him, we were able to get funding for this program from the Electric Power Research Institute, EPRI. And again, that was because of Filippo's efforts extending beyond just the modeling itself. But you can see that a key aspect of all this was that there was a community that was starting to develop, inspired by Filippo's initial work. And then came the big move. Filippo moved to ICTP here in 1998, and he became the founding head of this Physics of Weather and Climate group. And there are many reasons why this move was so important for us, as well as for Filippo's career. Part of it was that it involved a recognition of regional climate modeling as part of ICTP's mission to the world. We heard yesterday about how ICTP's mission includes trying to foster good science around the whole world. And this move here showed that it was a recognition that regional climate modeling is an important part of that. It also meant that there was an institutional focus on developing, documenting, and maintaining RegCM, which then led to the development of RegCM3, RegCM4, and then beyond that, RegCM5 now, and hopefully on into the future. And equally important, and I'll come back to this point as we go along, there's an institutional focus on developing and maintaining a global community. Again, part of ICTP's mission, but something that Filippo grabbed onto and really took in a very strong way going forward. And we see this in this next slide, which is a slide that I managed to get through Filippo. This was back in 2010 when he was recounting the history of the development of RegCM. But I think this slide really captures an awful lot of what Filippo accomplished here at ICTP in terms of that outreach, forming this regional climate research network, or RegCNet. Among other things, we see that they're started developing a contact list. At that time, over 700 people. I'm sure it's much larger now. Working with people in all sorts of regions around the world, working on regional climate modeling in all these different regions, exploring what could or could not be done with regional climate modeling. Interactions with other international programs, a visitors program, collaborative research projects with other people, and the development and use of ICTP model tools and data sets. And especially I want to highlight these workshops that were held at ICTP and other places around the world, training workshops. I was very honored to be one of Filippo's teachers at these workshops. And what I think is even more important and even more satisfying is I look around and I see all the people who came through these workshops and how they have now moved on to become leaders in regional climate modeling in various ways around the world. Lead authors, coordinating lead authors for IPCC reports, and going on to perform important roles in CORDEX, including becoming one of our CORDEX Science Advisory Team co-chairs. It's been so great to see all these people who came through Filippo's training, moving on and really establishing substantial leadership in our community. And Filippo really fostered that in so many ways. And there are so many different topics that were now explored, but they really sort of extended outward from all the foundations that Filippo had set up in those very early simulations. But being here at ICTP with that strong institutional support gave him opportunity to move forward in so many ways. So there's this really well-established foundation that Filippo had set up that allowed us to start to move forward even more strongly as a global community. But there are also some headwinds that regional climate modeling was running into. The WCRP, and in particular, the Working Group on Numerical Experimentation, had a lot of skepticism about what regional climate modeling could do. They didn't view it as being something that was really a valid way of approaching climate. In fact, I remember one of them commenting to me that they thought regional modeling was mathematically ill-posed. I couldn't answer that question at the time, but as I looked into it, this is not a topic for now, but it occurred to me that, well, global climate modeling is actually mathematically ill-posed if you want to present that as an issue, but that's another topic for another time. Despite all these headwinds, regional modeling was growing and developing and expanding in large part because of the efforts of Filippo. And so as a consequence, they finally had to recognize that it wasn't going to go away. And someone there recognized that, oh yeah, okay, this is some kind of a practical tool. And so they formed this task force on regional climate downscaling back in 2008. Filippo was one of the co-chairs of this task force along with Colin Jones. And that led to the initial framework and development of CORDEX. What's shown here is the initial map of domains. CORDEX developed as an outcome of other regional modeling programs that have been going on in different regions around the world. Ensembles in Europe, RMIP in East Asia, CLARIS in South America, and NARCAP in North America. And then Africa is highlighted here in white, the region that became the African region, because it was recognized that we needed to focus especially on Africa because so little climate information about Africa was appearing in IPCC reports and other reports. So this task force developed and worked towards the development of CORDEX. So that meant then that, in addition, that meant that now CORDEX was firmly within the WCRP family and recognized as a program within the WCRP family. But that wasn't enough for Filippo. We still had CORDEX moving along, more regions coming into play, more models getting involved. But Filippo also started these flagship pilot studies. These are studies we saw a little bit about yesterday. We'll see even more today. Studies that were there to try to advance what regional climate modeling can do in so many ways, exploring new methods, new ways of providing information for the larger community, all sorts of different ways of advancing regional climate modeling. I believe there's close to a dozen of these flagship pilot studies now. So Filippo was not content simply to have CORDEX in place, but to move it forward. And then in more recent years, the WCRP developed a new strategic plan, underdid some reorganization, developed an implementation plan to go with that strategic plan. And as part of that, we heard this yesterday from Detlef Stammer, there was this core project, Regional Information for Society, where CORDEX is really the central focus, or at least a key player in the RIFs. And both of them are contributing substantially to these flagship pilots, these lighthouse studies that Detlef also mentioned yesterday. So there was a lot that Filippo did to get us to this stage. Filippo was co-chair of the CORDEX Science Advisory Team that came out of this task force for many years, up until about the time that the WCRP started to transition to its new format. But the foundation was all laid and really promoted by Filippo. And I want to finish off here talking about a couple of recognitions that Filippo was part of. We all know that the IPCC got the Nobel Prize, the Nobel Peace Prize in 2007. there are literally thousands of scientists who had contributed to the IPCC up to that point. But Filippo played a central role in this too, by being vice chair of the Working Group 1 Bureau from about, I think it was 2002 or 2003 up through 2007. But what I think is even more important was Filippo won the Alexander von Humboldt medal from the EGU in 2018. And I want to highlight this because it really pulls together all that he did through his work here at ICTP, fulfilling ICTP's mission in so many ways. And this little quote coming from the document, the commemoration of this effort, talks about how he has a unique combination of academic excellence and a sharp awareness of local needs in developing countries. The academic excellence referring to all the very rigorous work that he did developing regional climate modeling and pushing it forward as a scientific discipline, but also using that to advance the needs of developing countries. Filippo's received many, many other honors and recognitions. I want to show just one last one, which is that he also was given you might not be able to see the bottom, the keys to the city of Trieste in 2007. So I want to say, while you're here, if there's any place in Trieste you want to get to, please go see Filippo because he has the keys to let you in. So just pay attention to that. And with that, I will say my thanks to Filippo for all your contributions, all that you've done to help our whole community move along, and everything that you've also given to the rest of the world. Thank you.
So thank you, Bill. You really kept the times. I didn't need to use this. So, and now
I can talk more.
No. You get your chance after. Okay, so now it's Linda Mearns who will say a few words. So you're up.
Grazie, Massimo. Prego. Oh, is that
Forward, backwards, you press 4 point.
pointer? Ooh, it's a hell of a pointer. Okay. So why are our names presented the way they are? Because Filippo and I would do this silly thing of saying our names like Filippo and Linda in our emails and sometimes in person. So, so I've probably known Filippo here longer than pretty much anybody, which is nice. It's been a good thing, which is truly a miracle. All right, so I'm just going to, Bill has already gone through this, but I'm, saying that in particular, I got to know Filippo around the time of the birth of the RegCM system in 1989. But actually, very few people probably know this, that when I met him first, he actually had a beard. And I can't remember why he shaved it off, but it was an improvement, I think. Yes. Wow. Okay. Glad I asked. All right. You can bring this up again when you say something a little later. All right. So here is the very young Filippo Giorgi, which with brown hair and more hair. And yeah, this is a very nice portrait of him, I think, sitting out on the terrace of the Mesa Lab cafeteria. Then we have the granola bunch. All right, this is not actually, the granola bunch was this group that we were in a group called the Interdisciplinary Climate Systems Group, headed by Stephen Schneider. When Stephen left, we were reabsorbed into another group, the Climate Change Research Group. I think this is kind of a transition picture. Anyway, you can see here Filippo, Rosaria, Stephanie Shearer, who was the secretary, Christine Shields, who was an important associate scientist working with Filippo. And quite frankly, I can't remember the names of the other people. I'm there too. But yeah, this was a very nice, it was a very nice congenial group. And I have no idea why I'm holding a gingerbread person. Perhaps Filippo can enlighten us. Okay, so the wedding, here we are. Rosario, Filippo, and I, and Stephanie in the corner there. So this was a very nice, happy event, and I had the privilege of acting as Filippo's best person for the actual wedding, which preceded this. But yeah, it was a very joyous occasion. The anecdote. Okay, so here we get to the key part of this, which is actually follows a bit from some of the things that Bill said. What young scientists in a new field have to put up with. And Philippe, I don't know if you remember this, but we were working on a proposal. I think it was the Great Lakes proposal, the Great Lakes proposal. And it was submitted, but then somebody from the agency to which we submitted it, I think it was NOAA, but I'm not positive. Some ecologist from that agency was in some meeting in Russia and was talking to somebody, and that somebody said, oh, regional modeling, it's not valid, it's garbage. And so this ecologist came back to that agency and said, you know, there's some really serious questions about this technique. Now, of course, this person was an ecologist talking to another ecologist who knew nothing about climate modeling in general. And so, but because of that, we then had to go around and get letters from the heads of various GCM enterprises indicating that this was a good technique, that Filippo and his colleagues were up to snuff scientists. And I remember we got one from Warren Washington, who was a major global modeler at NCAR. And so we submitted these letters. This was after the proposal had been submitted. And so we got these letters and sent them in, and then they were sort of like, oh, okay, well, I guess these people think this is okay. Then it's okay. So I think that's a very interesting story in terms about how science progresses or doesn't. And I think that might be the end. Is that the end? Oh, no, the New Yorker cartoon, which I always end with. So you can see the statue of, not the statue, the Empire State Building. Where are you? Hello? Isn't the center thing the pointer? Oh, the top button, thanks. All right, so that's the Empire State Building. I really like this cartoon, but I realized I could actually calculate how high the sea level would have to be for there to be those many floors still visible. And the good news is that that level of sea level rise is physically impossible. So I was considering writing to the New Yorker and saying that they were being over catastrophizing climate change. Anyway, So that's all I have to say, except that knowing Filippo certainly has been one of the great scientific and personal privileges of my life. And I am so glad to be here today.
Thank you, Linda. And now it's your turn, Silvina. So you're up.
You can just sit there. You can just sit there.
Okay, I don't have slides. I just have some things to say. Inspiring. This is the word that connects me to Filippo. I started, I knew Filippo during one of these training activities here in ICP 20 years ago. It was, I'm sorry, the ICTP workshops on the theory and use of regional climate models. And it was the first edition of that workshop. And I came here as a student, actually, and Bill was one of the teachers, together with you, of course, Filippo. And that was very inspiring for me because I was not in the field of regional climate modeling at all at that time. And I really enjoyed the activity. I learned what the regional models were. I started performing some initial simulations. At that time, the simulations we used to do was sensitivity studies of the Rexian model over different regions. I'm from South America, so the region I chose was South America, together with some of the participants that at that time are here today, Rosemary, Chris, Leonard, and many people who are here today as well. And we started those exercises with the regional climate models. And I was so enthusiastic with those, with that idea that I went back to my institution. And of course, I started to work with the regional climate models. I have to say that I did not work the RECSIM at the time, but I started to work with the idea of using regional climate models for understanding regional climate circulations and to providing information for adaptation measures. And in fact, that initial seed grew in my career. It made me grow in my career because I started a research group at the University of Buenos Aires. And I also introduced the topic of regional climate models in the postgraduate courses in the atmospheric science at the University of Buenos Aires as well. So it was not only me, but it was only a number of people around the scientific community within my country first, who started to learn about why these models were useful for, and to try to get involved into the use of those activities. But then I came back again in 2004 for the second edition of the workshop as a follow-up of the activity. So and we met again together with almost the same participants, and we really did some very interesting progress. And what I felt as the most important thing for that time was the networking. We could start a network within the regional scientists, but not only from my place, so South America, but also regional scientists from other continents of the world. And that was possible only because we started with that activities here with you, Filippo. And then as the interest and the idea of the regional climate models grew, as mentioned, as Bill already mentioned, the CORDEX idea was starting up on those days. after the task force, I became a SAT member in 2011. So in that time, I had the opportunity to learn a lot about your leadership and your vision on how to provide the community tools to improve their science and to improve the ways of understanding how climate change would affect their own regions. And that was amazing because I took this idea and I encouraged also people within South America to follow that path. So I'm thankful to you and Colin Jones at that time who encouraged me to gather the community in South America and Central America. We finally organized a network of scientists within the regions, which is amazing. And we are more than 300 people there working, talking about the regional issues and gathering from time to time in different activities related to associated with CORDEX workshops as well. So I can give more examples, but I want to emphasize here is that you did some very important imprint on my career, because I'm co-chair of CORDEX, I'm co-chair of RIFS, this core project of WCRP. But all the way through, since my beginning in this arena, I really enjoy your leadership, your enthusiasm, and as I said, your inspiration. So I have to say thank you, Filippo.
Thank you, Silvina. And now we're going to hear online from another person who was also at the start. So there will be a short video from Colin Jones.
Hi, Filippo. Greetings from Hadley Centre in Exeter. I just wanted to send you a short video at the time of your retirement, wishing you all the best for the coming years. It was a real pleasure to have you as both a work colleague and a friend. And I think I first really got to know you well around about 2007, when we started developing the first ideas for what became the CORDEX project. You were clearly one of the driving forces behind that. And you've stayed with the project ever since, over the past 15 odd years now, and helped make it into the truly international scientific and collaborative activity that it is today. And I hope you look back on the period of the last 15 years, and of course, maybe the 25 years in advance of that, and all your work to develop both the discipline of regional climate modeling, the delivery of regional climate information into both the policy arena through Icrc and directly on the ground, both in Europe and all around the world. And also the tremendous work you did supporting the development of climate science and climate capabilities and research in the Global South. You've been definitely a forerunner on all of these and an inspiration to many of us. I hope you have a great conference in Trieste, and then I hope you have a relaxing and enjoyable retirement, that you spend time in the sun, that you find time to get cracking on your novel, and that you also find a little bit of time to keep an eye on the Azzurri, playing both with the round and the oval ball being, of course, the more important of the two. So it's been fantastic knowing you, fantastic getting to visit you in Trieste and having conferences with you, work with you, and developing the whole of the CORDEX project with you. You've been a real inspiration to many in the field and a pleasure to work with. And I just wish you all the best for your retirement and for the coming years. And I hope we get to meet again soon, either in Italy or here in the UK. All the best, Colin.
Okay, so thanks to Colin, even if he can't hear it. Now the next speakers up are Erica and Ramon, who will have a joint presentation.
Okay, so because not everybody was able to, I mean, we could not ask everybody to join the panel because there are really too many all around the world to thank Filippo. Then in this presentation with Ramon, we really want to show the impact that Filippo had in the life and the career of many of the scientists that are related to our ICTP life. So when he started in 1998, for sure Filippo was not aware of how many citations he would get in the next coming year. We know all that is one of the most cited scientists in this field, for sure in Italy, but also abroad. But today we want to add some more citations to his list, together with all our colleagues. So the first, it's Franco that is with us online, that tells that Filippo's legacy at the CTP and in the wider climate community is exceptional, and is wishing you to find a new reward and satisfaction after the retirement. Then we cannot avoid to wish Filippo a very nice retirement, but not too much. So Fred is thanking him for granting as much academic freedom as possible. I'm thanking him for allowing my research to flourish within this community. Adam is highlighting your achievement in science that were astounding. And Karim is thanking you for your non-intrusive leadership. But also staying in SCTP, we have Rita that not only for science, but is thanking you for the passion, for the dissemination that you inspired her, and Francesca for your 5-star collaboration. Graziano is thanking you for your trust that you put in him and the code that you delivered to him, and he pledged to keep adding mostly bug-free new feature in the code, and Emanuela for your ever young and enthusiastic soul. But we are not the only one, because there is an entire world there for ready to thank and to show what is the impact you had in the career. So we have Rosemary, Silvina, and Thomas, and Teresa. They are thanking you for the inspiration and to be part of this journey. Silvina, as you just heard, thank you for being an inspiration for our future career, as well as Thomas. And Teresa, because you say you are our favorite scientist in the world. And also Ramon, that is here with me, that is telling that if you are boosting him from being a young PhD scientist to a permanent scientist in the Rosby Center. Chaba for your open friendship, and Faisal for the contribution in his scientific life. But we also have Daniel for thanking for the guidance, and Mutasim for instilling in him his climate scientist, regional climate scientist character. And then Alejandro that highlights how you're sharing knowledge and respecting everybody's input is a true inspiration, as well as James that say that you are an inspiration for work hard and take the responsibility to influence the public and the stakeholder. And Abram that is recognizing you as a big mentor, friend, and one of the best scientists that he knows. And then we have Fabian that is also recognizing how impactful was your support and trust, and for having made possible this unique opportunity. And Russell for the working in this inclusive atmosphere and the freedom in the research. And also Tadasse for teaching him all the science about regional climate modeling, and Sushan because he learned and grew and went back to India to initiate his career over there. And Ashraf also is wishing to thank Filippo and all his family. But to end with, we have also our dear colleague from Seoul, that she's still remembering how astonished she was to meet such an handsome, stylish, and sweet personality, top scientist. And she said that this was really something impossible to find in Korea. This is why she never married and is still single even today. All these factors say that thanks for the interaction with Filippo in the first paper, she became a tenure track at HCAST, and now she's saying that none of these success would have been possible without him. And then Marta, that is recognizing to Filippo the fact that for the first time she felt treated as an equal, and it was a very transformative experience in her career to come to a CTP. And then the last one is Bamba, that he recognized to Filippo the merit to see the scientist he could become, and he also recognizing the support that is Filippo giving him constantly, and he gave during his career, and even now that is the head of his group in the Africa community.
Well, we got a very diverse stories, of course, but we wanted to summarize in some shorter story. It was not easy to summarize in a short story, but in a word cloud, you could see that when you put all the text that we received that were really long, well, the words that they use describe an accomplished scientist named Filippo. And he has been dedicated many years to work in ICTP, and he has played a significant role in promoting the use of climate models through workshops. Additionally, he has provided opportunities for young individuals from all over the world to grow and become climate researchers. But beyond that,
we need to one more slide.
Yeah.
And we are done. Okay, sorry. Okay, sorry.
okay.
Yeah.
Beyond the, well, if you remove all the scientific words, there is a person behind that is describing the relationships. And then these relationships are showing that it's a first time and years later, it means that it's a relationship that lasts, using words like memory, today, always, life. A person that is guiding person, they use words like grateful, support, then mentoring, growth. It's a reachable person, which gives freedom, and is and a person that understands. It's a community building person that brings people together, that is prone to conversation, that collaborate, and with who you can establish a strong friendship. And they use other meaningful words like kind, best, good, miracle, wish, which is quite inspiring for us. Thanks for everything, Filippo.
Thank you, Ramon and Erica. Those are really nice words. And yeah, you can be proud of your husband, Rosaria. Okay, now the last on this panel to speak is our co-chair, Daniela Jacob.
Thank you very much. Filippo, I spent a year at NCAR in Boulder, and I got this invitation by rumors to one of those famous Italian parties, which are happening every other weekend in the summer '92. And someone told me, you want to come with us? It's all Europeans. Actually, it's only Italians. I said, okay, I'm German. Oh, yeah, they might let you in. And where is it? Didn't you meet Filippo Giorgi? I said, no, not yet. So come to the party, to one of those famous parties in your backyard in summer '92 in Boulder. That was when we met for the first time. I was a bit shy at that moment because I thought, I don't know Filippo, I'm not Italian, I can't go just to a party, you know, where I know no one. But it was such a nice experience, and you were so open. You looked at me a little bit, who is she? But from this first moment on, I think it was an experience to share with you 3 decades of scientific work. There were maybe 7, 8 years in between where we only met twice or 3 times. But I think it was something which inspired my life for sure. I was doing snowstorm modeling. I learned all about nesting at NCAR at that time with Terry Clark and others. And when I came back, I started to work on regional climate. And we have Ole sitting here in the room. And with Bernhard Machenhauer and Jens Hesselberg Christensen, we were asked, Burkhard Rockel is also one of those, we were asked to develop a second regional climate model in Europe. You know, have you heard about this regional climate model, this guy Filippo Georgi Rek, something? We should be able to do this. We should be able to do something similar. And it was Bernhard Machenhauer who pushed quite a bit at that time. And I think it was good because it was a healthy competition starting at that time. It was good to carry out try the different numerical schemes, try the different ideas, work with different weather services. And at that time, Bill, what you said, Hirlam plus Hamburg physics, that's where the Hirham is coming from, and Remo started. So I think that was very good because, as you said, there were lots of headwinds. And the more were involved in regional climate modeling in the dynamical downscaling, I must say at that time, the better it was to join forces against global climate modelers, against numerical weather prediction. And there was this working group on numerical experimentation. You also pointed to this. And we, of course, were engaged and discussed with them. And there was same like the working group on coupled modeling. And I remember I can't remember when it was, but I remember at one point when we discussed a lot with René Laprise and others, and then you came to me and said, I cannot talk to them again, you must do it. So, and I think this was exactly what was accompanying your career. We heard a lot about all your successful steps forward, which I can fully support, and I'm really glad that I was part of it. But I really admire how you stayed calm and did not let it go to fight against all the hurdles and all the difficulties, because you were convinced this is what we need. You were not so convinced about empirical statistical downscaling. So that took some time, I would say, to get the dialogue going, but I think that is exactly how it goes. We need a lot of discussion and we need a lot of dialogue. I think what I would like to mention is your strategic thinking, not only your, I would say, long-term breadth to push forward what you think is important, but also your strategic thinking. It was the CORDEX core, which has not been mentioned yet, in addition to many other things. The flagships. At one point you said, don't you think we need a strategy? And it was always you pushing forward the CORDEX community. And I think this is something which we will miss. And I hope that you will share with us during the rest of the conference what you have as a vision for CORDEX in the future. Now I think we reached a lot in this community. We heard yesterday about the scientific progress, which can be a bit faster, I must admit. But we also heard about the very nice words from Detlef Stammer, which were different on the last CORDEX conference, as several of you remember. So what has happened is that you pushed the field into a position that there's not only a huge engagement of the community all over the world, but it is also recognized. It is recognized in IPCC, and it is recognized in, I mentioned it yesterday, EU taxonomy, so in industry, but it's also recognized now as benchmarking for K-scale GCM modeling. Did you ever think this will happen? CORDEX results are the benchmark for K-scale Eve type, Björn Steven mentioned it yesterday, modeling. I mean, there's still the Shuklas, Stammers, Palmers around, but we made it. And we only could make it because of your inspiring talks about your push. And I'm very glad, and would like to thank you. You were always at the forefront of science. You were also at the forefront of science be enabled to interact with society. And this is what is getting more and more important. And with this, I would like to dedicate this conference to you, Filippo.
Thank you, Daniela. Now, Filippo, would you please come up again? We would like to give you a chance to give just a short response to this, and then we will ask if there's anyone in the audience who would like to come up and say a few words about your cooperation with Filippo. So, Filippo, what do you have to say after all this?
I feel actually a bit.
Yeah.
Give me just a second. Well, of course, I didn't know anything about this, which is incredible, I think. Okay, so first of all, let me assure you that I am retiring. You know, many people say, so we don't have to do this again. So, because I realize maybe some of you, actually I had prepared something, but I will do it tomorrow at the dinner that we have tomorrow, because there are many people that I need to thank. I've had a really wonderful career, I have to say, something that went well beyond my expectations when I started. I came from this small town, Sulmona. Actually, the population is decreasing. Now we are at 20,000. And I never expected that, that this would happen to me. There are many people that I need to thank, but I will do this tomorrow. I don't want to bore people now. Let me just say that there is one thing that I will never forget that my advisor told me once when Bill Shamidis, I don't know how many of you know this name. You must know Bill. Is a very famous, where is Alison? Alison, of course, knows Bill very well. He was, for me, really inspiration, but I will say more tomorrow. But he said one thing that I will never forget. He will say, you know, after some years that you work with people, these people become your extended family, because you see the meetings, projects, and so on. So what can I say? You are my extended family. So I thank you for everything. There's a new part of my life that is starting. I have to say that a few months ago, my wife can testify to this, I was kind of freaking out. What am I going to do the first day of retirement after I do retire? I don't go fishing, so that's not an option. And there are not many things I do, but I am writing a novel. Well, novel is a big word. I'm writing a fiction book. I heard that Michel Decay is also into write. That's what old guys do, you know, when we cannot contribute to science anymore, we just write fiction so we can create a new world. So when the book is ready, you'll be the first to know. But again, to me, you really are my extended family. And I want to thank you for everything. And I really hope that CORDEX will continue well, because as Daniela said, it took a long time to get it accepted. Colin Jones knows this very well. Bill, you know, the Toulouse meeting. And you know that already still today, there are people that think, I'll tell you another anecdote. When we started doing this, this regional modeling, of course, there were some NWP people involved. I will just say one name, Bill Kuo. Maybe some of you heard this name. He's the guy who created MM4. And he said, oh, no, you cannot do this. You cannot run regional models for more than 4 days, 5 days, because then it's noise. And he still thinks this after we have run like 2 millennia type of runs. And I'll just tell you this anecdote because I learned a lot from it, and especially for the young people, this is important. The reason why we, actually there's one person you haven't mentioned who had an important role in all this. His name is Gary Bates, also called the B for some reason that is too long to explain. He was part of the initial team that worked on regional modeling. There was Bill Poe, there was Rick Antis, very famous also developer of MM4, and Bob Dickinson, of course. But the idea then was to run many 3-day runs. So we would, the idea was, the first paper, Dickinson et al. Paper was, you know, you look at the GCM, when there is a storm in the GCM, you do a 3-day run. Because Bill Kuo kept saying, and Ron Errico kept saying, you cannot run these models for more than 3 days. And at some point, me and Gary, we got just tired of this. We said, I'm tired of running this 3-day, you know, looking for the storms and running. Why don't we just try a month-long run? And the reason why we tried is because we were not in NWP. I did aerosol modeling. That's another, I have many anecdotes about nuclear winter and stuff, but I'll save those for tomorrow. And Gary was coming from large-scale modeling. So we did not have this preconceived idea that you cannot run regional models for more than 3 to 5 days. They wouldn't even be willing to try it. This is the thing that really surprised me. And since we were coming from another field, we actually said, okay, why don't we try it? And believe it or not, the Georgian-based 1989 paper is the best regional climate simulation we ever had. We did a 1-month run, and I would say that still now, this is probably the lowest bias we ever got. So this to me taught a lesson that in science, many times we are so much, how to say, squeezed by these preconceived ideas. And I say this also in physics. Maybe okay, maybe I shouldn't say this, but you remember at some point there was this experiment about these particles that were going faster than the speed of light. You remember this? From CERN to this lab in Italy. And actually a prominent Italian politician said because there was a tunnel going by. And I remember talking to an important physicist here. And I asked him, what do you think about this? Okay, at the end they found that there was a problem with the data they took. So this was not true. But his answer to me was very strange. He said, oh, this is impossible. I said, why is it impossible? Oh, because you cannot go faster than light. And to me, this was strange, to be so close to the possibility that you can, that's something different. I mean, we don't know anything about the universe. So we shouldn't really have preconceived ideas. And I learned it from regional modeling. Someday we will see that we can go fast, not us, but that there will be things that can go faster than light. I don't see why in this big universe, the speed of light should be the limit, but the physicists, they do. And to me, this is this is strange. It's a lesson I learned. So try to be always open, especially the young people, to all the possibilities. Try them. Sometimes they don't work. Sometimes, like in this case, they work. So this is why we are here. But CORDEX is very important, and this is a message that we will discuss. Now that we have these very high resolution models, these convection permitting models, I see this drift towards everybody doing their own little regions just because you cannot do entire continents. But the thing we don't want to lose, or you don't want to lose, is the collaboration, is the coordination of the activities. If you lose this, then we go to square one. And the GCMers will be criticizing again, everybody will be criticizing again. So my message is try to develop, again, a strategy or whatever for the future that keeps the community together, and that it's CMIP 6 type experiment. Otherwise, we won't make it to the IPCC report again. And this was a big battle. I mean, Linda knows. We went from a few lines in the second report, few lines that I wrote actually, to the Atlas now, entire chapters. And this was an incredible something that they really fought for many years. So, and this because of CORDEX, I think. So try to be very, very conscious of this. And with this, again, thanks to everyone. And I'll say a few more words tomorrow for the people who will be at the dinner. But thanks again.
Okay, thank you so much for that, Filippo. And then, was there anyone who would like to give a comment in the audience?
Can I from Pune, can I join?
Of course, yes, please go ahead.
Okay. This is Sanjay from Pune. I have a message from Dr. Krishnan and myself. So Filippo, it was pleasure working with Filippo in the CORDEX Science Advisory Team. First, Dr. Krishnan was there, and I also had been with you for a long time. So it was a very nice experience. And what Dr. Krishnan would like to add that Filippo's contribution to CORDEX and regional climate downscaling are landmark contributions and will be remembered always. We wish Filippo good health, happiness, and all the very best for his second innings. From myself and Dr. Krishnan and all the CORDEX Asia team. Thank you. Irene, one more, Professor Koji Dariko would like to give his comments.
Yes, of course. Go ahead, Koji.
Okay, I will give you a very short message. I'm Koji Dairaku, Japan, now in Pune. I sincerely respect that you have been a driving force and a significant influence on regional climate communities. I'm very
sorry, could you speak up a bit? It's a bit difficult to hear you.
Oh, really? Okay. I sincerely respect that you have been a driving force and a significant influence on a regional climate community. I'm very pleased that you spoke openly with me at several CORDEX meetings, and we'd like to move forward with your younger colleagues, and we dearly congratulate on your next step. Thank you very much.
Okay, so it's time for wrap up. And now I want you up here again, Filippo. I will also say that yesterday we were discussing how are we going to make sure that Filippo is actually here at 9:30, so he doesn't, you know, come in late or something. So what Susanna told him is that I was so worried when I didn't see him in the audience. And Filippo asked, why is she worried? Well, she doesn't feel safe if you're not there. And so I was thinking, he would probably think that I'm in love with him or something. So I can assure you, Rosaria, you don't have to worry about that. Maybe a slight scientific crash. Anyway, we heard about that you will go on with fiction now. So maybe it's a bit of what you've already done, because as it seems, it was that CORDEX and regional model was science fiction in the start. So you're doing a bit of the same, I guess. And now the very last thing, yesterday or the day before, you saw my CORDEX shirt and you said, I want one of these. So now you need a memory of CORDEX. So here's your shirt, Filippo. It's the largest one we had, so we hope it fits. Okay, so I guess that is all, unless there are any more comments from the audience or from the panel. Any more comments? Or if not, Filippo, I will also say that when I started in CORDEX, Filippo was co-chair. So he's been important for me as well. So thank you so much, Filippo. Thank you. Last but not least, the coffee break will be short now, so we don't run late today again. So please make sure you're back here in 15 minutes. Yeah, and also remember to take your posters down if you haven't done so.
Carico le presentazioni, arrivo. Yeah. Hi.
You're in charge about the presentation.
Would you please come in? Let's get started for the insight session. So welcome you back to the first insight session. Let me quickly introduce the lineup and the flow of the session. We will first hear the insights from the A1, A2, and A3 sessions. Could you please come in and please let the others also in? And we then will look into the insights from the A sessions. And following this, we have prepared a few questions or topics which need to be discussed to discuss the future of CORDEX science. And I'm sure you're all engaged now after this very moving first part this morning. And of course, we have to show Filippo that we can also continue. So I challenge you a little bit here. And I would like to, I think we should start. We have two presentations or two presenters for the insights, and we start with Melissa as soon as it is prepared here. We would like you to prepare your thoughts, and then we will run around with a microphone, or you will run around to get a microphone. We will see how we do this when we get the audience engaged. So please, Melissa.
Yeah, so we're just going to give a few key takeaway summary points from yesterday's sessions and then turn it over to discussion, as Daniela just mentioned, sort of as quickly as possible. So we've tried to keep this short. From A1, I think the cross-cutting themes across all of the talks and the posters in the session is that adding Earth system components of variety of forms allows RCMs to capture additional feedback processes, allow new feedback processes to potentially evolve, and allow new feedbacks to be studied. And I think one important subnote here is that these feedback loops may change under climate change, so they're important to look at, and we can even include human interventions in these different feedbacks in these coupled components. The other key takeaway point that might be good to bring to the WCRP Open Science meeting in particular is that new and future CORDEX ensembles will for sure contain more models of increased complexity, to use the wording used in EuroCORDEX. And this will enrich the existing conventional GCM, RCM matrices that we've been dealing with so far. The key challenge identified under the A1 session was that standardization of RCMs, including standardized coupling, interfaces, documentation, simulation protocols, evaluation approaches, data access, and modern software development best practices are necessary to move forward with regional Earth system models. And they're necessary not just for greater outreach within the community and usefulness within the community, it's needed for comparability of these results and more feasible and sustainable model development overall. In A2, the convection permitting section, some of the cross-cutting themes across the posters and the session itself were that the CPMs improve the representation of different phenomena in different regions and timescales. So this included urban heat waves, the diurnal cycle, and interannual variability of precipitation and other precipitation characteristics, and other extreme events and cyclones. And convection permitting models in general improve the understanding of key climate processes, and it's essential for a sustainable future. Some of the challenges with CPMs could be summed up into coordination and cost. It is harder to coordinate, but the community should definitely discuss future strategies for this. So we don't just keep running our own small domains in our own regions or move back to that. There are also issues related to computation cost and number of ensemble members, transients, and time slices that need to be discussed within the community as well for coordination purposes. And one of the other challenges identified by several people were that there was still insufficient temporal and spatial resolution of observations to actually verify a lot of these simulations.
Okay, and here's a short summary of some takeaways from the A3 session, which was focused on statistical methods and machine learning applications in regional climate modeling. So one was that well-designed experiments can provide us with more information. So we heard about methods to design the experiments in such a way that we can actually extract a lot more information from the ensembles we might be creating than if we do it in a, as we have in many times in the past, in a more ad hoc fashion. We also heard about using storylines to help target our experiment or model choice to answer particular questions. So following that storyline process gives us a way to have a logical flow through to key decisions that we might have around things like the experiment model choice. We also heard about the idea that reducing errors in our boundary conditions, which we could do through bias correction, ultimately reduces errors in the climate simulated by the RCM. So I think anytime we can improve the RCM simulation, it's probably a good thing to think about doing. And we had several talks about different ways of using machine learning to develop RCM emulators. I think what we saw showed really good promise for the potential of these techniques, but there still remains quite a few questions around it. There's different training strategies for these techniques. What would be, what is the best training strategy that gives us the best transferability of these RCM emulators? There's a lot of work to still do in terms of testing those emulators in real cases on how ways we might really use them. So it's early days yet, I think, in this field, but what we see so far is a lot of promise. And I think with some concerted effort and maybe a little bit of skepticism in their use, we will find them to be very useful tools in the future. And that's it from us.
Thank you very much. Just stay here, please, Melissa. Just stay. So first of all, thank you very much to the session chairs and also to the two of you and the rapporteurs for summing this up overnight and presenting it here this morning. I think we have a bit of time now to discuss a little bit these points directly. First of all, I would like to ask if there's something missing which you think was very important from your session. So is there something which you would say that needs attention to? Because what this is what these slides they are also the basis for the further development of structures and science plans. So it's important that not only for today, for the discussion, we get the major points. So everyone is satisfied? Well done. I think the point now is how we organize the dialogue. And so if we have no immediate feedback questions to these slides, then I let you go if you like. Thank you. Thank you.
Hello, Daniela. Sanjay here from Pune.
Please. Yeah. Please.
Actually, can we add few more points in the by tomorrow from A4 and A5 if they have anything, because we are not prepared any slides so far.
Sure,
Is
please.
it okay?
Welcome.
Okay.
Of course.
Okay then, thank you.
Someone. I don't know.
I mean, nothing very important forgotten, I think, but on the complex regional climate model, I think one of the key questions we have is how do we interact with a modeling community that already exists, are already structured, but not in CORDEX yet, if we want to enlarge the number of components that we are taking into account. So do we want to grow, or do we want to just interact with existing community? And the second point on the A3, I think outside the question of the emulator, we have, I think, now to find a better way to interact, I mean, to hybrid the statistical tools and the dynamical tools. I think we are in a phase where we can really go much further in terms of providing regional and climate information if we can really find the right way to hybrid. I mean, I would say even GCM, statistical approach, and regional climate model. And we missed that in CORDEX for a long time.
Yeah, thank you very much. I'm sure the rapporteurs are collecting these thoughts at the moment of what is missing. We will come back to the discussion in a minute, Samuel. Stefan.
Yes, thanks very much, Jason and Melissa, for putting these bullets together and for handling the sessions. So following on, Sam's comment, it's not so much things missing, but are we ready to talk about stuff? Or not
We
yet?
will start to discuss these topics in a minute. So if you want to you already want to start into discussion, that's fine. Let me just keep the phone and the microphone, and let me just see there's no one else about missing topics on the slides. There's one missing, Gabi. So you have to pass it to Gabi first. We come back to you for the
Thanks,
discussion.
Gabi.
Because we do have a slide with points for discussion, which is covering the complex modeling and so on. So we come back to this topic in a minute.
We also
this is
have
just
some-
the summary of yesterday. Gabi, please. Gabi is over there.
We also have some much longer documents related to notes from yesterday, but.
Thank you very much. That's a really good summary. Apologies, Stefan, for this change. But I think on the A1 slide, there was one element that could potentially be added on the, there was a lot of, maybe it is on there because I tried to take some pictures, but maybe I missed it. But on the adding Earth system components, I also feel that there was some discussion on that there should be variety in those approaches. So for instance, for the urban, that not everyone is implementing the same urban module, but that this is really an important part of adding those new Earth system components. So potentially this could be still a small addition.
Okay, thank you very much, Melissa. If you would pass, please, the microphone back to Stefan. So let me say a few words before Stefan is talking. So the idea is now to discuss one by one, and please not everything at once, a bit organized. I'm not sure if we can manage this, but we will see. We will try. The following topics. The first one is coupling regional Earth system modeling, including humans, coordinated activities needed, and so on and so forth. So I guess you're talking on this one, your comment. The second is a kilometer scale modeling on climate timescales. We tried to get the slide up here. Changes in pattern. We had Rasmus talking about the precipitation pattern yesterday, for example. The third topic we want to discuss with you are coordinated experiments on medium and or high resolutions. Domain sizes, fragmentation, risk of fragmentation, continental scale experiments. Fourth is feedbacks on local and regional scale. I think that is something which we also heard. We saw several feedback loops, and this is also in view of informing other communities. If we have feedbacks on local and regional scales, we see them in our modeling approaches. We can validate if this is really correct or not. It gives us insight. It might change under climatic changes, and it can be used, as I mentioned before, in the benchmarking for global climate modeling on very high resolution. So this is a little bit along those lines. The connection to EVE initiative and other things we will discuss on Friday. And the last one is impact of human interventions on land. That's getting a hot topic because, and we haven't heard about it so much yet, but the change with from fossil fuel to renewable energies, change of land management in order to store more CO2, afforestation, and so on and so forth, urbanization. So, and then connected with the kilometer scale modeling is a hot topic for the kind of Samuel, what if? And I think that's also something which we would like to discuss. So, but we would like to start with the, and I think Pune is still online here. So I hope we try to just say when you want to say something. We try to bring you in as much as possible. And thanks for also participating this morning and in our session and also yesterday morning in the opening session. And so let's start with the Earth system modeling on regional scales. Stefan.
Okay, I'm immediately going to throw a wrench in the works, Daniela. Sorry. But I think that these different components are all interwoven, and we've been treating them up to this point in sort of individual FPS projects, and that's been super useful. But I think our future strategy in CORDEX needs to weave these strands together in some ways and take them in a collective way so that we don't end up next time with our next protocols for the future of CORDEX with a ESD protocol on the one hand and a dynamical downscaling protocol on the other hand, so that we bring these together. So I see three interwoven threads emerging here, and they kind of come out of the presentations from Sam, Erica, and Jose yesterday. So AI, deep learning, deep downscaling, whatever the heck you want to call it, it's mainstreamed, it's here, it's with us now. It has tremendous advantages and promise, but it's only ever going to be as good as the regional model that it's given to train on. So we also need then still these very high resolution CPCM simulations to build process understanding so that you can then trust the deep downscaling that's done and give it something realistic or at least reasonable and reliable to train on. And then the additional coupled components also then feed into the very high resolution stuff by improving these model simulations and in particular helping us better understand the impacts of climate change. So I'd say that all three of these are really critical and that we should be brave in our future strategy building to weave them all together in some way so that we're recognizing how they can work together in a complementary fashion to get us towards the ultimate goal, which is to better understand what's happening at local scales as the climate continues to warm.
So thank you.
And
with these long words and with also Samuel before, I would recommend that you write it up in a sentence and make sure that we are getting it into our further discussions. Not now, but I doubt that we can only rely on all rapporteurs when we have all these important comments now, and we would like to make sure that we keep them. And I'm over 60 now. I cannot remember everything. So I think that's great. Would that mean, Stefan, let me ask you, would that mean you are pushing for disciplinary research in the components plus the system connection? So is it in favor of the more system thinking? As Samuel said it yesterday, in connecting more compartments or parts and in getting the Earth system on the local and regional scale more in the center of the modeling?
I mean, I think one of the things that we've realized from the FPS studies is that we need some of these systems are really critical to get a reliable output from convection scale or kilometer scale models. And at the convection permitting workshop last month, we came up with some prioritizations on which of these components are really critical to have in there as soon as possible. And so, yes, that's really important for the very high resolution. But then, of course, as I said, this all kind of they all feed into each other. And that will give a better input to machine learning approaches, and that enables us to cover the range of possible future outcomes in a better way. So they all kind of go together. I don't know that I would put one on top of the other, but rather see them more in a Venn diagram way of thinking, if that helps. But we do have a prioritization, at least from the CPM community, and it's hydrology, vegetation. Erica, jump in and correct me if I'm wrong. Urban, and yeah, it's in her slides. And I think aerosols were kind of like 4 key things that we already have too. That's a real key important component aspect to this, is that these are already things that are in our modeling systems that different modeling groups have high levels of expertise and experience with. So it's not a heavy lift. It's not like saying we have to devise an entirely new module. And that's it from me. So other people should.
So are there more comments now? Please.
Thank you. I think one of the missing bit before you do modeling, we're talking about models and different components, but we're not talking about the associated data sets like land use, urban layers, and a lot of other things. And each modeling group uses their own, and most of them, they are static in time. Some, they could be 20 years out of date for modeling and whatnot, and we never put any effort to think about that and how we do this. Some modeling group omit aerosols because they don't have a capacity. Some they do emissions, some they do prescribe optical depths and things like that. So there's a lot of, I guess, or hard to compare the experiments because there's a lot of things which differ in design. And I don't know whether we can do some better job on that, specifying things, providing data sets, and putting some effort into getting that for modeling platform.
Yeah, thank you very much. I think this is something which we really should have high on our agenda, the common data sets and the coordinated activity in CORDEX and on the different scales. And of course, this is also true for the very high resolution. It is a bit difficult, of course, but I think it's an important point. Can go into under 3 here. Please. We're just collecting comments now.
Yeah, I think following up on that, another point maybe is infrastructure. CORDEX, of course, relies heavily on ESGF to distribute the data. And I think we should be conscious that this is software that is also kind of developed at modeling centers and so on. And engaging there and developing that can help with many of the aspects that have been mentioned just now. For example, for CMIP 6, there was already the input for MIPS project and also the ops for MIPS project, which is exactly that, distributing forcing data sets in a shared format so that everybody can have that, right? If we try to engage there and bring data sets that are needed for driving of the regional models into the same platform, it becomes much easier to share and deal with them.
Thank you. I just realized that we do not all know each other. Maybe you could say your name and where you're from. And I'm sorry, maybe we can bring the, I mean, Stefan knows everyone, I guess, or everyone knows Stefan, but maybe not. Maybe, I'm sorry that I did not think about this beforehand, please.
Well, now you forced me to reveal myself as the imposter that I am, because I'm kind of coming more from the global side. I work at SMHI in Sweden. I'm Klaus Zimmermann, and I work with this data stuff there a lot. But I really do think that interacting and joining forces there would be beneficial for everyone.
Thank you.
Daniela, can you hear me? This is Pankaj from Pune.
Yes, please go ahead.
So we have some comment on regional system modeling. That's what we were taking, I think, point. What we have experienced here, that obviously this is an important aspect where we are moving, and it is showing some promising results as well. I think there were points were already written what should be there, and one of the point which I feel is missing is the adding the cryosphere part. Somehow to add this, because we really miss glaciers and we really miss to talk about these high mountains people issues to address those things. And what we are addressing so far using either CMIP6 or RCM things, but we really miss real signals which we get from these glaciers and ice to moderate the microclimate. So that one suggestion should be there from our side, that should be around. And just to give a feedback that this obviously is improving the climate both at intraseasonal and intra-annual scale over South Asia. Yeah, thanks.
Thank you. This was Pankaj Kumar, right?
Yeah, Daniela, yes.
Thanks a lot. Please all make sure that you drop us an email with a sentence on this. This is for everyone. So next one, please.
So I'm Ben Booth from the Hadley Centre. I'm also a global modeler, but we also use regional climate models to inform national projections, so coming from both ends. And I wonder whether a missing part of the discussion about Earth system process representation is an idea about where it's important. So thinking about time-evolving aerosols, it's probably much more important that you include that over Europe than over South America if you're looking at downscaling RCP 8.5. But I wonder as a community whether we need to identify where the priorities are if you're doing regional modeling in that area.
Thank you. Samuel. We then slowly move to the kilometer scale modeling and the other topics, whatever topic you like, so but that we slowly move towards this. Thanks.
Jana Rechet from CORDEX in Hamburg. I've been working in regional climate modeling since 2000, quite a long time. So I'm very pleased, of course, from your point, Daniela, that land is a hot topic, it's getting a hot topic. And as you know, in the standard simulations, we still not have this as a standard input, and that we do now important steps to include this also in the models. What I want to say, so yesterday it was also in the A1 mentioned as a boundary forcing. But I think we have here a lot of opportunities to treat this as an interactive element as well. And if we want to include the human dimension, I think human land use is one possibility to include also human decisions. And if we want to use now also, if we want to integrate climate action, so as mitigation, adaptation, I think we have here very good tools where we can study then those feedbacks on the local and regional scale. But what is needed here, of course, is that we also have a parameterization for including these management options. So we have to include forest management, we have to better include urban regions and so on, that we really can then simulate the interaction between these land components, these modifications and the atmosphere. So what I want to say, of course, there are a lot of opportunities, but there's also still need for improving our models. So we don't, we should not forget this. Thank you.
Yeah, it's Samuel, then Erika.
Yeah, again, for the complex regional climate model, just a point on possibly on the organization within CORDEX. So something we missed a bit on this topic is the connection between the FPS. Some of them were targeting aerosols, RC, land use, cities. The connection between those FPS and the standard protocol in the domains. So it was well done, I guess, by the FPS aerosols, because now aerosols is a key word in the new CORDEX FPS, CORDEX protocol, but not so much for the others. So we have to, I mean, somehow to find the way to improve the interaction. So it could be one of the targets of the new FPS to deliver something back to the CORDEX normal protocol for the domain. So this is one point. And then I have heard a lot about, I mean, comment on the forcings. So we need new forcings, we need new data sets if we want to expand the number of components we use. And for that, I would recommend to use task forces. So technical task forces or technical support unit, even if we can have in addition to the IPOC, in order to prepare file, to deliver files that everyone can use them afterwards.
Thank you. Very good points. Erika, please.
Yeah, just following up just the first point of Samuel, I think we have to start to think about how strategically can we define new protocol? Because, for example, the first 3 bullets that you have in your slide, they will soon intersecate each other. Because yesterday we spoke about the bodies and Earth system model, which are the component. And then the next question is, why if, whatever you use, we get then to a kilometer scale Earth system model. So which is the boundary between one and the other. And then where are the coordinate experiment standard one of CORDEX? So I think we have to be careful to keep the coordination, but also not to mix too many things together. So for example, just taking an example like the EuroCordex, the EuroCordex new protocol. Now we have there the new protocol. We yesterday heard from Samuel that he thinks we should include also the cable system there. And what if we have a kilometer scale over the whole domain? I mean, how can we be comprehensive, but in the meantime, ensure that we will not have a single class of experiment that are then not comparable with anything. So we have to be smart and evolve the definition of the protocol, I think.
Yeah, thank you very much. This actually is one of the challenges which you said, and which also Samuel was pointing to. We have this kind of, let's say, at least 3 important areas of activity. One is more, let's say, the coordinated basis, like the coordinated continental scale modeling and the provision of climate change information for follow-up studies. And that, of course, with the best tools, with the best knowledge, and so on. The second is, of course, the further development of specific settings, which we do in FPS until now. And then the question is, when do we have reached so much new knowledge and capabilities in an FPS that it can go into a standard setting? And then, of course, we have some new challenges, and that's the more direct interaction with humans, where we probably have to think about an extension of the modeling systems which we have at the moment, even beyond some of the very high resolution activities. This is also partly addressed in FPS. And this afternoon, we have a session on what worked and what not in the FPS. And then we will on Friday also discuss and ideally decide the way for FPS in the future and along those lines. So I think that is important. I would challenge you a little bit more on the feedbacks. And maybe some of you, I heard some comments on how important the continental scale coordinated experiments are for reaching out to other communities, for example. So do you think this is something which we should keep on going? I mean, I'm a bit provocative now. Could also say, and then Grisha said, no, we don't. Could also say we get rid of the continental scale and do only smaller scales. And then Grisha said, no, fragmentation is not good. And this is exactly the dialogue which we need. So can I ask you from the audience a little bit, what do you think about the standard CORDEX setting with the continental scale information following the kind of CMIP 5, 6, 7, I don't know, 10 approach? Because that needs resources, and we had efficiency here somewhere on the slide, and also about the very high resolution needs. So.
Oh, I have the microphone. So I have 2 comments on this issue of the continental scale. I think this is really critical. The reason why CORDEX made it to the APCC is because of the CORDEX score. And actually, I was a bit disappointed that only 2 models participated in CORDEX score. I think WRF could have. We had many talks with the, what's the name? The German model, the other German model, Cosmo. And in the beginning, they wanted to participate, but at the end they didn't. And if we could do it, they could have done it. And having 4 models instead of 2 would have made really this an incredible data set for the impact. So I hope this is not forgotten, is not left aside. And okay, I realize that maybe you can do either one or the other or whatever, but I mean, don't forget that this is really critical, I think. And of course, going to higher resolution, now the computers are really fast. So you can probably go to 10, even 5 kilometers, I don't know, maybe not do all domains, whatever. The other issue I wanted to raise is this issue of digital twins. No, we heard yesterday about this whole business of digital twins. But one important thing is that you can have regional digital twins. In fact, in the document, there is some type of document going around, I don't remember what it's called. They talk about regional digital twins. For example, the Mediterranean, a digital twin of the Mediterranean, I think would be an incredibly cool idea, cool thing to do. Or whatever else. I mean, I talk about Mediterranean because I live there, but it's a nice area, nice enclosed basin or whatever. But to have some FPS on prototype regional digital twins will get you into this whole discussion. And this is the discussion of the future anyway. So that's one way to remain in the middle of what's happening.
Thank you. Linda, please. Eric, not the same person all the time. I'm sorry, Erika. We'll come back to you, but try to bring some others in. Linda first, please. Yeah, no, there's a microphone. Just a second.
There was a hand that beat you.
Yeah.
So next.
Just
That way I
a
don't have to
second,
run
Linda,
back.
just a second. I didn't see that there was one before. Okay.
So Filippo, if I understood what you said, you suggested that the presence of the CORDEX, or the very strong presence of the CORDEX runs in the IPCC, was primarily due to CORDEX core, and I don't think that's correct. I think the fact that, because for example, in the Atlas, which was the major vehicle through which the CORDEX models were discussed, it was mainly just the global coverage and the number of simulations that was much more important. So while I certainly agree that the CORDEX core is a very important component of this, I don't think it was the dominant one in the IPCC, partially for the reasons that you indicated, that there were so few models that participated.
I don't think that was said by Filippo, but we don't want to debate here.
Just to clarify, I didn't mean to say that it was the most important thing in NPCC. I meant to say that if regional modeling made it there, and Erika can testify to this, since she was one of the authors, is because of the CORDEX code. Of course, if we had had 6 models, it would have been probably the main thing, but I didn't mean to say it is the main thing of the IPCC.
Yes. My name is Andrea Hamann. I come from land surface models many decades ago, but now I work for one of the groups that uses CORDEX data for other applications. And in this case is the wind energy community. And a problem we face this whole time is the land surface, not only for future scenarios, but past scenarios. The land changes all the time, and it's critical for identifying this. And now there is a whole community that uses data without really knowing what they're getting out of it. So I think the thinking about the land and how it's represented in these regional models is really important, even including a variable, surface roughness. It's in none of the CORDEX models. Even in the CMIP, it's not there. And it's critical for us to identify what kind of surface is underneath the atmosphere. So that's just a comment from a community that uses your data.
Thank you very much. Erika, please.
Me? Okay. So, sorry, and this is Eric. No, I wanted to comment on the provocative question about the domain, the standard domain. I think it's time to designate a kind of two-dimensional domain space. So we definitely agree that we should keep the continental scale domain, but we have to envisage different resolution. I mean, a good strategy could have multiple resolution for the continental scale so that we are comprehensive, we are inclusive of all the possible resource that the different group can have. But also we need to envisage a different domain size coordinated one, okay? So this means I will have one axis will be the resolution on the standard domain, the other axis will be the size of the domain with the possible 2-3 domain that are coordinated by CORDEX so that we don't lose the people around. So we have to change the dimensionality of the domain, I think, space.
Yeah, thank you very much. There are Klaus Bergen, please.
Yeah, hi, Klaus Görgen from Research Center Jülich. So I just wanted to make a comment on the resolution and the domain size. I mean, what we see is that we get a lot of processes better at high resolution. Hydrology is one. And what we see, for example, when we include human interventions of the system, such as land use, land cover change, or water abstraction irrigation, is that we have a lot of remote feedbacks. So that is, we really need the large model domains in order to capture the remote feedbacks. And another thing that also came out in the workshop in Bergen is there is a lot of work now ongoing relating regional feedbacks, regional processes with large-scale drivers and large-scale interactions. So feedbacks with driving atmospheric dynamics. So I think for that, we also need the large model domains. So I would really opt for high resolution and large domains.
Bill, please.
Yeah, Bill Gutowski. I wanted to add to what Erica just said about this other dimension. What I would suggest is that when people start going to these finer, smaller regions, finer scales, there's usually key physical processes that they're targeting. And it may be that that second dimension should be set up in terms of what those physical processes are, which then could be coordinated across various regions around the world, such as convective systems or sea ice atmosphere interaction or mountain interaction. Something like that would be a way of thinking about that second dimension, so that we're not simply talking about geography, but we're talking about the climate processes that are relevant.
Sure. Just a moment. I don't know if there's a comment from Pune. Maybe. I don't know if someone is watching the Zoom. Someone was.
So Danila, this is again Pankaj.
Please.
So I think there are two ways, I would say. One is that obviously domain which we simulate for CORDEX South Asia is really large enough. And when you really are going to very high resolution, let's say 0.11 or even further, will be computationally very challenging. At the same time, also, we don't want to sit on some large scale signals where we put our domain. So I would say that we can think of addressing the domain for South Asia a little bit so that the large scale simulation, fine scale simulations can be done on more numbers of simulations.
Yeah, thank you very much. Pankaj. Thank you. Sorry, I don't know your name, please.
My name is Joseph Sectus from Queensland University of Queensland in Australia. I think one of the interesting things in terms of feedbacks where we could learn a bit more is to maybe have some coordinated experiments where we have run side-by-side couple and then couple models, so we can learn a bit more about, for example, we know that monsoonal regions and tropical climate around Whirlpool and whatnot is very sensitive to how the ocean is represented in the model. So coupling is very important, and there's a lot of missing things if you run high, whatever coarse resolution SSTs from global models and run regional model fine resolution. So I think we could probably learn a bit more about the missing additional feedbacks with the coupling because we have this capacity now. So that's, yeah.
Yeah, thank you very much. I would like to ask you to slowly also extend to statistical downscaling, empirical statistical downscaling. And I would like to challenge you a little bit here. So how we connect to the information space, let's put it this way, to make sure that what we are delivering is trustful. We heard about the wind energy a second ago. We do have, of course, on the local scale, climatic changes, maybe, for example, in wind direction, which is a bit of a tricky component. So how do we make sure that we evaluate those components on the local scale reasonably well to think we are able to deliver trustful information for the future? So, and how do we connect the different approaches along those sides? Rasmus, please, first.
Teresa Cavazos from Mexico. I agree with Bill Gutowski and the other speaker before, because I think that we need to maintain the high domains, the large scale domains for different processes like droughts or teleconnections, etc. But on the other hand, we also need some smaller domains at high resolution. Some domains like CORDEX CAM, we may not have the resources to run big areas at high resolution. So this is an opportunity to have a coordinated, smaller, high resolution domains, and possibly focus in particular physical processes that are of interest to several domains. Convection permitting, monsoons, tropical cyclones, coastal regions, urban. I think we can have coordinated projects on those high resolution domains.
Thank you, Teresa.
I like to comment. I'm Rasmus Bennestaff with the Norwegian Met Service. The thing about coupling and regional Earth system models, I think that is useful for trying to understand how things work, but not very good for projections, because these regional climate models are already physically inconsistent with the driving GCM, because you're changing processes, you're like changing a cloud and rain cover. So then you have different outgoing long wave radiation on the top of the atmosphere compared to the GCM. So then you need something else to make sure that if that really matters. And also when it comes to kilometers modeling, it's actually trivial, because we know if the climate change is here, it will change almost the same 1 kilometer down the road. So it's more a sort of a question of geographic effects of climates. But you really want to include, you want to do this because you want to understand convection and a small scale still. But I think when it comes to climate change adaptation, it's statistical downscaling is the safest bet, but still it has strengths and weaknesses, but it has different assumptions to regional climate models. You want to bring them together, and there are ways to do that. And I'll actually talk more about that in my presentation later on. But I think these are more of an academic side. I'm from the Met Service, and we are more interested in applying this to society. And then we want to have some really robust information, and I'll talk more about that later.
Yeah, thank you very much. More comments? Sam?
Excuse me, I am Lalu Das from IITM Pune. Actually related to statistical downscaling, I just wanted to mention, sorry.
Please go ahead.
Okay, we know that RCM and GCMs are providing a lot of information for the local scale as well as regional scale. So in addition to RCM and GCM, there are different type of numerical weather prediction model for medium range, extended range, and seasonal scale. So we have seen in the South Asian domain that still all these model output are not having very good skill to represent local climate adequately. So my proposal is to include those medium range, extended range, and seasonal scale model output to our CORDEX community to statistically downscale to get more reliable product for impact study. So that can be done. Actually, long time ago, actually Rasmus can also supplement that. When we have some workshop on ESD on Cape Town, that time we propose that we have to do statistical ESD, statistical downscaling, using the process-based statistical downscaling. And I think this can solve many of our problems for the local scale. So that can be done using more emphasis on, you can say, that is the more sophisticated techniques of ML, machine learning techniques. So this has to be more focused and included in the CORDEX future planning. So thank you very much.
Thank you, Samuel, please.
Before we completely move to statistical downscaling and hybrid stuff, I would like to recall that in the regional climate model development dilemma, there is a 4 axis, the fourth one, which is the development of the model. So everything constant, resolution constant, complexity constant. We also have to work on improving the content of the model, the physics mostly. And this will help us to gain trust and confidence in what we do, and also confidence for the society. So I think we, as a CORDEX community, we also need to develop innovative way of developing, evaluating the model. And I would also include the tuning, because now the GCM communities, they are developing semi-automatic tuning capacity that we do not have really in regional climate modeling. So I think we can gain a lot along this aspect. So development, evaluation, and tuning. I think it's also one of the axes we have to support within CORDEX, and it was not that much the case up to now. And just one example for the evaluation, there is something that is now fastly developing. It's climate change. So past trends are now detected at regional scale a bit everywhere for many variables, and we absolutely don't know if our regional climate model can reproduce them. And when it is tested, very often we are very bad. So this thing, for the trust, is very important that our regional configuration can reproduce the past trends that are now very strong everywhere.
Yes, thank you. Now I have Silvina first, and then Erasmus.
I would like to come back to the ESD. This is something that we have pushing from the CORDEX SAT since a while. And there is a white paper on ESD and the protocol for ESD. So we would very much like to encourage people start working and coordinating the activities on ESD to provide that local information that Rasmus mentioned before. But there is an issue with these tools, which has to do with the data, the calibration data. So if we need, for instance, to provide information on winds, how the winds will change, it's very difficult to have local data on winds over a long period. I would say everywhere, but mostly in some part of the world. So how we should think carefully how to deal with these limitations on the data availability again.
Thank you, Silvina. Erasmus.
Since we were, okay, my name is Erasmus Bonomo from the UK Met Office. I'm probably doing 3 steps back here, but it's closely related to what Samuel was saying earlier. With this focus, I'm really enjoying this conversation, but the focus is only on complexity, improving the models, better data set, higher resolution, and so on. I would like to know if what is the current thinking on the protocol for the experiments, in particular, where you draw the line between being inclusive or being cutting edge. Many in the last protocol, the one for the CMIT6, CORDEX V2, many aspects of the simulation are still optional. Is there going to be an attempt to make this more rigorous or more making stronger condition of what can be classified as CORDEX simulation?
So what would you suggest, Erasmo? I mean, it's a good observation, but what is your solution? I did not understand the solution.
That's why it was a question. I was to say if you have been thinking about that, because we are having on one side a discussion on increasing the effort and making our simulation much more expensive. Is somebody going to argue for we want to have as many groups as possible participating all over the world, and therefore we need to have minimal requirements that we are not discussing now. So this is the, I don't have an answer, of course, that's why.
Yeah. Stefan has an answer, perfect. And there's someone else someone has a microphone. Wait, just wait a second. So we have to go up there, please.
So it's about machine learning. So if Stefano wants to go first for the answer, or it was really exciting to see machine learning yesterday, and it feels like we're on the cusp of something really big, and it feels like it can open up so many opportunities. What strikes me is that one of the strengths of CORDEX, why CORDEX is so important in terms of that cascade of information to impact, is it provides spatially, temporally, multivariate, coherent realizations of how climate can change. And lots of impact models need that. So if you're doing river model, if you're doing flood modeling or so on, you need that data. So I guess questions I still have about machine learning is, to what extent can you do that multivariate, coherent response in terms of that, in terms of learning? Because if we can do that multivariate response, then I think there's a real frontier that's ready to be breached.
Yep. Thank you. Good point, Stefan.
So yeah, so one possible way to go about what Erasmo is talking about is that, recognize the fact that not all institutes are going to be able to do dynamical downscaling at the kinds of resolutions that we have ambitions to do them at, and that's okay. And but this is why I suggest that we take these threads of AI, deep learning, convection permitting modeling, and additional Earth system components, and tackle them in a coordinated way. So if not all institutes can do very high resolution downscaling over a domain, let's say South Asia, for example, then pool resources and do a few of those, and then other institutes can throw in and start using things like AI approaches and deep learning approaches. It's got potential to be incredibly democratizing. Many of us are already up against the limits of what we can do at our institutes. Right now, we are in a Horizon Europe project right at the limit of what we can do, and that's splitting Europe into 2 domains.
And coordinated one.
And coordinated, right? Splitting Europe into 2 domains and running for 3 domains, running for 60 years? 60 years. And that's pretty much the bleeding edge of what we can do here in Europe. So, so we're going to need to approach this in a really coordinated way, and recognize that not everyone should be aiming, recognize that not everyone should necessarily be aiming to do a dynamical downscaling, but to do the machine learning approaches, the empirical statistical approaches, and bring these all together into a coordinated protocol. Easy, right?
Sure. We are trying to do this since at least 15 years. At least we are talking about it now jointly without fighting in this one room.
Yeah.
Major step forward. Is there a microphone somewhere? Melissa, I lost you. Where are you? Over there. Okay, so who's next? Okay, so then let's switch the topic a little bit. Okay.
Sorry. I have a comment in the Q&A on Zoom. So
I would ask if you, Juan Carlos Sanchez Perino, would like to say it out loud, or would you like me to read your comment? Okay, I can't hear an answer, so I'll just, it's quite a long comment, but I will read it. It says, maybe it's a silly idea, but anyway, related to the higher resolution simulation in continental big domains, a possibility would be to join the computing power of several centers around the world, making distributed simulations, something like the SETI project, which uses pieces of volunteers to compute in idle computer times in a distributed way directed by another remote machine, a kind of server driving the process, but in this case, not in idle times, but in a dedicated way. Today, there could be more administrative and political issues to achieve this than technical ones. It could be feasible from a purely technical point of view. I don't know how well it would scale increasing the number of processors, something to consider if we take Destination Earth and digital twins efforts seriously. That was the comment.
Yeah, thank you very much. I think we will come to the discussion about digital twins and Destination Earth and Eve step by step in the next days. So we will also take this into consideration. It's a good comment. I would like to challenge you now a little bit on the multinational and development side of the scientific CORDEX approaches. So we heard this tremendous success of Filippo's career this morning, and it is very closely connected to many, many regions in the world, I would say to almost everywhere in the world, and also connected to many developing careers, developing knowledge, capabilities. So if you now look into the science of CORDEX and the challenges we are facing, on the one side, the efficiency problem, the high computing costs. We are reaching limits at the moment for computing capacities. But on the other hand, and Rasmus said, it's all about complexity. How much detail do we need? That's what I always say. How much detail do we need for which question to answer? And that's one side. But what do you think about the let's say the capacity development in this endeavor? Are we sharing enough results? Is the transferability from one domain from the knowledge of one domain to the next domain, is that happening enough? Or is it only the flagships pushing for this? Maybe you can comment on this a little bit from a scientific point of view. Erika, please.
Yeah, I think, as you say, the flagship was a success story about this because all the flagship on convection were just working at seeding each other out. So even if we start earlier in Europe, we didn't keep the secret for ourselves, but we were working with the community according to our capacity, I mean, our connection. And I think this was a great success because they didn't need to start by scratch again, but they could focus better on their process. Like, for example, in South America, that I know well, the project, or in Africa, then the focus was different because it's a different kind of research question they wanted to answer, but they didn't need to start from scratch, and we could share the knowledge and the experience. And I think on the other standard domain, I think most of the time is also happening the same because there are people working in more than one domain. For example, the Central America and South America community is working very much together. So usually when we organize CORDEX workshop, they join the effort, also because they join the money. and some we optimize the things. So I think it's happening, but the way in which we were working for this flagship was a very good success story of transfer of knowledge.
Joseph Sictus again. One of the issues, I guess few people mentioned that we're reaching our, I guess, limits with computing power, but additional issue emerging from the SMAP6 and CORDEX downscaling is that we're talking about even from single model, like we done 45 experiments for 3 scenarios, we're talking about petabyte of data because the high frequency early data and whatnot. And it's very expensive to publish that. And in Australia, for example, we have to pay for it if there is no institutional I guess, data sets, hosting capacity and whatnot. And so that's not insignificant cost ongoing. People would probably realize very soon when they start to deal with that as well.
Yeah, thank you. If you have comments on completely different topics, scientific progress, that's what we discuss today here. Please go ahead. So on whatever you would like to mention, what is missing in our discussion, what we haven't touched yet. Rasmus, please.
So progress more in terms of statistical downscaling. I've been talking a lot with statisticians and learn that there are actually new ways of downscaling. Like one thing is like the artificial intelligence, but there's sort of the pure mathematics. And one way that we have downscaling in the past is by day, and then you have like large scale predictors, and you downscale the state of the atmosphere at each day. But what the other way that the statisticians do, they actually look at statistical properties like the shape of the curves describing the probabilities, the PDFs, and other shapes as well. And you can actually downscale maybe the shapes of storm tracks, because if the storm tracks are systematically affected by large-scale conditions, then you should be able to predict that, because statistics is much more predictable than the individual outcomes. And for instance, like it's trivial to say that when you roll a die, it's like the probability of getting a 6 is 1/6. But to predict what you will actually get is very difficult. And that's the reason why you also have Las Vegas, is because statistics is so very predictable, whereas as the outcome is not. And this is something that we humans don't really often remember. That's why people go to Las Vegas, to lose their money. But the people who should run the show understand statistics. And I think here is also something that is fairly new in our field in terms of science or mathematics. So I just want to say this because we tend to talk about regional climate models, and empirical statistical downscaling is always ending up in the shade of it. So I just want to flag that.
Yeah, thank you very much. Samuel.
There is one challenge for our community that we did not touch yet in the discussion, is the fact that we are always in late. So when we will have finished the CEBIP6 downscaling, then CEBIP7 will be already there. And this is something that is an issue somehow. So I don't know how to work on that. So there is 2 possible answers I see. I'm not sure I have the right solution. So one is the infrastructure. So trying to run the downscaling where the GCM runs on the fly. So this is one possible answer, but it's not the generic answer. This would require a EVE modeling center on which regional climate models are invited, for example, and on which GCM run also. Another solution is hybriding dynamical downscaling and statistical downscaling. So using, for example, emulator that can run also on the fly, downscaling immediately GCM simulation because they have been trained on regional climate simulation before. So I don't know what is the solution, but I feel, at least from the government users or stakeholders, that they feel we are always in late. So I don't know how to answer this challenge somehow, but we need to find a solution.
I cannot answer that question, but I can give you my opinion to this. And after 30 years, I would say, who cares? So I think we should not be in the position to be pushed anymore. because CMIP 6, CMIP 7 is not necessarily per se better in detail and provides more knowledge to stakeholders. It's just the idea from governments, there's something new, and because it's new, it must be better. So I think it is very important. I like to defend the time we take to decide, because of sustainability and resources and scientific knowledge, we are later and delayed compared to the new cycle, but we only work with what is really makes a difference instead of replicating tons of data sets which are very similar to others which we had before. But this, of course, is a users-oriented and a sustainability-oriented answer. But I do think we should be much more proud and much more strong on why we are acting like we are acting. And regional climate modeling was, we had a tough start, as we heard this morning. But I think we should be very strong and outspoken and say we are out of the ugly edge of the room. We are a very experienced community with lots of knowledge, with many very important tasks and many very intelligent people. So it is a little bit also on the side how we communicate what we are doing. Are we still seen as the end of the GCM, which we were, or are we seen as the regional information provision, which we will come to after lunch, I guess. So, Jose.
A quick comment to that. I agree with a lot of what you said, Daniela, of course. Though there's a practical problem at SMHI, we launched a new climate service, I think last year or 2 years ago in 2020, and the future begins in 2015. And that's, of course, a bit of a problem. But with regards to CMIP, I also just wanted to make the comment that we are already seeing in CMIP 6 now that CMIP 6 doesn't really end with the IPCC report as maybe CMIP 5 did, but we're getting new simulations added even now, and this will continue until CMIP 7. And I think the global community overall is moving a little bit away from these cycles. Of course, we need to have these cycles for core evaluation and to do certain sets of experiments, but we'll see more and more that more experiments are coming out all the time and are getting updated all the time. So that's also a part of the answer, I think.
Yeah, a follow-up from Daniela. I fully agree with you because there's nothing that we can do. So what I think we need to do is to defend what the value of the data that we provide, because in the latest IPCC report that was mentioned before, what we did in the Atlas and in other chapters was to put side by side all pieces of evidence. And from the global model, the latest data set is CMIP 6, but there are problems with models. They came very late. Some models went into the report and then they are deprecated because they found problems. So CMIP 5 is much more solid, evaluated over the years. So we have full understanding on problems and deficiencies. So CORDEX CMIP 5 is the state-of-the-art regional data set in the IPCC report is acknowledged. And now, since we are running to this global warming level dimension, it is not so important whether it is CMIP 6 or CMIP 5. So the scenarios made a big difference because it's a different language, a different dimension, RCPs, SSPs. But if you talk in terms of global warming levels, who cares whether you are taking the slide from time slice from CMIP 5, CMIP 6. So I think we need to defend that what we do is the state-of-the-art knowledge on regional projections to be used in services as it is done, independently on whether we are just going to the latest or to the previous. There are advantages and disadvantages. So having now a data set relying on the solid CMIP 5 information has good elements to be defensible. So I think we are in this transition where we maybe in the future could do some quick analysis on task force on emulators, machine learning, whatever, to provide something which could be used, but the solid information coming from the RCMs and products derived from there should be at the let's say frontier of our work, and we need to defend that, and that information will be passed and will be used in the reports. This is not a problem.
Hello, I would like to include someone from Pune. Hello.
Please.
Yeah.
Yeah,
Okay, I am
please.
Dr. Mohan. Okay, I am Dr. Mohan Kumar Das from Bangladesh. So I am attending the conference from Pune. So as I observe, India is doing lots of work, sometimes Bangladesh also doing, but in South Asian context, some other countries are not doing that much of activities by using the CMIP or 5 or whatever CMIP 6 or CORDEX thing. So like if a big country has started to work lots of things, other countries just use it. But in terms of capacity building, I think institution to institution collaboration is needed, and also the capacity building is needed. So though CORDEX is doing lots of activities, I think there should be some channel. So some university, some government or non-government organization, at least a couple of people can join. And then their capacity will be enhanced, and then they can do some work by using their own data with the CORDEX data. I think that is still, that gap is there. And another is as you mentioned, converting, permitting new product. That is really challenging. And also I think our own observational things or some more experiment is required. So in that case, local scientist involvement is also required. So I think CORDEX can think of it. Thank you very much.
Yeah, thank you very much. This was a good point. I would also like to remind you in Pune, please send an email to make sure that we are not losing all your good comments here. We try to write down what we can, as we try here for everyone else. It's for everyone, for both hubs, please. Someone has the microphone. Please go ahead.
Yes, Ali Madani from CNRI Météo France. I think my colleague Samuel's comment is still interesting and valid, because for like some practical purposes, we have state-of-the-art GCM exercises, CMIP 6, and state-of-the-art RCM exercises, CORDEX, and the two are inconsistent. So for some applications, you want to show what's the, let's say, the multimodal response or uncertainty with CMIP 6 and the one from CORDEX. And then maybe you need to actually manipulate a third data set, which is CMIP 5, to kind of bridge the gap. So then just from this practical standpoint, it makes it a little bit more awkward, let's put it this way. So there are pros and cons.
Yeah, thank you very much. Let me say here, we discussed this also in the CORDEX SAT several times. And this time, I guess we are particularly late, but maybe not more than before. I don't know what exactly, but what I would like to say here, of course, your comment is correct, and this off cycling is an issue, but I would also say we should have the strength to say it's not an issue for everything. So and we should try to overcome this. I'm personally not a friend of running everything in parallel immediately. Downscaling crap I was never a friend of, but that might also have changed over the last decade. But what I would like to say here is we need much more engagement of the community to get faster, because some of those things are also delayed because the workload is on the shoulders of a relatively small group, which is also trying to taking decisions for the community. So that's why I would like to encourage all of you also to get more and more engaged and involved in all our discussions, because the more people we are, the faster we can be. So if you listen to what we have discussed, I would say we need about five strategic plans: one on regional Earth system models, one on convection permitting, one on those more technical issues, how to get faster and all the data, the resources issues. So we need task forces, groups, or whatever to work out solutions. We will never solve everything, but this is my little advertisement for get engaged with the CORDEX activities during the year. More active on all those topics which are of interest and important for you. Please, I'm sorry that I was interfering before you were talking.
Daniela, can I add something before? Because I raised the hand, you didn't see me. So I just want to say that it's true that we don't need to be in a rush, like Samuel suggested, and I agree with Jose Manuel that the solid regional assessment we have now today is thanks to the CORDEX CIMAP5 signal, and there was not big issue to complement the two coming from the CIMAP6. But what we have seen during this phase of the IPCC is that there is some gap that can be avoided, because as soon as the first evaluation and the CIMAP6 model were started to use within the assessment, then at that point, those models could have been passed to us to start the work. So this doesn't mean that you don't scale on the fly, but at least you don't wait 4 years before you get the first boundary condition. But on the other hand, what I would like to say is also that is our commitment now to reduce this gap with the impact community. We are late, and in the last cycle, people were still using the CIMAP5 model to do some impact study. And this is our responsibility now, and we should, on the same way, avoid that.
Sure.
Thank you. Joseph Sictus. So one of the practical things CORDEX should do for CIMAP7 is to make sure that at least every modeling institution says the boundary forcing for downscaling. Right now, there's less than a dozen models with available boundary forcing 6-hourly data and things like that. And so we have limited ability to select models and do large ensemble because they haven't saved the data. And typically they save only from one member and not every institute. In addition, if you want to evaluate your downscale data with a host model, we find out that a lot of models didn't save daily data, even for basic variables like rainfall and Tmax and things like that. So it's really difficult to understand how this to compare and things like that. So we need to make representation to maybe institutions who run CIMAP7 to actually pay attention and give us the data we need.
Yeah, thank you very much. We tried to do this, and Grigory, I don't know if you want to talk about this in a second. We're trying to do this for each cycle. And the more complex the output of the GCM get, the more difficult it's getting for us to get more boundary conditions, because they just refuse, because of funding, of storage funding capabilities, they just refuse to save boundaries from all the members they have. And we were fighting, I remember for CIMAP5, I think we were quite good to get as much out of as possible, but for CIMAP6 was even a stronger fight. And for CIMAP7, I think it will be another. This week, the CIMAP group is meeting. This week, in parallel to us, and we cannot be there, although we had been invited to make strong points. We do our best, and that's why I say it's good if you get all engaged as much as possible, push from your national point of view towards these, talk to your GCM modelers and your favorite ones, and make sure that CORDEX needs data. Grigory, do you want to comment on this?
I have the microphone. I took comments actually.
I'm sorry, but it's okay.
No,
Go ahead, and then it's Grigory.
Well, if there's somebody else, it's fine. But the microphone ended up here. But just very quick on this issue, I agree with you. It's very difficult to get the data. But honestly speaking, I think this is more of a psychological issue, because I looked at CIMAP5 and CIMAP6. I made plots. And if you do per degree of global warming, it's difficult to see the difference. So it's really, I don't know what CIMAP7 will be, but in terms of real science, I personally don't think there is a big issue. The other point I want to make is maybe you can look at these things also from a process point of view. For example, identify some areas that could be really important. One that comes to mind is monsoons, for example. Another one is hurricanes, typhoons, and so on. I think that approach for the focused, for example, high resolution modeling could be a good one.
Yeah, thank you. Grigori, do you want to comment on, I would like to have the comment from Grigori first on this, and then we see if there are more comments, and then we wrap up.
Yeah.
Okay, there's one. Yeah.
Okay, so my name is Grigory Nikurin from SMHI, and about boundary conditions for RCMs. So basically, it's not mandatory for global modeling group to provide this boundary forcing. It's up to them to decide if they can provide it or not. And there is a well-established procedure how to do this, because we did this within CMIP 6. Basically, we provided our request from CORDEX to the CMIP 6 data request, and basically all groups, global modeling groups, they know what to archive for RCMs, and basically we're going to do the same for CMIP 7. So from this point of view, all these informations will be downstreamed to the CMIP 7, but then we don't know how many groups going to provide these boundary conditions. But already from personal discussions, I see that many groups are interested in providing these boundary conditions, but mostly it's about the same group as for each CMIP 6 CMIP cycle. But yeah, we're going to discuss. But of course, resolution is increasing, complexity is increasing. So basically, it needs a lot of storage space to provide this boundary data with a 6-hourly frequency at the model levels and so on, so on. So it's a very big problem for, I would say, for many global modeling group.
Okay, so if one more comment up there.
So Bamboo from the UK Met Office. I sit on the CMIP 7 ensemble task team, and we're currently thinking about priority experiments for CMIP 7. So there's two major differences. One is there's a recommendation that CMIP 7 will be emission-driven for CO2 rather than concentration-driven, because there's a recognition we're not cascading the full uncertainties down to impact via CORDEX. So there's a recommendation which has been taken up by Scenario MIP that it will be the emission-driven will be given a higher priority, with the idea of that feeding through to impact both through CORDEX and EMIP. The other strand that's important to mention is that we're thinking about fast track. So climate service, there's not an appetite in the global modeling communities to do same scale of modeling as we did in CMIP 6. And so there's a desire to identify what are climate service relevant experiments so they can be fast tracked, prioritized by the global modeling communities. And that's intended, and although it looks like we've not really communicated or engaged where we should have done, to provide that data to EMIP, to CORDEX, so that we can have a more joined up projections system for IPCC AR7 than we did in previous chapters. So I think from the task team perspective, we would really welcome recommendations. If this community could come up with recommendations of what they think are their priorities. The experiments are like to be a current inertia, which is something like similar to 4.5. There's going to be a couple of mitigation experiments because they're deemed to be the questions are about how the pathway to zero emissions and the different implications, and one high end, which is probably going to be lower than 8.5, something like 7.0.
Yeah, thank you very much. The dialogue with CMIP group is really very welcome, and it has enhanced a lot over the last year. So I think that's really, we have to state this, that you do not get the wrong impression. I mean, there's a good dialogue ongoing, but I think it's important that we keep in touch on these issues, and we will come back to this, I guess, on Friday.
So perhaps this week, if we have a think as a community, what are your recommendations? If we can't prioritize everything, but what experiments do you need? One ensemble member? Are you looking internal variability? What are your priorities as a community? And we'll try and capture that.
Just one thing. So obviously we saw there were some issues with selecting GCMs for dynamical downscaling, right? They have to have the requirements like 6-hourly data. I think this is where emulators can help, right? Because you can train an emulator to take in things like daily averages, and this enables you to downscale more GCMs, right? Because then you have access to larger number of configurations. So something that we've been thinking about is, how do we train our emulator? So in our case, we're looking at, mapping from daily averages rather than 6-hourly fields, which gives us access to more GCMs and so forth to capture that uncertainty. So maybe emulators, if they work well, can hopefully supplement, some of the problems that we face with RCMs.
Yeah, thank you very much. I think we have to close down the session. We are on time. I think this was very, very good. At least for me, it was very good. I hope you feel like I do. Thank you all to Pune, but also here in the room for the good comments. I would like to ask the SAT members, the POCs, and the Flagship Pilot Study PIs to come here to this desk and stay here for a moment for a little lunch discussion. And the rest, please have a nice lunch and come back not delayed for the afternoon session. Thanks a lot.
Is the technical guy here? No. Okay. Nice try. We're going to start in 2-3 minutes, just letting time for more people to come in. Thank you. Okay. Hello, everybody. I think we should start, even if many people are still eating. So welcome to session B, CORDEX Interaction with Society. My name is Dominique Paquin, and I'm going to chair this session with my colleague Amira Nasser, that is just here. So we first have 2 invited speakers, and then we're going to have 3 regular speakers. Everybody has 15 minutes. Including questions, and then after we're gonna have a panel. So in this session, we're gonna focus on strategies for communicating climate information to society integrating climate information to real-world decisions, and understanding user needs and capacity. So in 90 minutes, we're going to cover what we aim to do for the last 20 years or so. So our first speaker is Bill Gutowski, who's going to talk about growing societal partnerships for climate resilience through collaborative storytelling. So.
Okay, thank you, Dominique. Yeah, it was interesting when those of us who were presenting got together yesterday. All commented we thought our talk was going to be a real outlier. So we got a lot of outlier talks. Hopefully that will be very stimulating for the panel discussion that goes on afterwards. I want to acknowledge a couple of other people who have contributed to this talk, my postdoc, Brandon, who did a lot of the technical work, but especially Linda Schenk, who is a professor of English literature. And that may seem like a strange background to be bringing to a CORDEX meeting, but it's very much tied in with this whole notion of collaborative storytelling. There's a lot that I've learned from her about collaborative storytelling and how that ends up getting us connected with community engagement. And what I want to be showing you today, I hope, are some overarching principles that I think could guide a lot of work that you might want to be doing. I'm going to be illustrating it by a couple of specific tools that we have used. I'm not going to be advocating that those are tools you necessarily want to use, but they're ways of illustrating the basic concepts that I'm trying to promote. So keep that in mind. I mean, if you're interested in the tools, that's fine, but that's not what I'm really trying to get at. So I think everybody from the talks I've heard so far all understand that there's this big issue of how you connect with community partners when you're talking about climate change information. There's a large amount of volume that gets generated. And in that context, we researchers produce lots of output that we connect with other researchers, and everybody's happy, having fun and games, analyzing that data. But the broader public really kind of gets confused. They don't understand the context of the data. They don't know how to use it. And in particular, this challenge that has been brought up already at this meeting, how do you produce information that is relevant to the people you're working with, that they find is credible, and that gives them guidance on how to engage in further actions related to climate change. Discussions about this have been going on for some time now, and it's led to this whole notion of co-production, or as I say here, co-creating knowledge. This diagram comes from the latest IPCC report, and I think it illustrates some aspects of what's going on here, that you have all these different groups that are involved, people producing climate data, scientists who are doing research with it, and a wide range and a variety of users, and they're all interacting and need to be interacting constantly to really come to understand what are the key issues that need to be resolved and what is the information that's actually needed. And in doing this, there are some various characteristics that are very important here, which go back to this notion of storytelling, as I'll illustrate, but issues of relationships, equity, who gets to be involved in making these decisions, who has the authority, creativity, understanding what we need to be doing differently, perhaps, to arrive at relevant information, and recognizing the values of everybody involved, including the values of us scientists involved in this, because at the end of the day, we're also stakeholders as well, and we are motivated to do our research by what is important to us. So recognizing all that, trying to pull it all together, very complicated. The co-creation pathway that we have been using involves storytelling, it allows for having diverse ways of knowing, which I think is important for trying to address the issue of changing climate and how you produce relevant information. Storytelling, not to each other, but with each other, has been a common practice for cultures for millennia in terms of how the concerns, the needs, the values of communities, of cultures get communicated and passed on. And we're really trying to tap into something that really is a practice that's been around for humanity for a long, long time. But in our particular context, it becomes a way of connecting personal experience and local knowledge with the scientific systems. And I hope I can illustrate some of that in what I show today. And in doing this, because it is a community coming together collaboratively, it fosters creativity in terms of how we approach what the information we have, fosters connections among people, and thus relationship building. So how do we do this? How do we get people that we're working with to start telling us their stories when we're thinking about climate? What do we need to do to prompt them to start telling their stories? I'm going to illustrate that with the next few slides in terms of how we approach it. Again, the key issue is fostering creativity, not necessarily the specific details of what I'm going to show you, but a tool that has worked well for us. And to do that, this taps into my colleague Linda's background as a scholar in Shakespeare. I'm not expecting that everybody is familiar with Shakespeare's plays, but a question we often ask people is, why are families in Romeo and Juliet feuding so intensely? And we're never told. Shakespeare does not tell us, and that's actually a gap that Shakespeare left out. And a lot of Renaissance story writers did the same thing. They left gaps. Why a gap? Why leave out some information that maybe you might want to know about? Well, that gap means that people seeing this play start to think about conflicts, feuds that they've been involved in, maybe a feud involving their family or their community or some larger political entity. But it becomes a way for people to start to think about this play, not as some historical artifact that involves two people who were falling in love several hundred years ago, but they start to be able to relate to it and connect it to their own personal life. So these gaps become an important aspect of how we've been approaching this whole issue of prompting storytelling and listening to other people. So one of the tools we use, and you're going to look at this and say, my goodness, this is incredibly simplistic. And it is. And that's actually part of what we're trying to do here. This is this tool called a community environment model. What it shows is a hill slope adjacent to a river, and there's rain falling on the hill slope, and it starts to produce erosion, and some of that will wash down into the river and start to pollute the river. But there's also these human agents running around, and if they're connected well enough, they start to work to prevent that from happening. There are a number of controls off on the left side. People can come in and use this. There's some graphs on the right side so they can see how things are progressing. But at least to this question, I mean, this isn't hardly a leading edge climate model. It's really practically a cartoon. And you wonder, how can something so simple help? Well, for us, there's all those gaps. That utter simplicity really becomes a space to prompt stories by our community partners that we're working with. So it's something that's very accessible. They can run this model. They can play with it. They can feel like they're comfortable understanding what it's doing. And I would contrast that with prior experiences where I was trying to work with community groups and showing them our climate models and what the simulations did. And they were totally perplexed. They couldn't really, I mean, they might trust me, but they still felt like they didn't really understand what was really going on in these models. This is something they can control. And it's not like they recognize that this is what climate is doing, but they can start to understand how to play around and think about what this means to them. So that these various gaps we have here, we're not very specific about where this is located or what's going on. People start to relate it to their home area, or they maybe start to relate it to a larger watershed. Multiplicity, they can start to think about different pathways, different climate scenarios as presented simplistically in this model. And then most important, this gap of revision. After people get comfortable using this, we ask them, how would you change this? What's missing? And in doing that, we're starting to recognize that they have authority too, and we're trying to bring out their authority. Oftentimes groups we work with are groups that have been pushed to the margins and feel like they have no say in what's going on in their society. This is a way of getting them to understand that, yes, they do have important knowledge, important values to present to us. And it's a way of bringing in their own particular values and their knowledge and say, yes, you have authority too. It's not just us climate scientists. So it's an accessible tool. They can feel comfortable with it. And it also is evocative, and it gets them to bring out their own understanding of how an environmental system evolves and where they fit into it. So in storytelling with our partners, we have a number of goals that we try to satisfy. We want to foster those relationships. We want to make sure there's equity involved and creativity, and we want to make sure that we recognize the values that people bring to the table, which comes through with their storytelling. That means we listen first. As researchers, we often have this expectation that we're going to go out there and tell people about our work. So it's a real challenge for us researchers to actually step back and say, no, we got to listen first. But we want to find out what was impactful, memorable weather and climate to them. And we want to, again, recognize that everybody has authority to bring to the table. Very important if we're going to work together as a cohesive group. And we want to take all that, those individual narratives, to develop a collective understanding, a collective storytelling with each other. And this is inspired in part by some work by Mike Hulme, who says, well, when you get these gaps in your scientific knowledge, the goal shouldn't be just to fill it in with more scientific information, but to start to layer in the diverse knowledges of all the people you're working with to make a better understanding of what that information does mean to the larger society. And as social scientists talk about it, it involves, when you get everybody working together, creating a so-called cognitive ecosystem among all partners, where people start to intuitively understand everybody and start to share their understandings and start to ideally work together. So the outcome is ideally meaningful climate information. So what do we do with these stories? Once we collect this information, we start to have some sense of direction. What we do is we start to work with storylines, which everybody here in this room, I believe, is familiar with based on talks I've seen so far. Our particular goal in this is to work with what are memorable or impactful weather and climate events in our societal engagement. And that tells us what kinds of stories we want to be pulling out of our climate models after listening to our partners. We do this by using the so-called object-oriented analysis, or what I would also call event-based analysis. I don't need to go into the details of this slide, but it comes from some tracking software that some colleagues have developed to track tropical storms that they study. But here our objects are much simpler. They're objects of daily precipitation, which we interpret as events. We can interpret those events as climate storylines. I'm going to show you one example here. And this gets at the heart of how we've been working with outside groups. In particular, this group we're working with are women who own farmland in my home state area of Iowa. It's a very agricultural area. In my home state, women own or co-own over 50% of the farmland, but they're often pushed to the margins. Their viewpoints are not considered. It's very much a very gender-biased approach. And so they feel like they don't have any authority. And we've been working with them to understand what they feel is important on the land that they see. One of the things that has come out is erosion. So we start to develop objects and then storylines of erosion producing events during this late winter, early spring period and where I live, when the ground is bare, before crops have emerged that could maybe retard that erosion. This has been inspired perhaps by that very simplistic model I showed you a few slides ago, but it's also inspired by just their own looking at their own land and telling us what they see. So we've talked with erosion experts about how rainfall contributes to erosion. And what they told us was that the events we need to be looking at are really pretty modest rainfall events. We're talking about getting events where the daily precipitation can be as small as 32 millimeters, or what we've been told, 1¼ inches, but hardly anything that you'd call an extreme event. But we're focusing on this because this is what's come out of our interaction with our community partners. And what we have here are results from analyzing these events, how often they occur in these 3 months of February, March, and April, in 2 different climate models, 2 different climate simulations. The heavy lines are contemporary climate simulations. These are actually 2 simulations produced by RegCM, driven by a couple of different global climate models. So 2 different heavy lines here. And then what happens in a mid-century climate going forward about 50 years or so. And these arrows here show how things are moving forward, changing in time, and that leads to a particular storyline that we can talk about with them, that erosion events will occur about 2 weeks earlier, promoting more erosion unless land management changes. And they can start to think about that. They can start to work with the people who are working on their land, and now they feel like they know something that's important. So just some concluding thoughts: object-oriented analysis, natural focus on events. These events can lead to decision-relevant storylines motivated by the interactions with our community partners. I won't show you it here, but we can also combine different types of events, talk about compound events. This approach is very flexible. It can build on the experiences, concerns, perspectives, and values of all that are involved. It promotes co-exploration of the climate simulations and thus co-production of climate knowledge, which in turn ideally promotes appropriate responses. And with that, I'll say thank you. There's a couple of papers here, one that's been out for a while, one that's almost out, and this is the graphical abstract from that WIRE's climate change paper. So that's it.
Thank you, Bill. Do you have any question? I don't know if there's some people online still, but you can write questions on the Q&A.
There's a hand over there.
Thanks for your talk. It's really interesting to see that somebody in this community is talking about co-production of knowledge and all this. That is something in the sociology field. They are working on that for a long time. But I don't know if you have experience about trying this in practical situations, and how do you involve the right people on that? Because really it's very important to know that there are key people that can help a lot on that, but it's not easy to keep them on the project. So
Yeah.
how do you do that?
Yeah, well, I mean, so how did we gather this particular cohort of people? We've been working with a group that actually, in where I live, it's a group called Women, Food and Agriculture Network. So women who are engaged in agricultural processes. We're also about to start a project involving an indigenous tribal group in the United States. Obviously, some of these details here are not going to be what you want to use in different contexts. I've got some colleagues who have worked with professional water managers for several years. And it's, even though these are highly trained people, oftentimes engineers, they still have had to work for several years to get to where they had that sense of understanding with each other. Again, it's the concepts that I'm trying to push here. Particular tools we use, maybe they might be of interest to you, but yeah, it does take some work to find the right cohort, especially if it's people that have been marginalized and they don't feel like they have any reason for coming forward.
Thank you.
The last quick question.
Hello. Hello.
Yeah.
Sorry, there's a question. If you from online, please write a question in the Q&A because we have a question in the room.
Yeah, thank you.
No, sorry, we don't hear you quite well. Can you write a question in the Q&A, please?
This is from Pune. Can you hear us? Can you hear us now? Better?
We can hear you, but we have another question that's being answered here first.
Okay.
Yeah, communicating science to policy is very important. What the role of media, like, did you utilize media to communicate your science to the community and the policy people? Because we have one experience in our own project and it was very useful.
We have not been working directly with media, in part because we're trying to, the focus in what I've shown you here is with groups that feel like they're just left out of the whole process to begin with. But that would be a further stage, especially if we can motivate them to assert their authority. But we have not worked directly with media. We do have some interactions with media professionals along the way, but it's not been the key focus of our particular work. You've got more experience in that, and that's something you might want to bring up in our panel discussion later. Thank you. Okay, Pune had a question.
Yes, this is from Pune. I'm Mandira. Well, thank you for your presentation. I'm quite encouraged to see that women as well as the indigenous groups are also being consulted and their inputs are being integrated. Now, the question I had was regarding this example that you provided on the community environment model. So in order to make the community, or the example that you showed about the farm,
understand about climate change and about the issues and then seek their input. So is this a model? You said it's a game, but is this more like a computer simulation that you have? And what kind of materials are being used in order to ensure that the information is communicated, and as well as their inputs are being integrated into the model? So thank you very much.
I'm not sure I fully understood the question, but I thought I heard a question about it being a game. I suppose you could view it as kind of a game. There's no clear necessary objective. It's really more of a tool to get people to start thinking about what the environment means to them, and how, when you have these sliders, you can change the climate, the weather conditions, and to get them to think about what all of that means in the environments that they're used to experiencing, which could be their own local community, or it could be something even broader. Some people using this have started to think in terms of the entire Mississippi River Basin where I live, or some people who come from other areas have thought about this in the context of where they live. But it's not, again, intended, I mean, you could view it as a computer game in some ways, but the real goal is to have it be an evocative tool that gets people to start telling their stories in the context of changing climate.
Thank you, Bill. Okay, I will encourage people who are from Pune to write the question in the Q&A or in the chat so we can read them. It's going to be much more easiest for us. So thank you once again, Bill. And now I will invite our second speaker, which is Bruce Hewitson, who's going to talk about the RIFs, so positioning WCRP research in the bigger picture. He also has another title, which is WCRP takes on the elephant in the room. So.
Great, thank you. I'm not sure how this is going to go down, but it does follow on what Bill says. It's probably out of scope of many of yours experience, but we'll see where it goes. So this is a classic opening slide for WCRP, used in many, many WCRP presentations. And where's society in this? And this is the problem. So WCRP has put together the Regional Information for Society core project. It's a new core project. We're only just getting up to speed. Co-chairs myself, Sylvina, and Sarah Pryor, who's not here today. There's a problem there. There is no society in there. And we are tasked with linking the WCRP activities with society. So what is society? Where is society? And this is my granddaughter. I have only one grandchild, and I've been told in no uncertain terms it's the only one I'm going to have. I'm not going to get any more. But this child is going to be 80 in 2100. And a lot of the projections historically been 2100. What about 2050? What is the future? And this is where the WCRP, as a coordinated scientific activity, has a huge responsibility to think about how are we taking our science, our very specific, our very detailed science, and bringing this in service of society. Now, the second problem I have with the title of Regional Information for Society, RIFS, is it's for society, which does not encourage a dialogue or a debate. It's like client-service relationships. And so we need to think carefully about this. And I'm going to try and unpack a little bit about the challenges that we face in RIFS after talking a little bit about what RIFS is. So RIFS, of course, sits in a big picture. It sits in some sort of messy world context. And in many cases, the science component that we want to feed into society that we think is so important is actually irrelevant relative to some of the pressures that elements of society are facing. So we need to be thinking quite strategically about how are we going to bring what is a critically important message into a decision framework that is dominated by externalities that are not climate. So RIFS, what are we about? Well, we have a vision statement, which is to understand, develop, and enhance the effective flow of relevant information among scientists, decision makers, and society. It's not one directional, it's talking about the flow between these communities. And we have a number of mission statements around there. I'm not going to go into detail there, but I want to emphasize the point that some people think about RIFS is now the climate services for WCRP. RIFS is not the climate services. RIFS is about research on how to link the science and society. And we're exploring a number of research frontiers about that, and then I want to unpack those in the rest of the talk. But we want to do facilitated regional activities, external partnerships, engage with the climate services community, connected with stakeholders, whoever stakeholders might be, but effectively enhance the construction, communication, and adoption of climate information by society. And what does it take to actually do that? So RIFS has three overarching challenges, which is probably where I'll end on talking about RIFS specifics. First is how to optimally identify, understand, and model the relevant climate processes that are most critical to managing socio-ecological risks. Second is how to optimally integrate multiple lines of evidence to inform society's climate information needs. And then third is how to best undertake the engagement with stakeholders and to maximize the information benefit and ensure the user context is integrated, which you won't find that phrase commonly used in many of the climate services arenas. So structurally, there's all sorts of complicated things. The only two messages are coming out of this slide is that CORDEX is homed within RIFS. That doesn't mean RIFS tells CORDEX what to do, but it's the intellectual home for RIFS. Along with the Global Extremes platform, if you don't know about that, that's an interesting one to go and look at. And our IPO is established in Canada. And just this week, we appointed Dr. Naomi Goldenson, who starts off as the director of the IPO. And she started on Monday. first key action that RIFS is doing is engaging in conversations. And this is just a slide I used when I was talking to Spark, looking at what are the intersections of the different WCRP core projects and RIFS science plan. And where do we find the intersections and where can we find collaborative value? Because RIFS is around building collaboration. It's not about a standalone closed silo. So if we go beyond that, and let's think about what are the problems that RIFS are trying to address. This is a typical output from science to society. This is the atlas from AR6. This happens to be 33 CMIP models. It happens to be 31 CORDEX models. And I highlighted the area. Obviously, I went and chose the worst case scenario I could find because I want to drive home a point. But if you're a decision maker and you're faced with this, what do you do? And where do you get guidance? And this is just the tip of the iceberg, excuse the innuendo there. That is a big problem that we have pervading throughout the climate science when we're trying to think about this decade of action that COP26 talked about, that we have a short time window to respond to. And how do we go from something like this to a decision maker who needs to build adaptation actions in the near term, not for 2100? So that's the relatively easy side of the challenges that RIFS are facing. But there are a whole host of other challenges that RIFS really wants to try and dig into. So context is king. The context of the application, the context of the decision maker, the context of the world that we're trying to feed information into. There's a difference between awareness of the issues and a comprehension of the issues. We're all aware about the war in Ukraine, but do you really comprehend what it's like on the ground? No, because you don't have the lived experience of that behind you. So one of the challenges in trying to do climate information with society, rather than for society, is how do we get a grasp of the context of the decision maker's world in a way that we comprehend what is really needed of us. And so there are a host of challenges, and I just put some samples here. So, for example, there are different modalities you can adopt. The client supplier is a classic one. Tell us what you need, we'll come and deliver it. Co-production, Bill has talked about. Co-production works very effectively, but it's labor intensive. It does not scale easily. It takes a lot of resources to do co-production effectively. And I know I've been doing this for a long time now. And then there's a sort of emerging line that I call partner relationships, which is rather like two siblings in a family. Maybe the one sibling is a doctor, the other one is a climate scientist. They're in relationship. They know they have access to each other, and they cross paths when and how they need to as they go forward. But that takes building relationships. And as climate scientists, we tend to live in a bubble. We're not good at building relationships with people who are living in another world. Then we have issues like the presumption of power. I mean, not the presumption, the power of presumption and assumption. We make assumptions about what our stakeholders need. We think we know what they really need. And so we deliver a product that we think meets what they need. And this causes all sorts of power relationships, implicit ones, not deliberate ones. But there's already the implicit power relationship between the global north and the south, or the resource rich and the resource poor. There's the implied relationship of science authority. I'm a scientist, I have professor in front of my name, and the policy and decision makers. And you know what it's like when you're talking to a policy community and you come as, I'm Professor so-and-so, they listen to you. Not necessarily they should be listening to you. There's big issues of cultural contrasts. So we have a major problem where the global north is building climate services for the global south. And even we know we have conflicts within the science community. We don't need to talk about global models and regional models. And this all has a mismatch of adaptation context. And the information is not appropriately on the scales in space and time that the decision maker's world is dealing with. And that's why co-production works, but I guess again, that's labor intensive. So if you just try and think about, you're doing a climate service project. I've heard people talk about, we're starting up a climate service, we're doing climate services. What if you're sitting up on the top right-hand corner here? This is a map of culture. So the top right-hand, we have Sweden, Denmark, Norway, Finland, Netherlands, Switzerland, Ireland, Germany, pick where you are. And you're doing a climate service and somebody's sitting down here on the bottom left-hand side. Do you comprehend the lived experience that they engage with? And as a decision maker, the challenges they are dealing with? We have the same language maybe sometimes. We use the same words sometimes, but we mean different things. But the lived experience means how we see the issue is very, very different. And if you want to talk about bringing climate science into society, we've got to deal with these sorts of issues. At the moment, we have this very strong tension of one part of the world, one cultural container, trying to deliver information for another cultural container. And it causes on-the-ground problems amazingly. We see a lot of that, and it opens the door to maladaptation. So I'm going to quote from 2 PhDs. So I think the PhD generation of today is much more wise than my generation. So the first is from Anna Stano, who did a PhD on climate services and co-production. And she says, the specificities of the decision context are not well understood and are often not considered in the development, tailoring, and supply of climate services. Yet, utility of climate services relies on them being suitable for the decision context. So an understanding of the decision context should be central to climate services development. The linear supply chain approach struggles with that. The second quote I'd have is from Jessica Lee, who comes out of philosophy, actually. She did a philosophy on values in climate science, and she noted 3 conflicts that can arise. The one is conflicts between epistemic and social values. In other words, the sort of epistemic type of information, knowledge that we deal with, and the social values. The conflicts related to the multiple roles that scientists might occupy in society. You just look at the tensions arising when a scientist tries to become an activist. And the conflicts between personal values and community values, which are often at odds. And she concludes that embracing non-epistemic values as constitutive of the field will have implications for the practice of that field and can contribute to the development of a code of ethics for climate scientists. We need to think about values, which is not something we normally think about, in the conduction, design, and implementation of our scientific endeavors. It comes down to, how do we stand in the shoes of another? How do we comprehend the differences in values and not presume to understand the values of the target audience that we're trying to deal with? How RIFS is going to implement the questions or frame the questions is going to be critical. And you all know, for those of you who come through a PhD, defining your question is probably the hardest task that you have. But just 2 examples of how one could reframe questions. A conventional approach to bringing climate information into society is to say to the users, which I really don't like that word, but you hear it a lot, tell us what you need. And the idea is that we go away and we produce a data product and we deliver it over to them and they know how to use it. It establishes this modality of supply chain presumptions and that we presume we understand the context. Whereas you could actually ask instead the question, and we've done this, and it leads to very informative outcomes. What do you really wish that us scientists would understand about your operational context? Don't tell us what you need. Tell us what you wish us to know about your context, because that will change how I approach my analyses and the formulation of material and information that you need. Or you could take a more personal approach and say, what is it that I don't get about the lived experience of decision makers' context? So think about a decision context that you perhaps provide information for, that you would like to provide information for. Do you really comprehend the lived experience of the decision maker working in that environment? Because if you don't, you're likely to produce a misaligned product. So these are the sort of things RIFS needs to deal with. I'm going to end up with what I'm calling the elephant, the big elephant in the room. This is a figure out of IPCC chapter 10, working group 1, just looking at the flow of the sources of information, how they get structured down, they come out to some supposed perfect product at the end. Not perfect, but comes out to a product. What is the policymaker to do when he sees this? Invariably, the policymaker only has access through to one subset of the data. There are conflicts and contrasts depending on what data set you use. You will get a different answer depending on what data set you use. And at the moment, there is no systematic endeavor by the science community to undertake this challenge. And I raised this at the JSC of the WCRP this year, and everybody said, yes, the elephant's there. It's a big elephant. We need to deal with it. But nobody wanted to actually wrestle with it. And I'm hoping, as a co-chair of RIFS, I can try and foster something around that to get us to deal with a systematic approach around addressing this issue. And I'll close with this, the time imperative. I started with my granddaughter, and I think there's a time imperative. COP26 talked about the decade of action, and we have a challenge of our hands. At the moment, as an example here, 3.8% of global change research goes on research on Africa. Okay, and Africa is considered the most vulnerable continent around. And you can see over the years it fluctuates, but it's way, way down there. And of that 3.8%, less than 1% goes to Africa institutions. So 99% of the limited amount of research funding on Africa climate goes to global North researchers. And now we have the cultural contrast issues, we have the value issues, we have the context issues. And so we have a challenge on our hands because we do have a time imperative that puts a lot of pressure on us. Thank you.
Does anyone here on online has a question for Bruce? Yeah, Daniel.
Thank you very much, Bruce, for this introduction, what RIFS is looking for. And let me put aside my CORDEX hat and take my Climate Service Center Germany Director hat for a moment. And not only that one, because I fully support what you said, but I have not seen how you are going to incorporate and invite the climate service community. It looks a little bit like WCRP steps on the foot of someone else, which you claim you want to not do anymore, which I fully agree. But do you know, you were there, we have a climate service partnership with more than 1,000 partners, science and practitioners, with a strong buy-in from the Global South. We have 6 conferences, from which one was in South Africa and one was in South America and one was in New York. The other one was in China, I think, or India.
Jamaica.
And one was in Jamaica, and the last one one was in Brussels. So I have not seen a single word from you here. How do you want to cooperate with this community and avoid major errors and mistakes, which WCRP has done in the past?
I'm absolutely with you. I expected a challenge like that. And we're not shying away from that challenge. We have our first SSG meeting next week. So we haven't dealt with that, but we are fully cognizant that we are not starting from a blank page. We are fully cognizant that we are only one element in a much, much larger landscape. And we are not trying to do climate services. We want to work with partners about understanding how we can evolve the climate services activities, not as a prescriptive role of saying, we're now WCRP, we're going to tell you what to do, but to say we have to try and learn as much as we can from climate services and try and think about where we should put our efforts in about evolving that. So, for example, the elephant I talked about. What could we do as a community to address this conflation of different data sets into a message that sometimes is very difficult to defend? What is it that we can think about in terms of how to assess and communicate uncertainty in a way that goes cross-culturally into a different value system? So I don't disagree with you at all. And I can't answer you because we haven't started. Talk to me after SSG next week. We have some ideas. But yeah, I'm not disagreeing with you on that at all. Yeah, I have been in WCRP for 15 years. I know the problems, and I do not want to repeat those problems. So.
Yeah, thank you for a nice presentation. The things that to minimize the gap between the policy and the science, the scientific field, you mentioned about the uncertainty in different climate model. But if we look on another side, the observation that I have from developing country, the top decision maker, who are the minister or the director, they don't know in the ministry even the climate change, the science of climate. So it's very difficult to communicate your message to them. So their education or the educated people that having that position is very important. Mm-hmm. The second thing that they have need-based decision making, like if there is flooding event in the developing country, so that time you will see a lot of decisions. But in normal days, if you put some report or your agenda, so that is often ignored. So the third thing is the basic need of the country. Like in the developing country, they have the food issue, they have some other economical issue. So that it is impacted by the climate, and these modeling input is very important. But on the spot, these things are ignored. So we need to minimize the gap on the both sides, from the science side and also from the policy side. And then we can think that how we can merge both and how we can communicate the things.
I think a common element to a lot of what you're raising there is relationship. You educate, you communicate best when you're in relationship. When you're just somebody over there, you're just another voice in the noise. So relationship is really, really central to that. I would also like to draw a distinction between the policy community and the decision maker. The decision maker translates policy into action. And there are different levels that one operates at. There's different types of information that you feed to a policymaker as opposed to the information that you feed to somebody who's doing stormwater management in an urban environment. So there's a whole set of nuances that we need to unpack. And I want to manage expectations here. RIFS is not going to answer all this. But what we want to do is be a coordinating, facilitating activity that tries to help build some of these relational approaches and raise some of the challenging questions that are perhaps getting ignored at the moment.
Thank you, Bruce. I think there are more questions, but I think we can keep them for the panel afterwards. So thank you.
And now we're gonna start switch to the oral presentation. We have a set of interesting presentations, and we will start with Ramsos Benestet. He will talk with us about the lesson learned about the use of downscale the climate model result for practical use.
So I would like to acknowledge my co-authors, Andreas Dobler, Kajsa Parding, and Abdelkader Mesghani. We are from the Norwegian Meteorological Institute, and we provide regional information for society on a daily basis. And we have done so for decades. A few weeks ago, we were hit by an extreme weather storm called Hans, and even our Prime Minister forwarded the red alert. Nobody died, and it was well coped with. So our objective is then to derive robust and reliable information about future climatic outlooks on regional and local scales. So in other words, we want to provide actionable information. But how to do this on a climatic scale is still not widely discussed, as far as I know. And for instance, we see that a lot of climate services only provide dynamically downscale results. We did actually start to discuss this at a workshop in Oslo last year, together with the Norwegian Institute on Public Health and also CORDEX. And the thing is that practitioners need to deal with the sensitivity of methodology, how to actually overcome the model's minimum skillful scale. And this concept is not really often mentioned in our community, but we should really discuss that, because this is an old concept and we need to deal with that. What is it really? But this is the reason why we're downscaling, basically. And also, they had to deal with the chaotic nature of climate variations on a regional scale. I'll come back to that. And then also the different models have different climate sensitivity, and that might be skill depending. So I'll also come a little bit back to that. And finally, of course, the future missions are not set, so we don't know which way it's going. So when we look at the literature, we see that the reviews suggest that the dynamical downscalers do not provide much advantage over statistical downscaling. And we also see that they neglect important processes, and hence that's why we want to couple them and so on. But in addition to that, they are physically inconsistent in terms of the driving global models, because that change the processes like changing the rainfall patterns change the flow of energy and heat, and also moisture as well. So that means that before we can apply this, we need to bias correct them. But bias correction is just a way of reducing the mismatch between the model output and the observations. And it's a way of sweeping the problem under the carpet. And it's also very controversial still, even though we don't mention it anymore, but it is still controversial and some people don't like to use it. So, so using just dynamical downscaling results for climate services is premature, I think. So, but when you look at empirical statistical downscaling, it also has issues. And one thing that we should keep in mind is that you can downscale weather predictions and you can downscale climate projections, and they require different strategies. So when you downscale weather, you downscale the actual outcomes. So day by day, for instance, or month by month, like the state of the atmosphere or the temperature or rainfall at some point. When you downscale climates, you downscale statistical properties. And statistical properties are much more predictable than each individual outcome. And by statistical properties, I mean not just the mean values, but you can look at the statistics of extremes. We can downscale the shape of probability curves or the shape of intensity, duration, frequency curves, because there's information determining these shapes, and these can be often be parameter. Yeah. So, but anyway, downscaling is not the same as bias adjustment, and we have to remember that, because the whole principle of downscaling is to grab large-scale climatic aspects that the global climate models skillfully reproduce, and then we add information about the dependencies to local climates. For instance, how the geographical conditions affect the temperature. So it's a way of adding more information to the equation. One thing with statistical downscaling that I see a lot is that people use multiple variable predictors, many variables as predictors, and that is suitable for weather, but not for climates, because these different variables go in different directions when the climate is changing. And one example is here. So this is an attempt to downscale storm track density based on the mean sea level pressure and the 500 geopotential heights. And both actually have very strong connections on the calibration period. You couldn't tell which is better, but one is moving, has a trend, and one doesn't. So you get different answers in the future because of global warming. And this is the models how to capture in a good way or in a realistic way, but we know that the models are not perfect. Another thing, so I think the solution to this is to use both dynamical and empirical statistical downscaling. And the reason for that is that they are based on entirely different sets of assumptions independent of each other. So if you get the same results with the two, then you get much more credible results and much more robust results. They have different strengths and weaknesses, and they should be regarded as different tools to try to build this, construct this knowledge or this information. Also, there's a paper I urge everybody who do regional modeling to keep in mind and revisit if you haven't read it. And it's a paper by Desser et al. And it explains a very fundamental thing, is that you cannot rely on one or a few projections, because they demonstrated with one model and then ran it many times, 50 times with different initial conditions in the atmosphere. And they got widely, sorry. Stop pointing. Anyway, they got widely different results. So you have the red and the blue ones. So on a global scale, they got very similar evolution, but on a local scale, they got very large differences on decadal scales. So in order to get a good picture or to cover like what might happen, you need an ensemble of many models, even with the same model or with different models. So yeah, so here you see the global, and these are regional ones. So here's one example. So there's one projection of temperature in the Nordic region with a climate model, and you run the same model again, and you get the same, well, similar results, but you get differences as well here. And then you can show all the realizations with the same model, and you see you get a band here. So and if you then want to know the extremes, then you see then you need a bigger sample to actually get a good statistics on it. And also, if you have different models, you get a very different results as well. So you need to also evaluate the models as well. And this is one example here. So here we evaluate ensembles rather than single models. And we use the pattern of variability. So this shows the magnitudes here. It's actually based on the covariance structure. And it's called something called common EUFs. And it was coined by a guy, by Barnett in 1999. It's almost 25 years old. And surprisingly few people actually use common EUFs. And they're also very useful for presenting predictors when they do downscaling in any ways. So these spatial patterns here of magnitudes represent 96% of the variance. So this is more or less everything that happens here. And at the bottom here, you have curves that all refer to this pattern here. So you have a black era 5, and then you have the red CMIP 5, and blue and green CMIP 6. And you see that the CMIP 6 cluster more tightly around era 5. So they actually, you can show statistically that they represent an improvement over CMIP 5. And same thing you can do with the precipitation, and you discover that some of the models actually outliers there, but also you get a little bit more complicated situation with less of the variance of the leading mode. And you can do it on an interannual variability, and you can see that the models actually do quite well, so they embed the observations fairly well. And the same thing for precipitation. And all these curves represent exactly the same covariance pattern as well. So we want to make use of the available information. So in addition to evaluation, we want to show both dynamical and statistical downscaling. And here you see the blue curve here for Norway are the CORDEX ensemble. And then the red curve is the statistical downscale results for the same models. And you see they tend to follow each other fairly well. So they give fairly robust results. But when you compare to the entire, this is RCP 4.5 ensemble, 108 models, you see that it only represents a small part of the spectrum. So it gives you get misleading results if you just use these few models. So you need many climate model simulations, and the statistical downscaling can be used to extend RCM outputs to cover the full ensemble opportunities. And also when you look at the ensembles, they often are almost close to being normally distributed. This is for the summary statistics of seasonal mean temperature. That means that you only need two numbers, the ensemble mean and ensemble standard deviation. And you want to have sufficiently large ensembles so you get like a representative and robust statistics, and you want to avoid the law of small numbers, because if you have too small ensemble, as I showed you, then you get misleading results. So a summary is that, yes, we can provide a basis for providing information to society by using all information. When we want to adopt the climate information for real world, so it should be world here, sorry about that, decisions, we need to overcome this law of small numbers, because this is just pure fundamental mathematics and statistics, because we have a high degree of stochasticity but also the way we deal with models minimum skillful scale, that is a downscaling. And then we need to understand the user's need and capacity. So it will be co-production knowledge. We have to ask them, okay, so what information have they used before on weather? How does the weather affect them? And how have they used the information, and why do they use it this way? And this way will actually provide some capacity building and training and education and interaction. So I leave you with some references here, and thank you for your attention.
Thank you, Ramses. Now we have a time for one question. Okay.
Marie Ekström Calgary.
We are from IITM Pune. Is it audible?
Yeah, you can go in.
Rasmus, actually, in the morning session, we had a good session for statistical downscaling. And one presentation I was actually delivering, and at the time, the scientists who are basically using the product of statistical downscaling or dynamical downscaling, they have a lot of confusion. So somebody asked us, which downscaling is actually reliable to get used as an input for impact assessment study? So as you have already mentioned, I also have some information that sometimes we have seen that RCMs and GCMs are having resolution almost 1 kilometer, 2 kilometer, or 5 kilometers. So is there any need of doing statistical analysis, or whether the statistical analysis is more skillful than the dynamical downscaling? What is your opinion? Please share your experience and opinion.
I'm not sure if I actually got your question, but in general, I would say you should use both dynamical and statistical downscaling together, and then at least some of the variables should be the same. So you should see if they actually describe the same future. But it's very like when it comes to using the data, you really had to be specific for that case, I think. So it's very hard to generalize, I think.
Yeah. May I ask one question? Yeah.
The question in the room, please. Just a second. We have a question in the room first. Okay.
Right. Okay. So Marie Ekström Calgary, which is the global reinsurance broker. So understanding the landscape of uncertainty is really good. But as I'm sure you know, the stakeholders will at some point need a number or a scenario for decision. That could be pricing, that could be for quoting for some sort of resource. And I think that's the really big challenge about guiding them from having that, because quite often the decision makers are left with there's a spread. You have all these sorts of, and then they go, well, I don't know. So someone needs to make the decision, and who should make the decision, and how do you make the decision? So in your experience being operational,
I don't like the word uncertainty, because that means a lot of different things to different people. So it's in itself is uncertainty. So it's in a way quite brilliant as well. But I would say, okay, looking at probabilities of exceeding some threshold, because there's actually information in this spread and the way it looks, and it's the way that the statisticians work. So you can say, okay, do you have a threshold that you shouldn't cross, like a probability, or like to say, like a frequency or a risk analysis, for instance, or you can use it to estimate the IDF curves, or use it for like when it's threshold about, say, area planning, like where you get floodplains and so on. So it's more about probabilities and risks, I think, rather than giving it like, you know, it's going to be like 6 degrees or something, because it will vary from year to year. And everybody knows that you have interannual variability or decadal variability, which you cannot really predict. So you have the two together. You have one trend that you know is coming, and then you have the year-to-year variations.
Okay, may I ask you to hold the question for the panel discussion? We will have a panel discussion where you can ask all your questions. Thank you. Thank you, Ramses. These were important lessons. And now we will have a presentation from Chris Leonard. He will talk about the capacity building for climate science, CORDEX, and the WCRP Academy.
You can choose. Standing.
Before I start, I could see the group in Pune and Krishna and Sanjay. Hi, it's really good to see you guys. Wish you could be here or we could be there. Yes, I am Chris Leonard. I work at the University of Cape Town in South Africa. I'm a climate modeler, and I'm not talking to you today about climate modeling at all. So I'm here as a representative of the World Climate Research Program Academy, and I'll just tell you a little bit about that. My co-chair is Melissa Hart, who works at University of New South Wales in Australia, and I think we are the only co-chair pairing in the WCRP who are both from the Southern Hemisphere. So yay for us. Why a WCRP Academy? So the motivation for it is these are pictures from Cape Town. Over the last 2 days, on Sunday and Monday, we had a massive storm that dropped 300 millimeters of rainfall in 12 hours over basically the province, the southwestern parts of the province. And it caused massive flooding, infrastructure damage. So far, the report's 6 people, miraculously only 6, have lost their lives in the flooding. And we knew it was coming because we saw what was going on. A cutoff low was responsible for this event. And I looked previously in the literature for projections of cutoff lows. What do the projections say about the increased frequency intensity of cutoff lows in the Southern Hemisphere, but also in the Northern Hemisphere? And in AR6, the IPCC assessment report, AR6, working groups 1, 2, and 3, cutoff lows are mentioned in 1 sentence, and that's in chapter 10, in the entire assessment report, and that includes the special report on 1.5. So in this latest assessment report, cutoff lows were not assessed. My question is why? Is it because there's no literature? People are not concerned with it. It's not an interest to anybody. If you take this and you write a paper about cutoff lows, I want to be a co-author, please. Thank you. So what the WCRP Academy is trying to do is try and build the capacity for research in climate. So for climate change and climate science research. So why is no one doing cutoff lows research? Is it because we don't know how to run the algorithms that identify cutoff lows? It's just not an important question. What if somebody does want to research cutoff lows, but can't because they don't have the computers, they don't have access to the data, they don't know the software? What can you do about that? And we start off on our website, now more than ever, the world needs climate experts. And whenever I give this talk, I say, if you're not a climate expert, you have to disagree with that statement. But particularly in countries that are most vulnerable to the negative impacts of climate change, and Bruce alluded to that in his talk earlier. There's a large amount of excellent climate science training available, but a lot of it is not accessible, particularly in the global south. So we in the Academy are trying to think about how to provide climate science training and make it more efficient, more accessible, more sustainable by connecting communities who provide climate science training with communities who require a particular type of climate science training. And you can find us on the website there. So that's why. There are many barriers to climate science training, as we've discovered, in that, and there are a few of them. So no one institute can provide all the climate science training you need. There's a network that we need to engage in. Also, climate science training could be made more useful if it's designed with impacts and the impact of climate variability and change on society in mind. Again, coming back to what Bruce is saying about having, and Bill also. Then barriers to access training are primarily geographical. It's not because people don't want climate science training, although I'll contradict myself in a result I'll show you just now. But it's largely because of the situation they find themselves in. People often want to get capacitated, but can't for various reasons. Then the training at the scale and quality required for the next generation of climate scientists will require delivery both online and in-person contexts. So kind of what we're doing here, it's a really interesting dynamic that COVID has shown us what is possible, but then also what doesn't work. And then lastly, delivery of climate science training needs governmental, institution, and philanthropic granting to pay for the training. So how do you pay for this stuff? And this is a question we struggle with all the time. We're actually discussing it just before lunch too. So what is the WCRP Academy? How are we trying to address these things? So to facilitate the training future of the next generation really of climate scientists, we see that there are these two groups. Climate researchers who need some type of training in climate analysis or climate modeling, whatever that might be, and communities who can assist. So we're at the ICTP. ICTP have for a decade now run training workshops for their RegCM model, and this is the kind of thing. So who wants to learn to run the RegCM model? ICTP can provide it, and it's the role of the WCRP Academy to link these two communities, those that want a particular type of training with those communities who can provide that type of training. It's largely you can think of it perhaps as a marketplace or a hub for climate science training. I always get the idea of a cattle market, but maybe that's the wrong image to leave you with. One of the tools we use is an annual stock take, and I'll take you into that a little bit later. And the annual stock take is trying to survey these two communities, who can provide training and who wants training. We've done that, and we do this in two phases. The first, we looked at just within the World Climate Research Program, what is available in terms of climate science training. And then a little bit later, our second phase will be an outwards looking to everywhere else. And I'll show you that in a moment too. The other tool that we've just been building over these last 2 months is a portal, and I'll finish off this presentation with the portal. We've been going for 2 and a bit years now. So the setup, we're almost at the end of our setup phase, and we're launching into, this is really what we want to do. This is where we're going. The structure is, there's the 2 co-chairs, myself and Melissa, who do, basically we organize the folk who are doing the work of the Academy. And we have 3 working groups within the Academy. First is the Stockdate group. So these are a group of people who want to understand the landscape of training needs and training provision. And they've been very busy over the last 2 years. It's been the bulk of our effort. Then we have the Identity group and the web portal developers, and they are establishing the brand, the WCRP Academy brand that the world sees largely. And this is done primarily through the website that we're busy developing at the moment. And I'll show you a bit about that later. And then the third group, and this comes back to financing, is who can finance. So if the Academy is going to last 15 years or more, hopefully, how do we finance this? What's the business plan? How can we develop a business plan for this? And keeping in the back of your minds all the time that this is to develop the next generation or this generation of climate science or climate researchers. At the moment, this is how we're structured. We have a steering group. So that's would be the equivalent of the CORDEX scientific advisory team, who are each responsible for stocktake funding and identity groups. We have ex officio members who represent the WCRP core program, some of them, and an advisory board who kind of keep us on track, really. And this is us. We're not a big group at the moment, but you will notice that it has a very strong Global South representation if you look at the country column there, and this is deliberate. We see the Academy, yes, as developing relationships between communities who want training and who can provide training, but we want to do that in a North-South, a global North, global South context, but also a global South context. And CORDEX has done this already. So CORDEX has been doing this for a decade. We just want to formalize that really within the WCRP right now. These are our heroes. So Beatrice, Lau, and Narelle, who, if it wasn't for them, last year I was the only co-chair before Melissa came in, and it was a bad year for me last year. And they rescued the Academy last year, which is awesome. So what have we done so far? We've run the stock take, and I'm going to give you some results from that. 400 people completed it. We're busy writing it up for publication in BAMS. The overall survey, the number of respondents we got was 414 and relatively good global north, global south participants. Similarly, by gender, 222 men, 180 women, and 12 who preferred not to say, or non-binary. And then also, these are the countries who responded. So if you're from Brazil, you can give yourself a pat on the back because the largest number of respondents came from Brazil. I must still ask if you're responsible for that, Rosemary. Then we have, kind of Europe and the US coming through. And most of the people who completed the survey were in universities or some kind of research institution. I'll go through 3 questions now. So would you like access to additional climate science training? This is one of the questions we asked. And to a person, the Global South said yes. That's not necessarily the case for the Global North respondents. Some of them said we don't actually require any more climate science training, which is great. Maybe, but maybe not. So definitely Global South would like climate science training. In your opinion, then, is the climate science training and education available in your country adequate to allow researchers to work effectively on climate change, science, and associated fields? In the Global South, again, mostly no, it's not adequate. And in the Global North, a lot of folk thought that it was actually adequate, over 50% of the respondents in the Global North. So again, in the Global South, there's definitely appetite for this kind of thing. What are the most important climate processes training that you would like? So analysis of model results other than model evaluation. So again, looking at projections is what you're interested in, how to interpret those projections. Then the third one there, collecting observations, which in the Global South is a challenge, as was mentioned earlier. 2 minutes. Okay, let's zoom through this. General training areas, coding and programming, and here AI is going to be a big one also. And biggest barrier is finance, as we saw earlier. This will be available for you in a moment. Then we also interviewed from this group, 12 people, and from those interviews, largely saw that opportunities currently available for climate science training are inadequate in the Global South. These are all Global South interviews. Local experts, databases, and studies are limited in these regions. There's a preference for short courses, and the topic interest ranges quite a lot. And there was a call for more inclusion of Indigenous knowledge within science training, and lack of funding again was important. We then also surveyed within the WCRP who can do training. Most of it was in the Global North through short courses and targeted practical users of climate science. So not necessarily climate scientists who are engaged in this thing. Most of the organizations offer training in English, which is also a problem if you don't speak English. So the conclusions from the survey was that there's a good match between training recipients and providers, but there's a mismatch in terms of the number of opportunities. And we're trying to solve this through the WCRP Academy Knowledge Portal. This is now the website that we will release at the Open Science Conference next month. The website has these 6 links you can click on how to access, but the most important part of this is the catalog. So how to access, that's just the information sheet, but the catalog is really important. So here you can go in and search for any kind of theme that you would like training for. Tropical cyclones, cutoff lows, some thermodynamics, Earth-sea interactions, those types of things. And you can get that on the website in the catalog. And you can then go and see what courses are offered on those themes. Then we also encourage you, when it becomes live, to become a trainer, register as a training provider. So you'll be asked a number of things. We vet what's going on, and you can then be visible to the community with the types of training that you provide. So in conclusion, then, there's a good match between the recipients. The mismatch, we hope, as the Academy, we can solve through your participation in the Academy. And I'll leave it with that. Thanks very much.
Thank you, Chris. These are amazing efforts running there for capacity building. And now we have time for only one question, and then we'll take from the panel.
Chris, very interesting. I'm very glad to become aware of this. In the US, the American Meteorological Society has just relatively recently passed a certification, probably for master's level persons, someone who would be conversant in a lot of the climate aspects that you're talking about, but also conversant with the stakeholders. So a go-between in between the actual climate modelers, climate scientists, and the stakeholders. So I was a little, I wonder if you could clarify, you don't seem to have a go-between system here, and it's not clear to me what would work best. I guess I just wish you would explain a little bit more why you developed the system that you did.
Yeah.
As opposed to a go-between system.
It's a really good question, largely because we want to walk before we run. We do see in the long term that we would also engage that community for training, because we do need to develop that community in a number of other projects we're involved in. We see that link, that go-between person or the broker, as a really, really important component of climate research. But you're absolutely correct, it's not there because we're just getting started.
If we have one question from Bunay. I think we're good to go. Okay, thank you, Chris. And now we will have Linda. She will talk with us about regional climate modeling in North America and Europe. Why such a different basis?
In the pocket or
The pointing is the top one? Yeah, okay. Sorry, but
pointing stop.
Yeah.
Over the big one.
And that one, nothing?
Right.
Okay. Well, I was going to start this presentation by saying something clever like, and now for something completely different. However, all of the talks have been completely different. So I guess I'll skip that part. Myself, as well as a number of my co-authors that include a number of people who are here, have wondered about this issue. Why did America, and by America I mean North America, including Canada and the United States, not including Mexico, why the development of regional modeling is so different? And what are the implications of that? So currently, this is being done. Let's say this is the phase one of all of this. It's we're currently taking a rather informal expert judgment approach to the investigation. And we just by, talking about it, came up with possible explanations. And we're kind of trying to check these out. Someone is just based on nation states. Well, there are a lot of nation states in Europe. They all each has their own regional model, more or less. And we have 2 countries in North America. So of course, there'd be fewer regional models. Another interesting explanation is that Filippo moved. He went from the US to Europe, our loss, Europe gain. And of course, what happened in terms of the development of RegCM. Another is the balance of RCMs and GCMs within nation states. The US and Canada combined have 5 global models, more or less, and that's a large number. A really critical element, however, is the funding vehicles. There's different structures in the different countries. And I think at this point, we're going to really have to investigate that further to see what's going on there. So this is very much a work in progress. And it's clear that it's not really going to be easy to sort this out if we can at all. So some basic contrasts between North America and Europe. So the North American, let's take the CORDEX domains. The North America domain is much larger than Europe's, okay? Europe applies many more RCMs and it supports many more RCMs. North America applies fewer and supports fewer. So the basic question is, why is the number of models supported so different? And critically, what difference does it make in terms of determining future regional climate change? What difference does this make in terms of adaptation planning, for example? So in the beginning, way back, even when Filippo had a beard, RegCM1 was a US model, in point of fact. There was also the development soon after that of a Canadian model at the University of Quebec à Montréal by René Laprise, developed and supported the CRCM model, which now is supported and used a great deal in Uranus. But there were other US models, and this is kind of interesting, going back to what happened with all of this. There was the RAMS model developed by Roger Pilkey Sr. and the regional spectral model, not developed by John Rhodes, but used a lot by him and his group. So what happened to these other models? Where did they go? And then we know at a certain point, WRF, once again being developed from a weather model, became dominant and is used not just over the US, but certainly in many different countries, and certainly many different countries in the context of CORDEX. All right, so let's look at the different programs that have developed. So as Bill articulated in his earlier presentation, there was this PERCS program that looked at just two different seasons, basically, or two different time periods in 1988 and 1993, corresponding to a serious drought and flood period. And that involved, I think, at least 6 different regional models, including the RAMS model and the other model that was used earlier. Then we came upon NARCAP, the North American Regional Climate Change Assessment Program, that was really fully supported by a number of different US agencies, NOAA, NSF, EPA, and the Department of Energy. Then following on that, we have the NA CORDEX, which there is a big difference what happened with NARCAP and what happened with NA CORDEX. It was never formally funded, and this is, if I have time, I'll say a little bit about why I think that is. We had to use donated funding for producing simulations. However, we did get funding for data set development and distribution from a Department of Defense sub-agency. European programs, as we know, Prudence, Ensembles, EuroCordex, and then the newest, the EU convection permitting program. And I'm a little vague about this, but it seems to me that all of these involve both major EU funding and also some national funding for the different efforts. So if we look at the domains, just to show that indeed they are different in size. The North American domain is quite large. Europe is certainly not small, but it's certainly considerably smaller than the North American one. And now I'm just going to show you a couple of the matrices of RCMs and GCMs. So here's the Ensembles program, in which we have a large number of RCMs in this column, and then 1, 2, 3, 4, 5, 6 different global models being considered. And here's the North American CORDEX domain. in which, again, these domains, these matrices are very unbalanced for the most part. God, I counted how many there were here, and I can't quite remember. We have a nice experiment, but it's small, with RegCM and WRF, using 3 different GCMs, which sample relatively well the climate sensitivity of the global models. But then we also have contributions from Canada, both the Victoria operation and CRCM5, using the CAN ESM2 primarily. Okay, so getting into a little bit detail. So what's the relationship across these? So prudence clearly was, I believe, the earliest multi-model comparison using the SRES scenarios A2B2, 2 GCMs and 6 RCMs. We've already discussed PERCs. NARCAP is kind of a follow-on from prudence in a sense. And I decided to develop this pretty much while I was at ICTP as a visiting scientist for a year. And there we did, in both cases, prudence and NARCAP, they were time slices of 30 years, 50 kilometers, same number of 6 RCMs. One nice thing about NARCAP that I've always been very proud of was that we really developed a balanced factorial design, which means that it was a balanced matrix, which actually made it much more statistically analyzable. Then with ensembles, full transient, these were both 50 kilometers. Ensembles were going down mainly to 25 kilometers. More GCMs, more RCMs, but the matrix itself was still sparsely funded, and there's really no equivalent of ensembles on the North America side. Then, of course, CORDEX, full transient, going down, most of them down to 12 kilometers, 3 RCPs, multiple GCMs and RCMs. And NA CORDEX, again, we tended to be, a resolution behind. NA CORDEX mainly did 25 kilometers, some 50, and only one, well, no, that's not true. We did several different RCPs, actually. But the number of GCMs and RCMs was much smaller. I think by the time for the IPCC report, there were at least 55 EuroCordex simulations. And since then, there have been many, many more. And then Europe has gone forward with the EUCP, the convection permitting simulations as time slices. So there's kind of like a follow-on between the 2 sets of simulations, but Europe has always been ahead of us. Nah, that's not it. All right. 2 minutes. Oh. So our opinions so far, sort of further elaboration of what I said before, is that based on the nation state analysis, it makes sense since NA comprised of 2 states, Europe, many states, thus many regional models. Makes sense, right? What's more to be said? But certainly, it's still the case that North America is missing out on some important numerics and physics explorations by not using more RCMs. Another factor in terms of opinions is that there's been very distinct added value of the coordinated efforts in Europe, i.e. EuroCordex General Assembly, and less so in the US. We did have something like that for NARCAP, but again, due to failure to get funding, we really didn't have that kind of structure of assemblies for NA CORDEX. Okay, this is kind of, I'm trying to disguise who, I interviewed obviously my co-authors, but also other people in the community. So at NCAR, one scientist said, using other models is not encouraged. You're supposed to use WRF, just like you're supposed to use the CESM. It's not prevented, but it's not encouraged. And it's kind of interesting because, you know, I'm at NCAR, I developed NARCAP, and we got a big prize, an NCAR General Award, but it's kind of like there's still these separate universes. Everybody else is just using WRF. And I never really understood why we got that award. In the US, I think it's certainly true. Well, one more thing, that most climate resources go into this further development of global models. For one thing, there are so many of them. And that's not the case. I don't think Belgium has its own global model, for example. But in the US, there's also this lack of high quality organization across agencies, like NSF, NOAA, EPA, DOE. Getting funding for an RCAP was actually a rare success in this regard. And maybe somebody could ask me a question about why we didn't get funding for NA CORDEX. Future directions. Okay, we're going to interview more US and Canadian program managers to get a more in-depth perspective on this. Also, GCMs and stretched grids. And we had to figure out a determined approach for comparing the difference in information and uncertainty through using more or fewer RCMs. And I don't think anybody has done that. An idea also that one of the co-authors, Melissa Bukowski, came up with was the idea of developing a relationship tree similar to what Canuti et al. Has done, showing how closely related the different RCMs are. And I think that's it. Oh, there's my cartoon again. We already know that the Statue of Liberty is too tall. Okay, thanks very much.
Thanks, Linda. This was very insightful. And now we have time for some questions before we begin with the panel discussion.
Yeah, I remember in the very early days in Prudence.
Sorry, I can't quite hear you.
The very early days in Prudence.
Yes.
It was that model diversity and having different regions being focused on different type of processes was really important, because you got, I think, different within Europe, sort of the Nordic countries were interested in CEI, so those where the Mediterranean is obviously not necessarily so. But by bringing them together and realizing the importance of different systems, that improved everyone's models. So I think model diversity and bringing different regional knowledge is really important. And that's kind of CORDEX is a really good forum for that.
Yeah, that's a very good point. Thank you.
I think we should
move on
to the panel. Yeah. So you can sit in front because you're part of the panel.
Sorry?
You can sit in front.
Sit in front?
Yeah, with the other members of the panel.
Oh, because we're a panel, sorry. Forgot what we were doing.
Just sit.
Thank you for reminding me. Let me get this on.
Okay, so we prepared questions for about 2 hours and we have less than 20 minutes. So, okay, what we're going to do is that I'm just going to read the question we prepared. Then we're going to ask 1 or 2 to our panelists. Then we're going to open this for a question from the public. First from Pune, if they have some questions, especially for the man who prepared a question for Rasmus previously. So if he can have the microphone as soon as we open a question for the public, you can ask your question for Rasmus, and then we're going to open for questions from the public. And yeah, we're going to try. So the questions that we prepared, like I said, I'm going to read them. The first one is really related to what Bruce showed, but we didn't knew that before. So there is a multiplication of climate services centers. It's a little bit the law of the jungle, because when a user needs regional information, he may connect with ARCIS regional atlas to some national or provincial climate services. He may look at another country's services. He may connect with a consultant, and he's going to find different answers because different data are used either from GCM, from RCM, using different downscaling technique, using different RCP, SSPs, different interpolators, and using different definition of a specific indicator. So in the end, what is the message we tell to this user? And this was a question we want to address to Bill. The second question for Bruce was developing a common language with stakeholders take times, and time is running out. So do the risks come too late? Okay. The third question for Linda was a European community strikes back, because Copernicus is already a dominant player in the climate services. And it's a possibility that in a few years, many stakeholders from all over the world will refer to Copernicus instead of the local services. So what can we do against the European invasion? That was a question. Another question that we had for Erasmus was, there is a lot of interest towards CPMM and RSM, sorry. But is it really what the users need? Maybe they just want sub-daily, downscale, debiased information. Okay, from statistical downscaling. Another question we had for Chris was, sometimes decision seems to be taken from a political point of view instead of users' need. For example, to do SSP 126 instead of SSP 245. And so how can we prevent those political decisions? And the last question was for Bruce as well, because yesterday Detlef Stemmer said from WCRP said that they expect a lot from the RIFs, but somehow it's a bit because GCM community failed to fill the gap with the users. And how can we succeed knowing that once again, time is running late? So those were the questions we had in mind that we won't have the time to address, but maybe later you can grab one of our panelists and ask them the question. Okay. So we're going to start with Bill and the question about the elephant in the room, because Bruce addressed this topic during his talk, but for you, so yeah, what can a user do regarding when he needs climate services regarding all the possibility that he can find on the web?
Sure. I think what I thought about this question since you posed it to us yesterday. Thank you. I would not want to direct them anywhere to start. I would want to start having a conversation kind of consistent with what I showed earlier. And your question reminded me of something I heard many years ago from someone. We're at a very early meeting about providing climate information. This is somebody from another disciplinary area. And she said, don't ask me what I want, ask me what I do. Kind of consistent with what Bruce brought up and kind of consistent with this telling of stories that I was talking about. If you know what somebody's doing, then you have a much better idea of just where they're coming from. And it's really the start of a conversation that really has to go on for a while. And I mentioned at the end of my talk that even some colleagues of mine who've been working with very highly trained water resource managers, engineers, have had to have that conversation for not weeks or months, but years to really arrive at a situation where they understood each other well enough. And so I'd be reluctant to just direct them in any particular direction right away. I'd want to really understand what they do, why they do it, what's important to them, and where they want to go with that information before I could even determine what might be useful for them.
Thank you. Does anyone wants to add something to what Bill said, Bruce?
Just because there is this time imperative, I think one way to short circuit the process, not completely, but is to explore the question, what would change a decision you're going to make? What would change a decision you're going to make? What information would change a decision? Because that gives us, at least as a scientist, a focus to say, okay, I really need to go back and find this one particular thing that will change a decision. Because very often the science information will not change a decision. They're going to make the decision anyway.
Rasmus?
Yes, so we've had some experience with users. I was invited to a workshop with ecotoxers. Have you heard of it before? People are concerned about how pollution and shit is sort of taken away by rivers. And they invited me so that I could listen to them and talk to them and interact with them, and then be sort of integrated into their community. The same thing with health as well, or in, like Hydrological Institute. We have a lot. So we work with professionals, so they're not the ordinary man in the streets. So with professional networks, they tend to last longer as well. And many of these people are scientists themselves, but they're also involved in bureaucracy or governance as well. So that is a good start, because they understand the idea of uncertainty, and even may actually appreciate that we have a lot of numbers for them, but they want to understand what is the story behind the numbers, what weight should I place on them. And then they will see that there's a small probability that something might happen, but it's more likely that this will happen, for instance. And of course, you also have the cases like you have a storm, you have flooding that will actually, the aftermath of a storm is often worse than the storm itself, because it pollutes everything. It brings down the infrastructure. People have to boil the water. You have the water management. And these people also are used to weather, so they know what the year-to-year variations are. So we just have to blend into their community and talk to them, and then that way we'll understand what they need, but they also need to understand where the numbers come from, what kind of stories behind our results as well, because sometimes we can say something quite certain, sometimes we can sort of guesstimate, we don't know exactly. So yeah.
Yeah, so I'm a little surprised by comments that my esteemed colleagues have made. Sorry? Oh, come on, Bruce, tell us what you said.
Why am I not surprised?
Oh, I don't know. There seems to be this assumed that the stakeholders, the decision makers, are the static phenomenon, that they have these requirements. Whereas, we found, I've also been involved in let's call them interdisciplinary climate systems programs, probably longer than you, Bruce. And what we find very often is that one of the things that has to change is the decision makers' view of their decisions. For example, I worked a lot with infrastructure people, transportation infrastructure, and they start off thinking, well, we need a number, so just give us the new number. Whereas in point of fact, we can't give them the new number. And they had to actually adjust and rethink. And this took years, and this is a big problem in terms of, advancing things under duress. It took years. I've been involved in this one project in New England for at least 7 years, and it took years for them to grasp that they were really going to have to re-examine and really shift their decision-making protocols, because they couldn't get the same information that they use in current times. So I think it's understandable that part of the co-production or whatever is that everybody has to change. And I think we have to make that very clear.
Thank you. Maybe we can jump to another questions and I'm going to ask Chris, can we do against political decisions that are not useful for user? In fact, in my experience, no user wants SSP 126. I mean, they don't care, and we have to redo, because we don't have any military yet, we have to redo all the simulation of SSP 245, because this is what they want in addition to 370. So can
you? Short answer is I don't know, but let me. Yeah, so if we are told by policy that they want to have SSP 126 to consider, how do we mitigate against that? Perhaps for more relevant policy, what do we do? Yeah, and my answer was I don't know, but I'm going to blunder forth anyway, because it's never stop. I really think it comes down to what Bruce was alluding to in his talk about relationship. In developing strategic relationships with people in your country or in the community that you're interested in working with, and knowing that that relationship can last a long time. So
identifying who that is really important, because if you're going to work with the politician, it might be the wrong community, because the politician is going to maybe swap out in 4 years' time. So who is there beneath, who's working for that politician? So if you're a fan of yes minister or yes prime minister, then you don't work with the prime minister, you work with Humphrey. So it's identifying and so it's identifying the community who you want to engage with in order to put forward your thoughts and your ideas and your suggestions, and keeping that relationship hopefully over a longer time period. So my answer is going to be the relationship, that you've got to establish trust between yourself and whoever you're working with. And the second thing is to what Linda said. I am not going to do that. It doesn't push my buttons. I'm not wired for that at all. So it's knowing in your community who can actually do that. So it's not me, it's the type of person Linda was mentioning earlier. I'll give it to you then.
Yeah, that's an interesting point about, politicians are going to change. They're not going to be there forever. But an example of work we've done at NCARS is working with military bases. And at military bases, the commanders rotate out every few years. I think it's a crazy system, but that's the way it is. And so you really you have to deal with them because they are the decision makers for their bases ultimately. And so you can't get around the problem of short-lived leaders, shall we say.
Rasmus.
Yeah, I think I think you have some good thoughts, and I would like to add that one way to reach people is to talk through trade unions. And the reason why I say that is there's a trade union in Norway that's having a 150-year anniversary next year. So it's actually older than any political parties. It used to be a professional society. Now it's a professional society and trade union for civil engineers. And through that, it's because it is a force in society, a bit like the trade unions in Hollywood, right? And they understand the situation because these people are natural scientists and engineers. And through them, they have 100,000 members. You can actually reach society. So, and to have many voices together is much stronger than just one person. So using professional societies, using your colleagues, and everybody sends the same message that I think eventually sinks in much better than just a few academics.
Thank you. Anybody else? No. Bruce.
Just throwing, I think the question conflates information for policy and information for adaptation actions. And I think information for policy, there's often good enough from global warming levels or things like that. The details of which SSP and so on like that are less important compared to if you're talking to an engineer who's trying to decide the pipe lifetime that he's putting in for a stormwater system. And I think we need to be a little bit nuanced when we approach these requests from whatever the stakeholder is.
Bill? Something I wanted to add to this is there are oftentimes legal structures that can get in the way of things too. Years ago, I was working a bit with somebody who was involved with flooding issues in New York City. And he said, we are required to design for the 100-year storm. So in some sense, you're saying we need a number. And you could start talking about, well, we're not quite sure what that number is. Maybe we should think about getting around with it. But there's liability issues that come up. And his business could get sued and go out of business if they did not design according to certain standards. So that which edges into policy, but it's another nuance to all of this that has to be recognized.
I think that's actually a very interesting point, Bill, in that, the problem is that all of these different stakeholders and so forth are operating at the same time, but in different ways. And so, for example, insurance companies, for example, in Southern Florida, you can no longer get insurance. It's very difficult to get flood insurance at this point. So the insurers are reacting, but sort of in their own little world of insurance and not considering what will happen to everybody if they just withdraw the insurance. And so, I mean, this is an interesting problem about how all of these different entities have to be coordinated in certain ways for, let's say, just adaptation in Florida to actually work.
Okay. I think we're gonna have to move on for the questions. I don't know if the man from Pune who had a question previously for Rasmus is still there, and if he has the microphone, if he wants to ask his question to Rasmus. If you can raise your hand so we can see that you're there. No. By the time we can ask if there's some question from the audience here. Is he there? Okay, I think he's coming.
Yes. Good afternoon again. This is Mandira from Pune. Well, I think rich discussions as well as presentations that we've heard. One of the questions that I have is that we are using the term users, right? So, and that's quite loosely as users. So who are our users? I mean, a very basic question. And there were examples that were provided that interactions, for example, with women farmers or decision makers. But I think it's important also to keep in mind who our users are. I mean, broader society, yes. But I would like to hear from the panelists as to see where the intermediaries stand. I think example was given as a society, the various professional organizations, but what do you see as the role of the intermediaries in terms of really conveying that information to the, I call it the last mile or the beneficiaries that really require this information? Thank you.
You're welcome. Our main user is the Norwegian Climate Services. And the information that I presented is the basis of deriving more detailed information. And the users of the climate services would be typically hydrological institutes. We have most of our energy is produced by hydroelectric. So they're very much concerned about rainfall in the future, how to build, how to scale the power dams and so on. We have farmers and also people working on water management and also drainage. They want to know how to build and the drainage and also for water security. So, but it's mainly my focus will be mainly the climate services, but also the professional parties that I collaborate with. So we have collaborated with the Norwegian Institute of Public Health and hydrology mainly.
Someone else has to add something. Okay, Bruce.
I'm not sure exactly got the question, but make a comment that personally, I don't like the word users. I can live with stakeholders. I prefer partners. But I think from a WCRP perspective, because I heard WCRP mentioned, WCRP and us scientific community cannot do the last mile. We just do not have the capacity to do that. I mean, individuals can maybe do some case studies or do some project work like that. But as a community, we can't do the last mile. So we have to engage with the climate services community, as Daniela was talking about. We have to build relationships with the climate services community. So they better understand the science and we better understand the frontiers that they are facing.
Yeah, one thing I've been wondering about in this context is coming from the United States, which always promotes for better, for worse, a free market economy, is that in the area of weather forecasting, the U.S. Weather Service provides fundamental forecasts, but then there's a private sector that comes along and tailors those forecasts for individual users. And I'm just wondering if there would be some comparable spin-off with climate services. I'm not saying it's good or bad, but I'm just wondering if there would be some kind of a private market where people develop, you might say, private services directed towards special climate services based off of what the National Climate Service entity might be providing.
Well, yeah, I'd be very concerned with that model, Bill, because we have plenty of consultants out there who provide all sorts of climate information to people, and some of it is not very worthwhile, which is why I brought up the issue of the AMS program in which people get certified in a formal way to act as a go-between between the hardcore climate science and the stakeholders. And we tried that to get that program going a couple of years ago. And it was interesting because it failed because the AMS weather people were afraid that we would be taking shares away from them, which was kind of weird because they weren't doing anything in terms of certifying climate stuff. So we finally got over that hump. And so I think that's the kind of model I think we need.
Yeah, I just add on to that. I think that it points to a gap that we have at the climate scale that's present at the weather scale. There is a code of practice, a code of conduct, a code of ethics at the weather scale. It's absent at the climate scale, and we have no accountability at the climate scale. There's no, especially when you start talking trans-border climate services, there is no authority of accountability around that.
And at the risk of sounding like a broken record, the AMS program will include those elements. Yes, at the national scale. At the what scale?
Trans-border.
Oh, trans-border. Oh, well, that's a different thing.
Okay, time is running out. I'm sorry, because we won't have the time to take all the questions. I think there's one last from Pune, probably. And okay, then one from the audience, and we're gonna have to wrap up. Was there a question from Pune? If not, just. Okay. You can go, you can ask your question. No? Is there a question?
No questions.
Is there a question from the audience here? Yeah?
No.
Okay.
Yeah, thank you very much. I would like to come in here before we close, because I would like to make sure that we are state of the art in the discussion. And I really appreciated your comments. So I think it's really important to follow this field and to realize that the climate service or consultancy is growing exponentially, with or without knowledge. So, but this is worldwide. This is not only in Europe or only in the US or somewhere. It's at Boston Consulting level and PricewaterhouseCoopers, as well as in universities, as well as in spin-offs. So we have many, many activities along the lines, but we also have agencies here. There is a dialogue on the norming, ISO standardization of information for the services. There was a huge activity at the Climate Europe Festival last week about how much sense does this make and how much individual context is needed if you provide a good climate service. Which part of the climate services can be homogenized and standardized and can be made, let's say, more universal in order to make sure that a certain stamp or a quality assurance or an assessment at least gives you similar quality as for weather services, and which part is so context specific in guidance, in framing, in dialogues, where you cannot do this. So I think it's really important to understand that there is part of climate services is data, climate knowledge, climate projection, and what we discussed here. But a large part is social science. So the point is here that ideally, the climate service development should be guided and led and pushed for from the social science and humanities, not from us providing data. It's us supporting what society needs. So the last point I would like to ask you, and it would be nice if you get a quick round of comments. How do you envisage the engagement with social science in a way that they are in the lead and it's not us in the lead?
Well, why does it have to be one way or the other? I mean, I thought the point was to establish partnerships. And so, for example, in a number of the projects we work on, another term, I don't know how current it is in other parts of the world, but the concept of convergence, in which you are really coming together in that very equal way. The problem is, and that's very nice, we've had a very successful project working in the context of fires, which is a rather important topic, particularly in the Western US, for example. And we made incredible progress with the fire strategists, the fire people, were really taking the lead, and we were following them, let's say, for example, in terms of what do they really need? Well, the best thing to do was to really develop something for climate that was using a product that they were already very familiar with. And one of those is a pocket card. I won't go into detail about it, but we thought, okay, we're going to develop pocket cards for them, but about future climate, not just the weather. And, you know, that was incredibly successful, I think partially because they were so pleased that we were just willing to listen to them and spend the time, because this, one of my concerns about all this work is it is so time consuming. And, you know, it's like, I just don't see in which we can have a world in which every effort has to be something that takes 5 years, because we're all going to burn up by then.
So I think one of the things that RIFs can do, but just generally that I think I would like to put on everybody's conscience, is the scientific community is very easy to live in a bubble, to live in your ivory tower. And it's not so much the social side leading or the physical climate science leading. I think where the scientific community is lagging is the willingness to step out of the bubble and see the world as the others, as the stakeholders see it. We think we know how they see it, but honestly, we don't, because that acquisition of knowledge comes through experiential exposure. And I would love to see every postgraduate program, for example, involve some experiential exposure to the lived experience of the decision maker and build that across the generations of the climate scientists, because we too much live in a bubble. And RIFs, I think, can help on that side.
So you're suggesting that some of the climate people should be on the fire line?
Yes. Yes. It's risky, it takes courage, it's scary, but we need it.
Do you know what level of skill is required to be on that line?
You can start at whatever level you like.
All right, I'm going to stop there before we
deteriorate. Can I add something? Because I think your question is, doesn't quite suit Norway, because the climate services is part of Department of Environment, and also there's an environmental agency that owns it. All the climate adaptation is done in the municipalities. So the climate services is a network linking up to the engineers in the municipalities. So they work with the sort of municipality bureaucracy, and also together with the Institute of Hydrology, who decides where you can build according to flooding, rock slides, and so on. So it's very much sort of integrated into the sort of fabric of the civic society. We do have some social scientists too, but they are not really playing a big role. And then we, of course, have the communications people as well.
Yeah, I'd like to comment on this for a second, and I already allowed the session to run for more than 5 minutes. I know that we're running late, but I think we're getting now at the point where RIFs and CORDEX and, for example, the Lighthouse activity, Chris, what you're talking about, the academy, are at their connection points. Because the question is, wouldn't it make sense that the academy is getting enlarged by practitioners? So isn't that an aspect which is in addition to what you're currently doing, needs a bit more focus, for example? And how can we, from Linda's, and we have many, many other experiences which are kind of context-specific experiences, how can RIFs build on these experiences which are in CORDEX, in the CORDEX community, in a way that it can be fast, upscaled? So I think that's where we really have to push and try to find the linkages instead of continuing in bits and pieces. And I think that's something which I haven't really heard yet, and maybe we can think about it, and you can think about it in the next 2 days, and we can come back to this on Friday when we talk about the future. So, and say what you said, Rasmus and Bill, I mean, that's really, I think, yes, we all know this, but we have to go beyond and fast. But Samuel, it's your turn.
The last question to Samuel, please, quick, and identify to which panelist you address your question, please.
I think it starts from Bruce's talk on the inconsistency between GCM and RCM signal we can see in the atlas. And I can imagine that if we add the empirical and statistical downscaling, we will then increase the opportunity to have inconsistencies in the climate change signal. So do you have the first direction or advice or guidance to deal with such inconsistency that we have to face when we want to go from the data set to the society, information to society?
I think from a WCRP perspective, there's an opportunity to start the dialogue of getting all the core projects and the lighthouses and the participants talking to each other about how to do this. I don't think RIFS is in a position to answer that question. I think what we're in a position to do is facilitate the conversation to say, let's get a systematic approach to deal with this. Like CORDEX is a systematic approach to deal with RCMs. CMIP is a systematic approach to GCMs. Where is the community's systematic, coordinated approach to deal with that question? And that's where I think where we can make the initial start. So.
Okay, I think we have to wrap up because we were already 15 minutes late. Okay, so thank you very much, all of you. It's been a very inspiring session, and I say it because I think it, because I wouldn't say it. So thank you very much.
Would you please come in? We would like to continue so that we are done soon and can all go swimming. Without fun, there is no CORDEX. But there's a lot of fun without CORDEX. So could you please come in? Would be nice. So we will start the Flagship Pilot Study session, which is about the third last activity for today. We have the session now. Could people can come in, please? They don't want to come.
It's already on.
They will miss a very important part.
Yes.
So we have the flagship, then we have the posters. Don't forget the posters.
Clip it.
And then we have side event, I guess, in the program. But they will be announced after the end of this session. So I would like to ask the Flagship Pilot Study PI representatives, nice word, Flagship Pilot Study PI representatives to come up here so that we see how many you are. Erika, Tamas, Diana.
I don't know who is it.
Selvina, they don't want to talk with us anymore.
Sorry?
They don't want to talk with us anymore.
Okay, I will ask.
Marilaura.
Here.
So,
I would.
Flagship Pilot Study PI representatives. Would you please come to the panel? Okay.
Please.
Diana, would you please come up here? We want to start. Okay, I pass the microphone to Silvina and it's on you. Please go ahead.
Or this is microphone. I'm done. Okay, thank you. No, I'm on the microphone already.
Yes.
Okay. So thank you for coming back to the main room. We are going to start the last oral session here, which is related to the outcomes and insights from the flagship pilot studies. Flagship pilot studies is closer, but this is or this is. Oh yeah. Okay. So the session today is going to be one general introduction of insights from flagship pilot studies, and then we will have a panel discussion with the flagship pilot study PIs who are here on site to think about a little bit of the experience of this instrument, the flagship pilot studies, successes and things to change, to improve for the future. So I will quickly go through what these flagship pilot studies are. They were launched in 2016 to tackle emerging scientific challenges relevant for CORDEX. At that time, we were discussing the science plan for the scientific question, the main scientific question for CORDEX. And we realized that with the continental domain simulations, coordinated simulations, we couldn't look at the details of processes like the relevance of aerosols in the regional climate change signal, the new information we could take from the convection permitting simulations and all that kind of issues. So following a protocol, this flagship pilot study call was first announced in the I think it was Brussels conference in 2016.
And we had a series of calls for these flagship pilot studies. The first was in end of 2015, beginning of 2016. Then we have a second call in 18, 19, 20, and 21st. And up to now, we have 11 endorsed flagship pilot studies ongoing. Some of them are close to the end, but we have to define how to continue with these great networks that have been organized around these flagship pilots. So what I would like to bring here is a summary of lessons learned, for which you panel members will introduce more details, the emerging scientific outcomes and the way forward. So let me summarize what are these 11 endorsed flagship pilot studies we are running already. There are, I have clustered them in different topics. There are several on convection permitting modeling. And here in the map, you can see in which areas of the world they are running. We have in South America, Europe, and the third pole environment, and Lake Victoria in Africa. You have heard a lot about a lot of presentations in posters and in presentations during yesterday's sessions on results from this convection permitting modeling flagship pilot. And this is the list of the 4 ongoing activities around the issue of convection permitting. Then we have land use aerosols, the topic on how this land use changes and the inclusion of aerosol in the regional climate model may modify or modulate the climate change signals. So, and responding to that kind of issues, where there are 3 ongoing activities, flagship pilots. One is the one on the urban environment, another on the land use changes, and the last one on the role on natural and anthropogenic aerosols in the Mediterranean. They are flagship pilot studies over a given region, but anyway, the outcomes can be transferred to any other regions as well. And then we also can find some flagship pilots dealing with a diversity of regional Earth system models or model complexity, increasing model complexity, how the increase of model complexity shape the regional climate change signal. And we have 3 examples of those. One is focus on climate extremes in the Lake Victoria Basin, another on the role of air-sea coupling and small-scale ocean processes, and another one dealing with hydrological modeling for Canada and Mexico. This is the very new one. And then we have one flagship pilot focusing on the distillation dilemma of the climate information. And this is also a very new flagship pilot around the storyline framework for understanding climate hazards. And I don't see Melissa here. Melissa? Well, I hope she can later. So there are bunches of information on reportings and on activities of all these flagship pilots. They report to the CORDEX once a year to see how things evolve. And for the meeting today, we asked them, I mean, the CORDEX asked each of the flagship pilot studies PIs to prepare a summary report of lessons learned and key messages emerging from the experience each of these flagship pilot studies gain through the evolution of the time. And there are I have tried to cluster them into a few key messages and few lessons learned. But mostly, as you see, there is an imbalance among the different topics covered by the flagship pilot. We have several on convection permitting, so maybe the lessons learned are a larger number because they have been running for a while. So that's why I introduced here in this presentation a couple of important messages from those flagship pilots, which summarize that they have improved the understanding and representation of precipitation and related extremes with the convection permitting simulations. The convection permitting coordinated simulations show a reduced spread in the climate change signal, which is a very good outcome because it means that we can reduce the uncertainty on the future extremes. Then we realized of the relevance of improving the representation of cities in the regional climate models and the need for a global urban land surface data suitable for regional climate models, because each regional climate model have a different representation of the city. Some are just rocks, some has more sophisticated representations, and it's difficult to compare among them. So the idea behind this urban flagship pilot has to do with how to deal with cities to have a common understanding of how climate change impacts on cities. On the side of the aerosol forcing, the outcomes, the main outcomes of this flagship pilot is relating with the importance of taking into account the aerosol forcing in regional climate models. And I remember several years ago that one of the complaints of some global modeling community people was that they try to simplify the differences between the signals in the regional climate models and the signals in the global models, because the regional climate model did not include any aerosol forcing. And this flagship pilot is exactly focusing on that. And they show that the inclusion of the aerosol forcing may have an impact and an imprint on the climate change signal. Then on the land use changes, the group working with the flagship pilot study focusing on land use, the main outcome, or maybe it's not the only one, but one of the outcomes is that they have elaborated a framework to integrate land use changes consistently into multi-model regional climate change simulations, with the potential to transfer to different regions. Though they have been working over Europe, they have been working on how this can be transferred to other regions as well, dealing with the problem of the impact of land use changes. And finally, one key message from the most recent, one of the most recent flagship pilots has to do with the development of a strong science stakeholder relationship guiding the assessment of climate risks and environmental change. And this outcome is coming from the storyline approach flagship pilot over North America. This is a synthesis of lessons learned. Of course, the panel members here will have more to say, but I want to wrap up on key messages that were mentioned through all the different reports that the flagship pilot PIs presented to us. The key messages has to do with the inspiration of CORDEX. So the importance of having ensembles of regional climate models, the importance of community efforts. So it's not just one institution showing that aerosols are important, but it's a community effort with different scientists from different parts of the world, I would say. And it's not written here, but one thing that the flagship pilot studies also allowed or improved was the networking through the community. And I'm not only talking about the networking within each of the flagship pilot studies, but also the networking among the different flagship pilot studies. The convection permitting activities are one of these examples in which the lessons learned, but the one run in Europe was transferred and discussed with the other flagship pilots in order to gain from the knowledge already built on that topics. So, and I think this a transferability of knowledge among regions that has been emerging from the different flagship pilot studies is key and is one of the signatures of CORDEX. And the key message on this flagship pilot has to do with the data needs, which is something that is emerging all the time. For instance, for assessing the capability of these convection permitting simulations, we need high resolution data, which we don't have any in any areas of the world. For the land use changes, there is a need for good data on how land use have changed over the last decades. And I can give examples of all of these flagship pilot, which also highlights the data needs as an important pending issue. Okay, so I'm not going to go further in the detail, but now I would like to listen to the panelists. And we have prepared three triggering questions. The first one has to do with the successful, the nice part of the flagship pilot. So the question is, what, in your opinion, is the most successful part of the flagship pilot study you're leading or you're working on? So maybe we will not have time to go through all the panelists for each question. So maybe we can pick the first question for whoever wants to start with, and two panelists for each question, and a discussion would be fine. So whoever wants to go through this, thank you.
Maybe I can start just to break the silence. I think the most successful part was that the model could drain, really. We didn't know if the model were going to work. And when we started, I remember the first meeting we had in Trieste, we were really all working on a very, very dangerous ground, because most of us were just at the edge of testing the model, not having the right setting. The model was blowing up most of the time because we were going to very high resolution. There was the issue of the time step and the stability and all these kind of things. So I think if I think back to the first Trieste meeting we had for our flagship pilot study, I think we were really imply a big step to be done, but it was not really clear if we could make it.
Thank you, Erika. So, Diana.
Yeah, maybe I can shortly start with something what not worked at all, and then go further to what worked very well. So what worked not at all was the original work plan. So we were very ambitious. We had many objectives, and then we realized, okay, first we have to prepare the models that we can apply it for this question. We have to prepare data sets that we can put into the models. But in the end, I would say it was even an advantage, because often in many third-party funded projects, we have deadlines and we have to provide results. And here we could step back and relax and had the flexibility and we could say, okay, first we need to prepare this thing. Otherwise, we will not get the results what we need in the end. And so I would see this as an advantage. And I would like, if you allow, to highlight three really what I would call successes. So the first thing is here we have this very systematic approach related to a certain topic. So for example, on urban, on aerosols, on land, and and here we in this FPS activities, we could connect to the experts in those fields. So often we as regional climate modelers, we have to be multi-talents and we have to do everything and all parts to include. But here we could connect, for example, with land use modelers who brought in their expertise from their field and then combine this with a multi-model approach, really targeted to the experiments where we want to find out what is the effect of this specific part, what we investigate here. I think this really makes a difference. And this automatically then also leads to that we can provide robust results. And this is then important, of course, for societal applications. The second point is, so in our case, we very successfully transferred, or we had built a very successful collaboration with North America. Originally, it was planned only for Europe, but then due to the nice collaboration with Martin Leduc, who's coordinating this, and Olivier Asselin, who's here, and Dominique Paquin and others, so they applied the method we developed for Europe for their domain. And then we had several meetings and we got back a lot of feedback and experiences. And so this meant we could exchange. So what we started in Europe could be transferred to another region. And I think this is very efficient that we can exchange. And and one final point, it was mentioned several times before, the capacity building, and not only across regions, but also across generations. So we have young people and experienced people, older people that come together, and young people bring many new ideas, many new innovative things into these initiatives. Experienced people have the experience with the modelers, and they say, okay, here maybe you have to be careful. And this together, I think this brings us really a step forward. Thank you.
Thank you, Diana. So does anybody wants to jump in? Yeah, and yeah, please, Fabian.
Works like this. Hello, this is Fabien from the Aerosol FPS. So I think for us, actually, one key result was actually to show on the EuroCordex domain, actually, the importance of taking into account evolving aerosol and trends for the regional climate signal. Okay, so this has been quantified, notably on the temperature and surface radiation within the FPS. And this has led also to a design from the aerosol point of view, the new baseline protocol, so an input for the larger CORDEX community, because it turns out there are many regions actually with very significant trends in aerosol, Southeast Asia, East Asia, Southern Africa, etc. Okay, and so this is really a key message. With regards to your first point. Okay, then after maybe I'll tell you about the struggle we had and the impact for society.
Thank you, Fabian. We can jump to the second question in order to have time for the rest of the audience to intervene. So the least successful component of the flagship pilot. So Maria Laura, you want to comment on this? And what would you change knowing that you couldn't succeed on whatever you planned originally? Switch on the, yeah.
Okay. I think that the least successful part was the funding access. I think it was very difficult to, well, it was almost impossible to get funding to cover the complete project. we only get access funding from national agencies to cover some of the objectives. But well, one of the good things and that I wanted to talk about was the networking that was established. So that allowed us to access to other fundings for instance from Spain. We have projects together, bilateral proposals that we could apply to those proposals, and we get the funding to perform to carry out scientific studies that were very good and very successful. But I think that was the most difficult part of the flagship pilot to get the funding for the project.
Thank you, Maria Laura. Does anybody wants to jump in with this question?
It all went awesome and it went great. And there were no failures at all. No, I mean, I think one of the things that didn't go quite as we expected, but that actually had a seed for success in it, was that in our proposal, we were absurdly ambitious, and we also included the development of emulators in there. And this was in 2016. We all recognized at that time that there would be immense costs associated with these kinds of simulations, and even then that there was a need to develop alternative methods that could complement the dynamical downscaling. And I think even then, Klaus Gergen already had a really good estimate of the amount of storage we would need. It was and he was really close to being right. It's like ended up around 300 plus terabytes or something like that. And at the time, though, I think we were hopelessly naive on how much effort these emulators would actually take. And really, if it weren't for Sam and an unsuspecting PhD student, Antoine Dury, who you saw yesterday, who took on the challenge, I don't think we would have gotten much out of the emulator activity. But luckily, we did, and it's really laid the foundation for a lot of what you saw yesterday. So a challenge, but then a challenge that also has a happy ending to it. I would say one other thing that's not so much a failure, but that is also a challenge that I think all the FPSs will confront if they haven't confronted already, which is just kind of maintaining the momentum and maintaining the energy, because this is done quite a large amount on on kind of unfunded activity or basic funds. And that can be quite a challenge to kind of keep the momentum going, and especially that last mile. So getting the data ready to be accessible to all of you and to the broader community as well. And that has taken, I think, quite a bit longer than we initially anticipated. And but keep your eyes on the ESGF space. The simulations are making their way there now as we speak.
Thank you, Stefan.
And just to complement
Yes,
this, also the other things that was not successful was originally we planned to interact more with the GCM community. So we were thinking in our proposal to give back some feedback and eventually to help them to understand, RSMAP. But then this communication was basically not happening at any level. Not because there was not the willingness to do that, but because the amount of work that we had to do, it was underestimated in the beginning. So there was not really the space and time to also engage with this extra activity.
Yeah. Yes, Thomas. Yes.
Well, Thomas Alenka, Flagship Pilot Study on Urbanization or Urban Environment and Regional Climate Change. To be honest, our least successful part of our Flagship Pilot Study, which is still quite young, I would say, was the start itself, because it was actually during COVID time, and start just online without, say, having the luxury of real in-person meeting, discussing all the stuff that was really missing at the beginning of the activity. Let me return back actually to the first point, because despite of we are quite young, I would like to react on that was from the morning discussion, and that actually even in the proposal we already involved the communication and involvement of say urban climate group, which I would say helped quite a lot, and maybe even participated a bit on, for instance, modification or preparing option for using some urban classes, so-called WUDAP, to as the option involve implementation of urban schemes. So that's something which I would say was some kind of success at the really very young stage of the project.
Thank you. Yeah, please go ahead.
Yeah, so I'm sorry, I'm late. I was leading the flagship pilot study on Icrc interactions, and that was a bit weird in the sense that it was good to involving people from the ocean community, which is something that is missed and is not really, we don't have much weight in the CORDEX community, so that was a nice point. But also the least successful part of that is that as it was very difficult to have a common initiative funded or something that, as she said, we decided to go for more of ensemble of opportunities, saying, okay, the different groups have had their own interests, so we tried to let them to work on what they were working, and then trying to merge all the information so we can get something interesting from their work in terms of the pilot study. But then the problem was to find a motivation for them to still be involved and to continue working on that. So our experience is that it's much better to have a clear goal and homogeneous and common, and everybody working on the same goal is much better than trying to do as we did. It was not good in that sense. But the good part is that it allowed also to involve people from the ocean, as I said, and also opened, as we talk about that later, about new options to integrate CORDEX outputs into different societal needs. So
yes, I would like to jump on that issue, because one of the goals of the flagship pilot study was to answer societal needs. And so the question is, if you've done so, it's fine. But if you didn't, the question is, how would better integrate with society all these flagship pilot study discussions to provide a new piece of information? I'm asking.
So I think in our flagship pilot study, it was more about model development and proof of concept of what we thought the impact of explicit combustion could have on the representation of these extreme events. So from the beginning, in reality, in our proposal, there was not really a lot of engagement with the society, but it was more like create something, understanding something better that could eventually, of course, help the society. But like maybe thinking about the future, maybe every flagship should have at least one close connection with what is they want to bring to the society with their study. But this part, I don't think we touch it, and it was not really, I think, maybe the time to do this, because it was really more physical study.
Yeah, of course. Thomas?
Well, concerning this, I could say that we got some nice present from Stefan, actually, in the Icrc project, the Impetus for Change project, where actually we can use some activities of the project as a real proof of concept of, say, connection to society, so that demonstrator city within this project. So that will be actually a nice combination of the flagship pilot study and actually funded activity from EU.
Yeah, great. Yes, Fabian.
So actually from the aerosol and maybe more largely the atmospheric chemistry also point of view, the obvious links are like, the link with air quality. First, which can be also crossed actually with the problematic of your urban environment, like different stressors, like heat and air quality, for example. What is the impact of that? And also because emissions, chemical and aerosol emission are really a part of, socioeconomic activity. So it's really an interactive component of the system, which is now treated as, as a forcing. Okay, but perhaps, there would be some way to be more interactive also between the climate change and like the emission adaptation, the emission feedback, let's say, going via the socioeconomic pathway. Okay, so that could be some ideas for the future.
Yeah. Yes, Diana.
Yeah, so I think to ensure the societal relevance, it starts already with selecting the FPS. So in which efforts do we put our energy and our resources? So we have to set somehow priorities, and we cannot do everything. And if we here have this as an important criterion, that to answer this question, there are many questions from society and how to approach this. If we consider this, I think we can ensure this from the beginning. And the other thing is, really to make the results, the data available, and not only in the data banks, but really to provide meta information, to provide additional information so that the data is really usable in the end, to follow the FAIR principles and so on. I think that's very important, because then also the other communities can use the data, can bring in their expert knowledge, so that it feeds also back into this community. Thanks.
Yeah, thank you. I have another question, which is not written there, but it's on the air. And how we continue, or do we continue with the flagship pilots? How you see the future of this instrument that has been so important for CORDEX, for understanding different topics that we could not even assess with the current model? So how do you see the future of this instrument, the flagship pilot studies? And this is open for the audience as well. So do you want to start, and then we open the discussion to the audience? Or Stefan, please.
I think that we've seen clear benefits to these flagship pilot studies. They've given us insights that have made their way, for example, into our protocols for CMIP6 downscaling. That example would be the aerosols flagship pilot study. The FPS and convection over the Alpine region has provided, I think it's the world's first multi-model ensemble of convection permitting simulations for climate change. That's what we wrote, at least. So yeah, it must be true. That's how it works, right? And also in some ways set proof of concept that these, while there are many things that we still need to understand about these simulations, but that if they're used responsibly, they can form part of a well-constructed climate information stream. An example of how this is done would be the way it's being used right now in UKCP, where they're very clear about what you can and cannot use these very, very high resolution simulations for, and that they undersample the uncertainty, but that they're very useful for understanding changes in extremes, for example. And so I think in that respect, they're extremely useful and have been and can continue to be. And we should find a way to continue supporting these, especially for other parts of the world that are demonstrably more exposed and more vulnerable to the effects of climate change, and where information is currently lacking. And some obvious candidates to this are like the FPS right now over the Tibetan Plateau. And then you can think of other regions as well where it's used, where this really needs to be done. Elvig is another good example. On the flip side, if I'm to play devil's advocate, is that it's immensely time consuming and challenging, and it takes a huge effort. I'm consistently amazed at the amount of effort and amount of work that everyone has put into our, and grateful as well, the amount of effort that everyone has put into our FPS. But I do question whether or not that's sustainable, that kind of effort is sustainable in the long term, especially when that is placed on top of the CORDEX writ large program, and the desire to continue that as well, where we're providing downscaled information over all of the land regions of the world. So there's a balance to be struck there, and I don't have clear answers. I think that's something for the community to grapple with.
Yep. Over there, you?
Yes, I agree. And I also think we should think about for instance, in our flagship pilot in South America, we created and a community was integrated and the networking was very good. And it was created through this flagship pilot. So I think that we think about how do we sustain this networking once the flagship pilot ends, because this is an effort, a very large effort for all the community, the regional community, the smaller community, and also the cross-domain communities that we create that networking with other institutes from other countries and other domains. And that is really good for the regional community. And we should think about that, how to sustain the networking.
Yeah, thank you, Maria Laura. Please.
Yeah, I agree that the FPS are very nice when they start and also when they finish. So because I think it's important to have this, because if, as they say, is really a huge effort to try to keep this track. But then it's also a good tool, I think, to keep all these satellite people, all these network that maybe they have no possibility to work on the core simulations or to develop coupled systems or whatever, but then they can open the door to a lot of applications. In our case with the marine applications, I mean, we are talking about marine biologists, or there are some fields where we can provide CORDEX data there that are really not accessible right now. So I think it's a good tool to involve them in scientific questions that make them part of the community, even if they cannot have the label of core simulations.
Yeah, fully agree. So, Samuel, come on, yours.
Javier, pues, I want to make a question to the panel. For those of you who have worked with high resolution downscaling, what kind of advice would give to CORDEX to move forward to in terms of data availability, data that is has quality and credible, reliable? Because many regions don't have enough data that is in high temporal resolution and high spatial resolution. So I think this is a big setback for doing this kind of coordination. So what would you advise us to do?
To look for the data, because I think you do have the data. It was a big effort for Europe, at least, to find this data in the beginning. When we started, we really didn't have, for example, many of hourly data set, because one data set was not ready, the other one was not perfect. We had to do, but this kind of effort, it was good for the model development, but also for a lot of data
data set development, because, for example, we had to look at many data sets, homogenize them, and try to use as much as possible. So I think if you want to start this effort, you can use this effort also for improving the data quality in your own region, because I believe that the data can be found, not in the equal amount for every region, but there was also a lot of work done on the data during this experience. So it's a positive things also, positive feedback.
So from some feedback from our side. So in the group we have in Toulouse, we really enjoyed the FPS. So it's a space of flexibility, freedom, innovation, and then after an FPS, your tool has been improved. Yeah. So it's a really good tool, I think, within CORDEX. So I hope we will keep it. One question for me, there is one comment, which is how the FPS feedback to the main CORDEX domain protocol. It's something that was not, I think, thought initially, but we need to create this link. And I have a second question is, do we want to keep FPS geographically focused, as most of the FPS are today? Or do we want to expand to multi-area focused FPS that in theory would be very good, but I'm not so sure that in practice this will be an added value for the FPS. So I don't know what are the opinion of the panelists on this.
Let me first say that this is something that we are already discussing within the scientific advisory team, CORDEX SAT. But we wanted to hear your inputs and to move the discussion forward and to include your thoughts on this, because what you are pointing out is very, very relevant in terms of not focusing on a region, but focusing on a process and see how different regions react to any particular tool to understand how that process behaves. So absolutely.
Hi. Yes, Eleni Katragou, University of Thessaloniki. I have a short answer to Samuel's question. And I don't have a question for the panel, but a big acknowledgement to the work that all the FPS leaders have done. I'll talk first as a co-coordinator of the dynamical downscaling activities of EuroCORDEX. And to a huge extent, our European protocol has been based on the outputs of several FPSs. The most mature one proved to be the aerosol FPS. And special thanks personally to Fabienne, who worked so hard on producing a data set available for all European CORDEX modelers that is heavily used for the evaluation simulations. So if it wasn't for the FPS aerosol and all people working around it, we couldn't have had this new protocol, updated protocol using the evaluation of, evolution of aerosol. Also, the FPS Lucas has done a tremendously good job by providing a coordinated data set on land use changes for the 21st century, which is used for, it was too complicated and too early to make it mandatory for European production CORDEX simulations. So we decided that it's better and more safe to keep this as an FPS activity and not introduce it in the standard production simulations of CORDEX. But the results will be analyzed separately, and I'm pretty sure that a lot of interesting outcome will come out of it. And of course, it's the urban FPS, which is a very important one and very promising, still quite early to be implemented in the protocol, but it has some years to run, and I'm pretty sure, well, that will give very, very interesting results. So thanks to all of you for motivating the community and doing an tremendously complicated and difficult work. Also, another very, very important aspect with respect to the FPSs, and I'm talking now more as a university professor, is that gave a floor to a lot of early career scientists like postdocs and PhDs and not only working on a very state-of-the-art topic like the FPS's themes, but also to create networks with other CORDEX participants, which is also very important when you're in such an early stage of your career. So that was an excellent opportunity as well for the early career scientists. And I had another point, which I forgot, the third one, but I think it's already enough for what has been done. And thanks to the leaders and also to all the participants of the FPSs making this happen.
Thank you, Eleni. Yes, Thomas.
Well, just comment concerning the Sam's second question. That I think that we should be open for both actually going to geographically interests where there are some, as well as we can go following the processes. And that actually our flagship pilot study on urbanization was actually from the beginning built up as say inter-domain flagship pilot study. We had at the beginning about 30 partners, and 1/3 was actually out of Europe. We have active groups from Latin America, we have active groups from Asia, China. So, and there are actually even some newcomers to the flagship pilot study. So there are actually definitely topics which can be really inter-domain oriented, and that might be actually strictly just geographically oriented topics.
Yeah.
My question is related to integration with society. I think in the first step, the CORDEX community in this flagship project identify that what stakeholder they should focus. Like in the last panel session, there was who is the end user. So that's very important. Like I'm working on climate change and health. So then you will identify that what the requirements, if initially you focus on 4 or 5 area, and then you can prepare the data accordingly, because the data challenge is very high, especially in these projects, like if you go in very high resolution. So data downloading and then even the processing for the end user, it will be a big challenge. So what area till now, what society stakeholder you identify so far?
So I'm gonna push back a little bit on this requirement, because I think we shouldn't try to be all things to all people, and I think we should be realistic about what we can accomplish and what we can set out to do. I think the links to the stakeholders really come in the downstream and depending on the FPS, of course. If there's an FPS that's specifically set up to address this, then yes. But like in our instance with the convection FPS, it wasn't well tailored to answer stakeholder practitioner questions, and that comes after the fact, and it has. And as Tomasz mentioned, we have a Horizon Europe project now that is now using these tools to generate local scale information for a variety of practitioners at the municipal scale, basically. So I think it really depends on the kinds of questions one wants to answer with it. And I don't think that, if it's something focused on like process understanding, I don't think you should try to shoehorn a stakeholder element into that simply because that's, because we have to, or because we should for some reason. But I think it's something we have to think about carefully. And it's not going to be appropriate for every FPS, for example, and it may be more appropriate for others.
Okay. Is there any question from Pune?
Yeah, is there someone from Pune?
Maybe they already left the room. It's too late for them. Yeah. Yeah, they are not there anymore. And I would like to add to the discussion that the knowledge that is emerging from these flagship pilot studies needs to be transferred as well, because now we are talking about global modeling at kilometer scale, and they never went into that arena, and you did. The EVE initiative, that they are planning this kilometer scale, multiple models with coordinated thinking, and we have already go through this path. So I think we should be clever enough to position how CORDEX has gained in knowledge to integrate that knowledge to other communities. So I think it's important. And Daniela wants to jump in. Yeah.
I would like to come in here. Thank you very much. I would like to mention the EVE initiative again, which Björn mentioned yesterday. And this also goes to what Samuel said. The idea in EVE is now to start with pilot activities. And the EVE goes from the global modeling, number crunching, to the AI use to develop products out of it, to the dialogue and transfer. And the prototype pilots, they are currently discussing, or we are discussing, because we were part of, and Krishnan and many others from CORDEX were part of this dialogue in July, are physical processes oriented. So the pilot regions they would like to look at are the monsoon regions. I can't remember, there were 3 or 4 of them. I think one was about the food production, food basket region, and so on. So, and the question I have here is, can we get prepared with our, I say, smaller domains, which are smaller than the continental standard domains? So with some domains which coming out of FPS, can we be prepared to be the benchmark for those global simulations, which will come soon in some of those regions? So I think the idea is to either create an FPS-like thinking about this, create the dialogue, but also think about what you also said, Teresa, look on some physical processes with smaller domains. I think it would be really good to get prepared for the request, which I'm pretty sure will come, because this pilot initiative, I think that's something which they won't let go. So that will happen. If the big thing will happen, we will see. But the pilots for the next 2 years, and they are in the next 2 years, so we cannot just wait for the next conference. I think that is important to see where you could jump in with your experience.
Absolutely. Yes, Erika. Thank you, Daniela.
I think one easy evolution to answer to this question is that given the fact that now our model are raining, we could envisage a flagship focus on the monsoon. So the domain for convection permitting over the monsoon region could be like identified, and then we can, of course, move forward and look at the monsoon. But then when you think about the monsoon, then there is also the other component that the coupling with the ocean is important. And as we have seen in one single model study that we have been doing with our model, then having the ocean interactive coupled with the model is also something that, we should have 2 different pilot study, one looking at the contribution of the explicit representation of the convection. So see if, for example, we are still doing good at this scale with this kind of process that are much large scale like the monsoon, but also in the same time, see if we can set up something for the coupled model in those regions.
Yes, Thomas.
Well, I would say that some kind of parallel activities to flagship pilot studies in CORDEX we have exist even in the global scale, and for instance in destination Earth, Destiny, digital twin. They are some, say, pilot projects actually which are going to some specific issues, specific topics. For instance, actually what I know, because it's went through me or through my participation in Icrc project, that is actually initiative on urban environment as well, actually even from that global destination Earth activity.
Thank you. So please. Go ahead.
For example, if you have the direct effect of the aerosol, then will affect on precipitation of the region. And if you have indirect effect, you have effect on the rainfall. Aerosol very important. And you have the role of aerosol on the atmosphere. For example, you can get how much warming or cooling due to aerosol. And the geographical distribution is very important. For example, if you got dust from the desert, you have the different type of aerosol. If you get aerosol from the desert region, like black carbon, organic carbon, and the ends of aerosol. So we think in the region, and we think in the range of aerosol, size distribution of aerosol of this region. Thank you.
Thank you. So maybe Fabian, do you have to comment on this?
Yeah, okay, so thanks for your comment. And it's true, like when you think about aerosol, actually, you can think region, but you can think also process. You can think monsoon a lot. You can think microphysics, interactive aerosol now, I think will be the way to go, right? You know, because it could give to some different kind of interaction with regard to a simple prescribed monthly climatology in some region. So, in fact, you know, I have no clear idea what should be the future, because the problem is like, you know, if you go multi-region is of course to get the robustness of multimodal assessment on the same region. So that's a lot of things. On the other hand, you get more participants and you can discuss very interesting stuff, you know, depending, for example, of the type of aerosol absorbing versus diffusing, etc., in different regions. So scientifically, it's exciting. Okay, but then you don't get, you know, maybe as big ensembles. So I really do not know how to answer this question, and this will be discussed in the parallel session tomorrow, D9. Right. There will be free drink and free aerosols.
Thank you. So Teresa, I think it's the last question, so we wrap up. And
well, actually, it's a comment. Yeah. We haven't heard much about the ocean, but since Erika mentioned the ocean a few minutes ago, I wanted to make a comment, and I think it is time for the CORDEX community to get the ocean modeling people engaged. And tomorrow afternoon, after lunch, we will have a D1 session in the Oppenheimer room in Leonardo. So we hope to see participants because we know that the ocean is very important. Every time now we hear about the ocean heat waves or the sargassum or many factors that are affecting not only circulation but also the aquaculture and biogeochemical features of the ocean. So it is very important to, I think it is time to include the ocean modeling.
Thank you, Tere. In order to have time for the posters, we are already 12 minutes delayed. I would end this session now. I would like first to thank all the panelists. And we can tackle on this on Friday discussion as well. Now, Jason has some announcements for all of us. Thank you.
Yeah, just a quick reminder for all the ECRs. We have the ECR event on tonight. It's down at Adriatico House, which I'm told is about 15 minutes walk away or so. If you want to go down together, we'll meet outside the Leonardo building at 5:45 and walk down. And the last reminder is for the SAT members. We have a meeting up the front here right now. Okay, that's it. Thanks, everyone.
And there is only one more thing. We are trying to make a photo tomorrow, after or before lunch. We don't know, but please tomorrow be here for the photo. Thank you.
I'm also told the other side events are down in Adriatico House as well.